So I want us to look at this momentum and impulse question. Guys, I'm here to bless you with maths. Ne? Yeah, I'm here to bless you. So I just want to help you guys to stop donating maths. Ne? So yeah, I'm here to massify you of it. I'm the word mass in the word massive. Okay, so I want us to look at this question, and then we're going to try and answer some of the question from this question 4 of November 2024 paper 1. They say that trolleys A and B, trolley A has mass 1.5 and B has 2 kg, and then they are held in a stationary position. Okay, so now we don't have friction because they say this is a frictionless track with a compressed spring between them. So the trolleys are released and the spring takes T seconds to return to its natural length. Then what happens is that the spring then falls to the ground. When the spring falls to the ground, trolley A moves to the left, as you can see the arrow there. Let me quickly point out that part. So from the arrow here, you can see that, okay, it moves to that direction, and then trolley B moves to the right. So, and then trolley B will continue going up an incline that is frictionless, and then to a maximum vertical height of 1.5 meters as shown. Okay, so one thing that I need to note, I need you guys to understand something here. Né? So I'm going to point out some of the things before we start working on the questions. Né? So first thing first, let's talk about the mechanical energy, because maybe we can do for B for that, but it's fine. We can also talk about the change in momentum. Okay, the change in momentum. So I think everyone now understands that if the object is at stationary, what is the change in momentum? What is the initial change in momentum? I need you to tell me what it will be the change for this part. What will be the P initial, the change in momentum equals to? Because this is not moving, this one it will be 0. The initial one it will be 0. But since this one is moving, then this tells you that the other side will going to have the change. But you'll see when we do questions, okay? Okay, let's dive into question and see what we need to do from this one. And they say that ignore the effect of frictional force. Or the effect of the wheel. I always like when on vertical projectile motion when they say ignore the effect of frictional force. Write down the principle of conservation of mechanical energy in weight. It says that the total mechanical energy. To answer this, the total 4.1, the total mechanical energy. Or if you don't want to say the total mechanical energy, you can revert this as the sum of gravitational potential energy. You can say this is the sum of Fg, gravitational potential energy. We add its energy and what? Its potential and what? And kinetic. Right, kinetic. And we said that these two, according to the principle conservation of mechanical energy, when they are in an isolated system, isolated system, it has to remain, remains constant. I'll explain why. Why is that the case? They remain constant. Or if you don't want to say constant, you can say there is conserved. You know? Right. So what is this principle saying? What is this principle saying? So basically the principle is just telling you that the change in momentum before the P initial, it should be equal to the P final. That is what this thing is telling you. Okay, that's an easy mark. So you also have the definition on your exam guideline. 4.2, they ask you to calculate the speed of the trolley at the bottom of the inclined plane. So please only focus on that. B. Only focus on B, and then. But before that, let's go back to that 4.1. Remember, we are saying that the law conservation of mechanical energy. This law, guys, it focuses on what? It focuses on the fact that the total kinetic mechanical energy of an isolated system, it remains constant, right? So this tells you that the mechanical energy, when we talk about the mechanical energy, we are talking about the sum of what? We are talking about the sum. We are talking about the sum of the potential and the kinetic energy. Okay, let me not. I think if I say this, let me remove that, because this is going to create so much confusion. Right, let me just remove that, because it's going to create so much confusion. So we are talking about the sum. When we say mechanical energy, we are talking about the sum of kinetic and potential energy. So you see the definition that I just gave you, and normally this definition is usually explained there. Energy, it's only examined if the law of the conservation of mechanical energy is used to answer the next question. So when you see they ask you that question, just know that on the next question, you'll have to apply that to answer the next one. Okay, so this is 4.2. So 4.2, we need to use that law, the one that we defined. So we need to apply the law. That's how you're going to approach the question. So to apply the law, the one asks to calculate the speed of trolley B at the bottom of the inclined plane. Okay, let me write the formula that we need to focus on this 4.2. The formula says that the total mechanical, okay, I can say that the total mechanical, so, or let's say EMEC, for E for energy, and for the total mechanical energy at top. This will be equal to the total mechanical energy at bottom. The total mechanical energy, EM, at bottom. I think everyone can see that we don't have much space to work on now. We don't have space to do this question. So I'll just move down here. So now, to write that formula, we said that this will be the total EM at top. We equate this to the total EM bottom. Okay, so let me just write. I know that the mechanical energy is the sum of potential energy plus EK. So this one is for the top one. We need to equate that to the sum of EP plus EK, and this is the bottom. Right, let's just do the substitution. We know that EP is mgh. We're going to add this with EK, which is the kinetic energy. It's half mass times the velocity squared. So we know that this is for the top part, and this will be mgh. We added that with half times the velocity on bottom, and this is for the bottom part. So point A, okay, let's say this point here is my bottom, and this point for point B, this is my top. So now I'm just going to focus on substituting what I know. I know that the V final here is 0 because Once it reaches the maximum height, the final velocity will be 0, and we are looking for V initial there. So let's just substitute everything. So what is the mass? We are focusing on trolley B. And the mass of trolley B, if you go back to the statement, the mass was given as, 2 kg. So I'm going to substitute 2 kg. So this will be 2 multiplied by 9.8. 9.8, and then remember this is for top, right? We need the height when trolley B is at top. So the height when it's at top, it's 1.5 meters. So I'm going to sub in 1.5 meter. Right, I see, guys, we wasted so much time explaining that law. Let me try to move fast. Then I'm going to say we add 1 over 2, the mass is 2, and we know that the velocity at top, is 0. So this will be, I'm just going to sub in that at 0 squared, which makes everything to be 0. Then we go to the bottom part. The mass is still 2, 9.8. And what is the height at bottom? The height at that point is 0 because it's still on the ground. So this will be multiplied by 0 plus 1 over to the mass of 2 and V squared, which is the one that we are looking for. Okay, so to simplify this question, I think we can agree that we just have to say 2 times 9.8 times 1.5 and see what you get on your calculator. So let me quickly also put that on my calculator. 2 times 9.8, and this is multiplied by 2 times 9.8 is multiplied by 1.5. And what is that equals to? 29.4. So this will be 2 times 9.8 times 1.5, 29.4 plus 0. It's equals to 0 plus. So we can see that the 2 cancels here. So this will just be V squared. So I just have to square both sides to make V subject of the formula. Therefore, what is the velocity? It will be the root of answer. So this gives us 5.4. If they say round it off to 2 decimal, please, that will be 5.42. And that's your answer, 5.42. So the answer is 5.42 meters per second. That's the velocity that they want you to calculate. So now they said that for the t second, that the spring takes to turn it to its natural length, calculate the change in momentum. So now I think you know how to calculate this one, right? I think you know how to calculate the change in momentum. So to find the change in momentum, we know that to answer this 4.3, the change in momentum, the formula for change in momentum is the mass times final velocity minus the mass times V initial. They said for trolley B, you just have to just substitute what you know, right? So if I write this, I know that the change in P is going to be equal. So I think this is easy 3 marks. The mass of trolley B is 2. And then we know what is the final velocity, which is what we just calculated. So the final velocity, it was 5.42. Then this is minus the mass times the initial velocity. Okay, so remember, initially, they said calculate the change in momentum for t second that the spring takes to return to its strength. So this is before the trolley B goes up. So we need to consider before and after the spring is released. So this tells you that this is my V final, which is 5.42 now, and then my V initial this time is 0. So to find a change in momentum, I'm going to say this is mass of 2 minus 0. So therefore the change in P is going to be the 2 times that 5.42. So this will be 2 multiplied by 5.42, which gives us the change in momentum of 10.84. Right, so this is 10.84. 10.84. Okay, so there is another way that you can use to calculate the change in momentum. I think it's best if we also talk about this. So, but if I do this, maybe this might even cause more confusion. So guys, let me say something. This answer is for when you choose, what? Right as positive. Okay? So if you take right as positive, that will be the answer, the change in momentum. So, right, if you choose left as positive, you're going to get your answer as negative, which shows you that the momentum is going to the right. I hope this makes sense. So for now, I'm just gonna stick to choosing right as positive. Then the last question, they say that write down the change in momentum of trolley A. You see, so the change in momentum. Okay, they want us to write the change in momentum for trolley A. Okay, since the linear the total linear momentum, remember the total linear momentum of an isolated system. This is where I made the mistake. When I say somewhere here I wrote this is equal to that. That was a very big mistake. I was talking about the total linear momentum, and the question wanted the conservation of mechanical energy. So I was confused on myself. That's why I removed that formula. So now you understand why I had to remove that formula when I said this will cause too much confusion. So now for 4.3.2, to find the change in momentum of trolley B, remember that the total linear momentum of an isolated system, we said, is going to be conserved. So this tells you that the change of the trolley B is of the same of what? It's of the same magnitude, but in an opposite direction with the change in trolley A. So if you calculated the momentum here as 10.84, this tells you that the change in momentum for trolley B will also be 10.84. So this one is right because we set right as positive. So this will be 10.84. And then the direction of this. So the most important thing they want to see is the direction. This one will go to left. Please note that. So this one is just the same answer, but the difference is the direction. This one is right, this one is left. So they need to see that left on your answer. Okay, let's work on the last one there. Write down there. Oh, calculate the speed of trolley A after t seconds. The speed of trolley A after t seconds. I'm not sure if you know, but we can use that change in momentum to find the speed. Calculate the speed of trolley A after t seconds. The speed of trolley A after t seconds. And what is that t second? We said that where is the statement where they're talking about t? Okay, the trolleys are released and the spring takes t seconds to return to its natural length. So I can use the change in momentum to answer that 4.4 question. So I'm going to say that the change in momentum for A, they said I am looking for the speed of trolley A. So I'm going to use the change in P for that A, and then it's equal to mass of V final minus mass of V initial. So maybe I can just rewrite the formula and say this is M into V final minus V initial. But now I know what is the change of that trolley A. We just calculated that to be 10.84. But now let's talk about the direction. Okay, let's talk about the direction. Remember, we set right as positive, and if this is right as positive, so right as positive, look at this. The change in momentum for trolley B is the one that is going to the right, but the change in momentum for trolley A is going to the left. So when you substitute it on the equation, you need to put it as negative to show that it goes in an opposite direction as the change in momentum of trolley B. Then I'm going to equate this and say the mass of this is trolley A, it's 1.5. If you still remember, it's 1.5. And then we are looking for the V final. So I'm going to say this is V final minus V initial of 0. Remember, we started from rest. So it's going to be V initial of 0. And then what's next? So this is just negative This will be negative 10.84. It's equals to 1.5 VF. And then divide both sides by that 1.5, divide that by 1.5, which gives us the final velocity of negative something. So I'm going to take that answer there, the 10.84, divide that by 1.5 and see what I get. 7.23 if I round it off. 7.23, that's my answer. So my final velocity should be negative 7.23 meters per second. So remember the 7.3, it tells us that trolley A moves to the left because we set right as positive. As you can see on the diagram, trolley A is moving to the left. So I'm going to say, therefore, V final is equal to that 7.23 meters per second left. And that's it for this question. I hope you guys had a great one on this one. Right. So, and that's it for this one. This is where we're going to stop for this question because we've answered everything on this question. And I'm really sorry, guys, that we wasted so much time on that 4.1. Okay, now let's look at this question 2. This has to do with Newton's second law. So we have a crate P of mass 1.25 kg, and it's connected to another crate Q that has the mass of 2 kg. So the two crates are placed on a rough horizontal surface. A constant force of magnitude 7.5 acting at an angle theta to the horizontal is applied on crate Q. As shown in the diagram, the crate accelerates 0.1 meters per second squared, and this is going to the right. So crate P experiences a constant frictional force of 1.8. So I'm going to indicate that on my drawing. Okay, so the crate P frictional force will go in an opposite direction. So this is my frictional force, and they say the frictional force is 1.8 newtons. Then crate Q experiences a constant frictional force. So this crate will have a frictional force that is equals to 2.2 newtons. State Newton's second law. Okay, so to state this one, I'm going to state the Newton's second law using the formula that says F net is equals to ma. This is the Newton's law formula. It says that when a resultant or a net force acts on an object, okay, so it says when resultant or a net force, when a resultant or a net force if it acts on an object, we say the object will accelerate so it will accelerate in what? In the direction of, it will accelerate in the direction of the force. So, but now the acceleration is going to be directly proportional. Guys, I'm going to finish this definition by writing it in symbol. The acceleration is directly proportional to what? To the net force. So acceleration is directly proportional to F net, and we are saying that it's inversely proportional to the mass. So the acceleration, it's inversely proportional to the mass. Right. So directly proportional means that if the net force increase, the acceleration also increase. Inversely proportional means that if the acceleration increase, the mass decreases. You see something like that. Okay. But you can also use your exam guideline, guys. I don't like to stress on definitions. You can just define it using your exam guideline. Okay, so now 2.2, they want you to draw a label free body diagram for crate P. So I'm going to indicate all the forces that are acting on KP. We have a tension going in that direction. We have a normal force acting up, and then we have the FG perpendicular going down. And then look at this. The mark allocation tells you that this is 4. You need to indicate, to answer this 2.2, you need to indicate how many forces? 4 forces. So this is your Fn, and this is your Fg. Then there's a force that goes in that side, which is the tensional force. And the last one in an opposite direction, that's your frictional force. And you'll definitely get the 4 marks. Okay, 2.3, calculate the magnitude of the tension in the string. And to calculate the magnitude of the tension in the string, I'm going to use Newton's second law, right? First thing first, write down there 2.3.1. Say F net is equals to MA. Okay, then when you have the F net is equals to MA, you need to, they say the tension in the string. They want us to calculate the tension in the string. So look at this. If I have the frictional force, okay, so it's going to be easy if we use the crate P, because crate P has only 2 forces. I can't use crate Q. Crate Q will make everything to be more complicated, because we have the horizontal force, we have the frictional force, the tension and the frictional force. So for this crate Q, if I draw a free body diagram, this will be my Fx, this will be my tension, and also my frictional force. So I know that I have 2 unknown, which is Fx. I can't find Xx because I don't know what is angle theta. I can't find Fx, and then I can't also find I can't find tension because I have 2 unknown. Tension and the Fx, the horizontal component, unknown. So I'm not going to use crate Q, but crate P, it will be easy for me to draw a free body diagram on that, indicating the horizontal forces. This is my tension. Then I have a force going that side, which is my frictional force. So it's easy to use crate P because only 2 forces are acting on that crate P. So when I say F net is equal to MA, I'm going to choose direction. Direction of the motion as positive. So right as positive. Then I take all the forces that are going to the right. I subtract all the forces are going to the left. Equate this to MA. Okay, so now I'm just going to do my substitution. They set the tension for that crate P, it's 1.8. So this will be, we take the tension, we minus the friction, which is 1.8. 1.8, this is equal to the mass we are using, crate P, which is 1.25. The acceleration was given, I still remember on the statement, it was 0.1 meters per second. So I'm going to say this is multiplied by 0.1 meters per second. Then now what will be the tensional force? We're going to say this is 1.25 into 0.1. Then take the 1.8 to the other side, it becomes positive 1.8. The answer that you get, that will be your tensional force. I'm just going to try and put that on the calculator. So this will be 1.25, 1.25, close the bracket, 0.1, close the bracket, then we add 1.8. This gives us the tensional force of 1.93 if we round it off to 2 decimal places. That's your tension. Easy, 4 marks, né? Right, tensional force 1.93 newtons. Right. Then the last question of this one, it says they want you to find the angle theta. Okay, so the angle theta. So to answer this question, the angle theta is the angle between the horizontal component and the applied force. And we know that we use this when we do the Fx. So what is the Fx? Horizontal component. Then it's a horizontal force. You're going to draw a free body diagram for that horizontal, for all the horizontal forces that are acting on that plate Q. So when I indicate them, I'm going to have the Fx to the right, the tensional force to the left, then the frictional force to that side. So if I say F net, it's equal to MA. I'm going to say I write as positive again, write as positive. Then now I know that I need to take my Fx minus the tensional force minus the friction equate this to MA. But if you still remember, if I have the applied force like that, and then I'm going to have the force going up, which is my Fy. So I'm going to say I am looking for Fx, which is my eigency, and I have F, which my hypotenuse. So according to SOHCAHTOA, I have eigency and hypotenuse. This will be the cos of theta. So now this tells you that the cos of theta is equal to eigency, which is your Fx, over hypotenuse, which is F. Therefore, multiply both sides by F. What is your Fx equals to? So the formula for Fx is F, the cos of theta. So I think everyone already knows that. So where there's Fx, I can substitute F, the cos of theta. We minus tension. Do we know what is tension? Okay, it's fine. Let me just do the substitution first. Let me just rewrite everything, then I'll do the substitution now. So F cos theta, do we know the applied force? The applied force is given as 7.5. So I'm going to put in this as 7.5. And then the cos of theta, then I'm going to minus the tension, which is what we just calculated. The tension as 1.93. So I'm going to minus 1.93 minus the frictional force of crate Q, and we said is 2.2. So I'm going to minus that 2.2. Then I'm going to equate this to the mass of crate P, crate Q, which is 2 kg, times the acceleration of 0.9. 2 into 0.1, not 9, 0.1. Therefore, this will be like, okay, let me say 7.5, the cos theta, and see what is this equals to. So this will be the cos of theta. This will be equals to, I take these two guys to the other side. So basically, this will be 2 into 0.1. Then we're going to add 1.93. We add 2.2 and see what is that equals to. Okay, we're going to take 2 into 0.1, and then we add 1.93, then you add 2.2. Then this gives us 4.33, right? So this tells us that this will be 4.33. Then now you can divide by that 7.5 on both sides. Divide by 7.5 on both sides. What is the cos of theta equals to? So the cos of theta is equals to, we're going to say answer divide by 7.5. This gives us an answer of 0.577. So it's 0.577 and so on. Therefore, theta will be the cos inverse of that 0.577. What is theta equal to? The cos inverse of answer, because I don't want to round off. The theta is 54.74 rounded off to 2 decimal place. Theta is 54.74 degrees. That's the angle theta. And that's it for this question. This is how you collect that 13 marks. Easy, right? So I'm very sorry about the Newton's law definition that we did not manage to finish the definition, but it goes like this. When a resultant or a net force acts on an object, the object will accelerate in the direction of the force. The acceleration is inversely proportional to the net force, and is directly proportional to the net force and inversely proportional to the mass. That's the definition. And I want us to work on the next one, the next question. Okay.
Hi there, welcome to Spark Genius Academy with Polite. So thank you very much for joining in on the lesson, and we're gonna work on this past paper. If this is your first time watching our lesson, please make sure that you hit that subscription button so that you can get a notification when we upload the next lesson. Please trust me, you don't want to miss the next lesson. So on this lesson, we're going to work on Newton's law. This is question 2 of your question paper. If you're doing grade 11 or you are in grade 12, this is the best lesson for you. So let's look at this question. We will try to analyze what we are given on the question, and we'll take everything step by step. Okay, so they say that we have block A of mass 3 kg. It's connected to block B of mass 6 kg. So we can see that from the diagram. And now the 3 kg block is the one that is on inclined, and it makes an angle of 30 degrees with the horizontal. And block B is pulled by a constant force to the left, as shown in this diagram. And we are given also the acceleration of the blocks. So both of these two blocks will move with the acceleration of 2 meters per second to the left. And the first question, which is 2.1, they want you to define the term kinetic friction. So the kinetic frictional force is the force that opposes the motion of an object. Okay, so this is the force that opposes the motion of an object. You can also consult your exam guideline on the definition. The motion of a moving object. So in order for object to have a kinetic frictional, the object needs to move. A moving object with what? With relative to the surface. And if you give them this definition, you'll definitely get that 2 marks. Right, that was 2.1. Let's look at 2.2. 2.2 says that the kinetic frictional force acting on the block AB. So we are given, I'm just going to note this down. What are we given? The Fk for what? The kinetic friction for block A. It's given as 4.3 newtons. And we are given the Fk of what? Of B. And it's given as 7.2 newton. So now on 2.2, they want you to draw the labeled free body diagram where you will be showing all the forces that are acting on block A. So which one is block A? The one that is on inclined. So the block A, first let's draw the vertical component. Remember, if I have an object on inclined, this object is in contact with the surface, so it will have what we call Fn, the normal force. Then it will have the weight acting down, so this will be my Fg. So this is what we know so far. We have the F, which is the normal force. This force is acting up because it should be perpendicular with the surface. Then there will always be Fg acting downward. This is Fg. I'm not going to include the components, Fg perpendicular, Fg parallel. No, I won't include the components. So this force is moving up. This tells you that the frictional force will act downwards. So this will be my Fk. Because it's moving, I'm going to call it Fk. So let's include this, which is the force that is parallel to the incline. So we have the tensional force that is acting up there. We have the tensional force. So this tells you that we only have 2 parallel forces. So this will be my tension. And you'll definitely get the 4 marks by showing them all those forces. Okay, let's keep moving. The next question, 2.3. 2.3 says that they want you to calculate the magnitude of the tension in the string. So, ladies and gents, I need you to work on this type of questions in this way. look at this. They want you to calculate what? The tensional force. Remember, the tensional force is your horizontal force. You're gonna first draw a free body diagram indicating all the horizontal forces. Right, so we're gonna have my tension going up, and then we have the frictional force, which will be my Fk going down. So look at this. Are these the only forces that are acting on the object? The answer is no. So this is where most learners make mistake. Each and every time when they do calculation, they forget to include the Fg parallel, the weight that is parallel to the surface. So we need to make sure that on our calculations we include the weight, which will always act downwards. If the object is moving up, the weight goes down. If the object is moving down, the weight goes down. The Fg parallel will always act downward. Doesn't matter if the object is moving up or down, it's always point downwards. So when we have, these are the only three forces that are acting on the object, and we are looking for tension, we're going to apply the Newton's second law, which says F net is equals to ma. Okay, so now I'm going to choose direction. I know that this is accelerating up, so I'm going to take up as positive. This tells you that all the forces that are going down will be negative. So I can say my F net will be the tension, which is the one going up, subtract my Fg parallel, subtract my Fk, equate this to ma. So by writing this down, ladies and gents, you already have a mark, right? So they'll give you mark for any of this formula. You'll definitely get a mark. So already by writing down the formula, something that you never gonna get it wrong, you have a mark. 1 mark down. 3, how many marks to go? 3 marks to go. Let's work on that. So now remember, Fg parallel, if I'm working on something, if you still remember, the formula for Fg parallel, it's equals to, for the fact that you are watching this lesson where we are doing past paper, I'm going to assume that you already know that the Fg parallel, the formula for Fg is mg, the sine of theta. Please, if this is the first time you see this, make sure that you keep it in mind that Fg parallel is mg, the sine of theta, and Fg perpendicular, it's equals to mg, the cos of theta. Please don't ask where is this formula coming from. For the fact that you are watching this lesson, you are preparing for an exam, so we don't have time to do the basics. What you need to know is that this is your Fg parallel and this is your Fg perpendicular. I'm not going to talk about the things that we don't need yet in this question. So let's go back to this other side. So I'm going to say this will be the tension. We minus mg. We said Fg parallel is mg, the sine of theta. We're going to minus the Fk of what? The Fk of, we are working with block A, right? We are working with block A. So the Fk of block A, then equate this to ma. I'm going to explain why we chose block A. This was the first thing that I was supposed to tell you, which block to choose, because remember the tension is the same. So the reason we chose block A is that we don't know what is F, so finding F will be more complicated if we don't have the tension also. I hope this makes sense. Let's keep the ball rolling because we have a tension to find. Let's do the substitution. Remember it was given that the Fk of what? If you can check on this problem, it was given that the Fk of that block A, it was 4.3. So I can say this is my tension minus the mass of block A is 3 times 9.8. The sine of that angle, this angle here, the sine of that angle is 30. So this will be the sine of 30 degrees. You minus the frictional force of block A. It was given as 4.3. We equate this to the mass times the acceleration. Remember, the acceleration was given as 2 meters per second. So this will be 3 into 2. So the only unknown term here is tension. So I'm just going to put that on the calculator and see what I get. So this will be 3, close the bracket, into 9.8. And then this is multiplied by the sine of 30. Right, equal sign. So the answer that we get, remember, we need to subtract that 4.3. So minus 4.3. And this gives us 10.4. So this will be 10.4. Okay, so this is minus 10.4. It's equals to 10.4. It's equals to 3 times 2, that's 6. So I just want to make sure that we did everything correctly here. Okay, I just want to verify something here. We said this will be, let me say this is minus inside the bracket 3, and this is multiplied by 9.8, and then this is the sine of 30. Then we minus the 4.3. Oh, this is negative 19. So this is negative 19. So we did a mistake when we punched the calculator, because now when I get an answer that I don't feel it in my blood, I need to check something, because like sometimes you can feel it in your blood that normal, there's something wrong that I'm doing. So the 10.4, I did not feel that 10.4. You know why? Because I know that 3 times 9.8, look at this, 3 multiplied by 9.8, look at what you get. You get a very large number, which is 29.4. Then the 10.4 normal, when I multiply 3.98, I know that we get a very large number. Then it will be sine 30, it's half. So half of that number we minus 4.3, you understand? So let's go back and write this down. We got negative 19. So it's 3.98 is 3 times 9.8. I think you guys get the idea, times the sine of 30. And then we minus that. Remember, this is negative. Okay. Just gonna put this inside the bracket. Let's minus that 4.3. I'm just doing this to help you practice how to get this right. So this will be negative 19. So let's work on fixing that mistake. So this is negative. Okay, I'm just gonna write down this is negative 19. It's equal to 6. Therefore, what is my tensional force? Tension is equal to 6 plus 19, because the 19 will go to the other side, which will give us the tension of 25 newtons. So when you have it like that, let's see how many marks you're gonna get. How are they going to mark this problem? So for this correct substitution here, there's a mark for that, and for substituting the acceleration, there's also a mark, and the final mark will be for finding your tension. That's how easy the question is. So let's look at 2.3.2. Now they want the fourth F. The first F, it's on block B. This is where we're gonna put our main focus, block B. Yo, I'm having so much fun. I hope you are also enjoying this on your side. So this is very nice. I like nice things. So this is block B, and then we need the force that is on block B. I need you to draw the free body diagram indicating all the forces that are acting on that one. We have the tensional force going in that side. We have the force going in this side. So this is my force. But there's one thing missing then. What is that? I need you to pause the lesson and try to answer me and tell me what is the force missing and in which direction is that force moving. I heard you saying frictional force, and you are very correct. It's frictional force. So the frictional force is what? That will be Fk. it will move in an opposite direction as the motion. Remember, this is going to the left, and I'll refer that left as positive. Now let's use Newton's law to find the answer. Oh, this is nice. So Newton's law, F net, it's equals to ma. So we're gonna take all the forces going to the left, we subtract what? All the forces that are going to the right. So this will be minus the tension minus the Fk. Ladies and gents, there's something that we call negative positive marking from 2.3.1. so if you got your tension wrong, you're gonna get what we call positive marking, because there's no way you're gonna get the 2.3.2 correct if this tension is wrong. Because first thing first, you'll have a mark for substituting those formulas. For writing down the formulas, you already have a mark. Nice. So we know what is tension, we know what is the kinetic friction of B. If you still remember, we need to use that kinetic friction of B, which is 7.2. Let's do the substitution. So F minus the tension, which is 25, minus that 7.2, it's equals to the mass of block B, that's 6, which should be multiplied by the acceleration, which is 2. And now I'm just going to use my calculator to find what is that negative 25 minus 7.2. And this gives us an answer of 32.2. So this will be negative 32.2. So this will be F minus, what is this? Come on. 32.2, it's equals to 16 times, oh, it's 6 times 2, that's 12, right? So we just have to bring the 32 to the other side to be positive. This will be 12 plus 32.2, and when you add the 2, we get the force to be equals to, let's see that. So it's 12, we add 32.2, this gives us an answer of 44.2 newtons. 44.2 newtons. And this is your answer, and I'm happy with that. I'm just gonna collect the marks. Let's quickly work on how they're gonna mark the work. So you'll definitely get, you see, to substitute an acceleration is very important, and this was just 3 marks. For that acceleration, you'll get a mark, and you'll also get a mark for the final answer. Last question, ladies and gents. How will the acceleration of the block B change if the string breaks? Choose from increase, decrease, or remain the same. Guys, how will the acceleration of block B change? Look at this. I think this, I know that some of you guys, when you answer multiple choice questions, you just say anyone that you feel like, maybe just do guesswork. Oh, I like letter D because my name is Dineo, then I'll go with decrease. No, it doesn't work like that. I'll go with increase because my name is Itumeling. Today's my lucky day for that 1 mark. Doesn't work like that. Ne? You need to make sure that you analyze the question. Please don't do guesswork. And because you're going to say, it's just 1 mark. So if I'm lucky, I'll get that mark. If I'm not lucky, I'll definitely lose that mark. Yay, you are donating marks. And this is what we need to prevent. Look at the block beam. It's on inclined, and it is pulling by what? It is pulling by a 6 kg block. So if I cut the spring, what will happen to the acceleration? Where will this accelerate? It will accelerate downward or upward. Where will this accelerate? So they're saying that how will the acceleration of the block be changed if the string breaks? So I think that block A is moving because of the applied force that we apply at block B. So I'm going to say the acceleration of block A, it will increase. Why? Because it will move down, and the more it goes down, the more it increases in acceleration, in velocity. I hope you guys understand that. So for this one, I'll go with increase. So my 2.4, it's increase, and they don't want you to give them any reason. So tell them increase, then they'll be happy to give you that mark because you deserve it. Ladies and gents, that's it for this lesson. If you found this lesson very helpful and you enjoyed the lesson, make sure that you hit that subscription button, and by joining the family, I'll definitely make sure that you feel at home. And guys, I'm looking forward to see you on our next lesson. Trust me, you don't want to miss the next lesson. Multiple choice question you are failed to, and if you can look at this. Okay, let me tell you about me on the multiple choice question. I used to get 20, all the marks. I used to collect all these 2 marks. You know why? Because nginenkani. Guys, now, like, I won't allow to get a question wrong while I have the answer on the paper. The answer is there. I just have to find the correct one. I'll never get that one wrong. Let me teach you how to answer a multiple choice question. Let's start with the first one. They say that we have 3 vectors. 3 vectors act on an object so that the resultant force is 0. The resultant force is 0. So what I need you to understand is that for 3 forces to have a resultant force of 0, guys, we're going to take this step by step, and I'll try to move slow now, because now I can feel that I'm overexcited and already I'm moving fast. Né? So let me try to slow down. So the resultant force, for 3 forces to have a resultant force of 0, right, they must form a closed vector triangle. So these guys, they must form what we call a closed vector triangle. I know that someone watching the lesson now is saying that Sir is trying to say head to tail. Yes, you are right. That's what I'm referring to. A resultant force is 0. The 3 forces, they must create what? A closed vector triangle using a head to tail. Not tail to head, but head to tail. Right. So now, another thing that I need you guys to understand, this means that number 1, when we say how do we form a closed vector triangle? Each arrow must start where the previous one ends. So each arrow must start where the previous one ends. I'm not going to write that down because we're going to waste time. Or maybe, you see now, each arrow must start where the previous one ends. Very important. So now, the last vector must bring you back to the starting point. Okay, that's number 1. That's point 1. Point 2, then we say the last vector must do what? Must bring you to the starting point. Starting point. Right. So let's start and check these vectors, because to create a closed vector, we say 1. Each arrow must. What is this? Each arrow must start. Where previous one ends. So I'm going to choose, they say which one of the following represent, they said which one of the following vector diagram is the correct representation of the 3 forces. Remember that I'm saying to get a resultant force of 0, we need to create a closed vector triangle. What is a closed vector triangle? We know that each arrow must start where the previous one ended. Let me say this one starts here, then it moves up, then look at this arrow. So now, as you can see where the arrow of that one is, it is meeting with another arrow. So can you see that the arrow of this one doesn't start where the arrow of that one ended. So option A is out. We move to option B. Option B, this one starts here, then it goes up. This is where it ends. Then this arrow starts here where that one ended. Yes, that's what we are looking for. We move that, then this is where that arrow ends. But look at this. Two arrows pointing on the same one. So option B is out. Remember, each arrow must start where the previous one ended. Right, because if I have an arrow like this is my starting point and this is my ending. So each and every arrow must start where the previous one ends. Let's go to C. Look at C. C starts here, then it moves up to that point. Then look at this. This one is head to head, it's out. It's not head to tail, it's out. So this leaves us with D. So this tells us that D is the correct answer, but let's quickly verify that. Né? So this one, it starts here, which is my starting point, then it ends here. And then the second arrow, it starts here, starting point, and this is my ending point. And this is what I need. Get in. It's a ding ding ding. So now when I go to this one, what is this? This one is my starting point for that arrow, and this is my ending. Therefore, the correct answer is D. That's how we answer that question. I hope you guys are happy about that. So this tells you that A, B, and C, they don't form a closed loop. Some vectors are not connected head to tail properly, so they are out. Let's move to the next one, 1.2. Two large objects P and, they say two large objects P and R, each of mass M, we can see that on the diagram, are placed with their centers R apart, as shown in the diagram below. They expect a gravitational force of magnitude F on each other, and then now the mass of R is increased to what? To 2m. So the mass of this one now is 2m. It is increased, and the objects are now placed so that the distance between their center, the distance is doubled. Guys, if you watched my previous lesson on electrostatic force, you know how to answer this question. Right. So we said that on that lesson. Remember that the force, the electrostatic force, is directly proportional to what? To the charges, and inversely proportional to the distance between them. So now I'm going to write this. I said that if they want you to use the charges and the distance, we're going to say F is directly proportional to the charges, which is Q1 and Q2, and F is inversely proportional to the distance. So now let's substitute. I'm going to name this as my Q1, then this will be my Q2. So Q1 is just M, so I'll just substitute M. So this is F. Okay, let's write this down. F directly proportional to Q1 Q2 over R squared. I'm already having much fun now. We're already on multiple choice and I'm enjoying the lesson. So this tells me that you are also having fun on your side. So it's a ding ding ding. Okay, so Q1, what is Q1? Q1 is just M. Let's substitute. Multiplied by, what is Q2? Q2 is 2M. Then this is divided by, in fact, you know what I'm going to do? To make this simple, let me write this in this form. Let's say I have my Q1, which is M, and then I have my Q2, which is 2M. So this tells me that this is just Q, and this will be 2Q2. Let's substitute that. So this will be Q1, it's just Q1. But Q2 is doubled, so this will be multiplied by 2Q2. Divide by what? R, it's 2R. So the value of R, I'm just going to substitute that as 2R, which is squared. So what do we have on top? I'm gonna write this as 2 of Q1 times Q2. What I did, I just moved the Q in front. Then this is divided by 2 squared, it's 4. Then I'll have this as R squared. So now I'm going to move the 2 over 4 this side, multiply that by the Q1, Q2 over R squared. Look at this. I know that this part here, this part here, it's my F. So if that part is my F, now what is 2 over 4 equals to? This is 1 over 2 times, we know that this is F according to the formula. Can you see that? So this will be F. So you're going to check on your multiple choice which one is 1 over 2F is A. It's a ding ding ding. So now that you get this one, everything is good. Né? So that's how you answer a multiple choice question. Let's move to the next question. Right, this has to do with vertical projectile motions. The velocity versus time sketch graph below is for the motion of a ball that is projected vertically upward from the top of the building. So I'll start by making my own drawing. I have a building that has the height H, and this will be my ground. Let me explain what's going on. This is you, the grade 12 learner. You are standing on top of a building, then you project what? A ball vertically upwards. So it will move up, it reach a maximum height, then it comes back down to the ground. But now, there's something that we need to note. What happens when the ball hits the ground? It's going to bounce back. But it won't bounce back to that maximum height. No, it will bounce back and reach another new height, which is lower than that one. It will keep on bouncing until it stays like at rest, stationary. So guys, let's look at this graph. They say that this is projected from the top of the building and this is my max. I know that at max V, it's equal to 0 meters per second. Let's write that well because this is important. The max, at max, the velocity is 0. At max, the velocity is 0 meters per second. So now the question says the ball reached its greatest height above the ground. Which one is the greatest height? Which one is the greatest height? We need to check the greatest one. Is this one. It should be above the building. You see? Above the building, this is my greatest height. So now they say at a certain time, which point on the graph corresponds to this greatest height? You need to be like very good when it comes to this because we know that, okay, the ball will go up the moment that you project something up. Né? The moment that you project something up, the more it goes up, it reduces in velocity until it reaches what? The maximum of 0. So can you see that it will start here and move down and then it reaches the maximum of 0. So the velocity here is 0. Why? Because this line here, you see this line where there's arrow, it's our point reference. Our point reference. Right. So at the point reference, the velocity is 0. So now we know that this point Q is our max height. So now they say which point corresponds to this greatest height is just Q. So the correct answer will be B. So now what happens to the ball? The ball, the more it moves up. So this tells you that we take up as positive. So this graph, when they draw, they considered up as positive. So then this part here, it's when it's going up. Then you see this part here. Because now I'm already explaining in case you do calculations. Né? So this part here, it's what? It's negative. So this is positive because the ball is moving up. This is negative because the ball is moving down. And we have up as positive. Why? It reaches 0, then it starts moving back. So I'm going to name this on my graph. This is point P. Okay, let's use a different marker so that you guys can do. You see, now I get too much excited. Now I'm explaining a lot of things on this 1.3 question, but this is going to help you there. So now this is P, point P. It moves up to point Q. Then it will come back to the same. It will pass through that same height and move what? Then it's going to hit the ground with a certain velocity. And when it hits the ground, this will be my point R. Then if that's point R, the ball will start moving up. So this tells you that this part here, we said that this part here is positive, and this part here, it will be negative because it's moving downward. Then it will start going up with positive. So this is where it's going to start going up. So what I need you to understand is that this point here and that point here is the ground, and this one is also the ground. Right. So it will hit the ground, reach another max. Why do we say this is max? Because the max will be at what? So this is from this will be S. Why? Because at X the velocity is 0. This tells you that this one is at maximum, then it will come back down. I hope this makes sense. But the most important thing is for you to understand how we got B. We had so much, I think I explained a lot of things for sure. Now you already forgot how we got B there. But please just try to go back on the lesson and understand how we got the value of B. Right. And there we go again. This is 1.4. So let's see what we have on 1.4. 1.4 has to do with what? It has to do with inelastic. So now they say, what are they saying? Two hard objects collide inelastically in an isolated system. You see, I underline the most important words. So, in an inelastic collision, right, I'm just going to give you guys this here. Let's say this is inelastic. Right, so this is inelastic collision. And then on the inelastic collision, this is in what? In an isolated system. Isolated system. What do we know is that look at the statement, which one of the following is correct for this collision? Both momentum, look at this guys, remember I'm training you how to master multiple choice question. Both total momentum, I'm going to underline momentum, and kinetic energy are what? Conserved. Both total momentum, kinetic energy conserved. Total momentum, kinetic energy conserved. Total momentum, kinetic energy conserved. You see, we have like same ways appearing each and every. How are we going to know if this is which one is the correct one? Then I know someone is going to close their eyes and say where I land my hand, that's the correct one. They just gamble with these 2 marks. Easy 2 marks. No, we need to collect that. Né? So look at this. First thing first, we're talking about momentum. I know that I'm going to talk momentum. Then you write total momentum down. We know that total momentum. Remember, we are talking about inelastic. So the total momentum is what? The total momentum, this one, it's conserved. So we're going to say the total momentum is conserved. Right? That's what we need to know. The second one, in an elastic, total kinetic. Total kinetic. This one is what? The total kinetic, not conserved. Right, I'm going to use this to answer the following question. So look at this. I'm going to eliminate some of the options. Option A, both total, for the fact that they said both, total and kinetic energy are conserved. This one is conserved, this one is not conserved. Look at the statement that I just gave you. In an elastic collision, we said total momentum is conserved, but total kinetic is not conserved. So this one is out. Option A, out. Let's move to the next one. Neither total nor kinetic energy is conserved. We know that the total is conserved, this one is conserved, but the option is saying none of them are conserved. So option B, out. The total momentum is not conserved. So for the fact that they said total momentum is not conserved, while we know that the total momentum is conserved, it's wrong. Option C, out. Then option D, the total momentum is conserved. Yes, I agree with them on that. But the total kinetic energy is not conserved. I agree with them on that. Then this will give me the correct answer as D. It's a ding ding ding. Get in, guys. We are having so much fun. I'm enjoying that. I wish you guys can see my excitement. Let's move to the next question, 1.5. Before we move to 1.5, let me give you something, guys, so that you don't maybe get like confused if they try to switch this question, because you might be lucky and they bring it like this again. So let me give you something that you can remember. This is a quick exam tip. Right. So elastic solution, collision, because in this multiple choice they asked you about what? They ask you about inelastic. Let me tell you about the elastic collision. So the inelastic collision, momentum plus kinetic, let's call it KE, kinetic energy. When you add these two, they are conserved. So when you add the two, kinetic and momentum, both of them, when you add them, they are conserved. Right. Then in inelastic, so this was for elastic. So inelastic, collision, only momentum, only. So only momentum conserved. I think, guys, when I say plus, it's maybe someone might be confused. So instead of saying plus, let's use and. So momentum and kinetic energy are conserved in an elastic. So in elastic, so in an inelastic, momentum, only momentum is conserved. So in an exam, they might change the statement. Instead of saying inelastic, they say elastic. Please pay attention on that. Get your weapon ready. Wait for them. That if they change this thing, you're going to ding ding ding. Yeah. So let's work on this one. Engine P has a great maximum power output than engine Q. Yo, I really like this type of questions. So they say that engine P has a great power output than engine Q. So remember, power is equal to the work done over time. That's the formula for time, for power. And they say engine P has a greater maximum power than engine Q. That's a statement. Which one of the following statement is correct? When P and Q each operate at their maximum power output, Q does more work than P in the same amount of time. P and Q do the same amount of work in the same amount of time. P and Q, look at this. It's all about more work than same amount than, you see? So now let's try to find the correct statement. So in order for you to find the correct statement, you need to understand this statement that says engine P has a greater maximum output than engine Q. Let's try to analyze that. Okay, so now what they are saying is that if engine P, I'm just going to tell you that if engine P has greater power, because that's what they told us on the statement, than Q. What can we say about that? So this tells you that P is the one that is going to do, okay, B does what? The same work. P will do the same work in less time. That's what you need to understand. Or you can say P does more work in the same time. Or let's say P does more work in the same time. So you just have to do vice versa. Look at this. If it's same time, P is going to do more work. If it's less time, P is going to do the same work. I hope you guys understand that part. So Q does more work than P in the same amount of time. Remember we said P is the one that is more powerful. So here they are saying Q is the one that is doing more work. This one is out. Then P and Q do the same amount of work in the same amount of time. So we have same, that won't work, because we said if we have same time, there will be more work. If there is less time, there will be same work. So we have same, that won't work. Then this one is out because of same amount of time. Same amount of work, same amount of time. That one is out. So P and Q do the same amount of work, but Q does it shorter timer than Q. So remember we said Q, here they're saying that P and Q, they do the same amount of work, but they say Q does it in a shorter amount. So they are trying to say that Q is faster. Q is faster. So if they say Q is faster, this tells us that Q is more powerful. So they are wrong. P is the one that is powerful. This one is out. So this will leave us with the last statement. P and Q does the same work. So they do the same work, but P does it in a shorter time. So the correct one is D. Look at this. P does it in less time. So the correct one is P. So exam tip for this one, you know the best way to do this. Just know that more power, it equals to faster work rate. Yo, I can't believe that we're wasting we're not wasting so much time on multiple choice. We are learning, right? And that's it for this question. So let's move to the next one. So they say that the absorption of a spectra of the same element surrounding both star A and star B are observed from Earth. The spectral lines for star B are more red. Okay, so I'm just going to analyze because I see something here. I see something very important. I'm just going to analyze that. B are more redshifted than those of star 8. So when we say something it's more redshifted than another one, this tells you that for B, more shifted, it tells you that its light is shifted toward the red. So its light, the light of B, is shifted towards what? Towards red end. Guys, when it says is shifted towards red end, what is this meaning? This tells you that this has a what? It has a shorter wavelength. Oh, not shorter, but long wavelength there. So this will have a long wavelength. Don't worry, everything will make sense now. So this tells you that since we know that C is equals to frequency multiplied by the wave. So if the wave increase, the frequency decrease. Okay, so the wavelength, if the wavelength increase, what happens to the frequency? For example, look at this. I can arrange this and say lambda, which is the wavelength, it's equal to C over F. Can you see that the wavelength is directly proportional to C, but inversely proportional to F? So if the wavelength increase, so if this goes up, the frequency will decrease. Right. So what are they saying? They are asking that, okay, but before that, let's conclude on the information that we have. We know that the frequency of B, remember they said that this one is shifted towards the red, and we said it's going to have a long wavelength. So since it has a long wavelength, it's going to have what? A shorter what? A shorter frequency. So the frequency of B, what is the frequency of B? Is lower than of A. That's what we know so far. Right. So that was, we used the shift, the red shift, and then now remember we can also do this with the speed. We are done with the frequency. Now we know that the frequency of B will be lower than A. So now let's talk about the speed. Let's talk about the speed. We are done with this column. We're going to be able to choose which one is the correct. Let's talk about the speed. So the speed, remember, if they tell you that this is more rate shifted, if it's more rate shifted, this tells you that the star is moving away faster. So the star is moving faster. Star is moving faster. I'm just gonna write faster. The star is moving faster. So since the star is moving faster, now we know that they said B is more rate shifted. So this tells us that B, what can we say about B? Has a greater speed. So B has a greater speed. B has a greater speed than A. Guys, I know this is so much information. Try to pause the lesson, go back, collect the information that I'm giving you. So what will be the final answer? We said B is going to have a frequency. The frequency of B will be lower than. So on this column, we need for B to have a lower frequency. So I'll just tick the column that has lower. Then we said that B will have what? Will have a greater speed than A. So the speed of B is greater. Then you tick all the columns that has a greater. So now look at this. The column that has 2 ticks is your correct answer. Which one is it? C. Guys, this is how I used to find. This is how I used to get 20 on multiple choice question. But I think it also has to do with understanding the theory beside the topic, the concept. Okay, it's fine. Let's move on the next one. Let's see what we have on this one. 1.7, guys, are we going to spend an hour on this? Come on. It's okay. It's okay, because remember, I'm not just using the memo and tell you that the answer is B and you don't understand why the answer is B. I need to make sure that I explain where is that answer coming from. So I'm afraid this lesson is going to be long. But if you need to collect the marks, sit in on the lesson. Let's finish all these questions. Can you see how nice the questions are? Look at how nice the questions are, and I'm going to make sure that by the end of the question, you know how to answer all these questions. Okay, let's go back and work on that question that we are currently doing. Let's go back on that question. Let me see, this was 1.7. They say that R and S are two small charge spheres placed distance apart. We can see that, okay, we can see that. And then they say that P is a point to the right of sphere S. We can see that also. And then ER and ES are the electric fields at a point due to the charges on sphere R and S respectively. We can see the diagram. Which one of the following combination is correct for the net charge on the sphere? Okay, so I'm just gonna try to analyze what we are given. They say ER. Okay, let's not analyze what we are given. Let's just go straight to the answer. Let's just go and answer this. So look at this ER. Where is the arrow of ER pointing? To the right. So I'm going to say my ER points to the right. ER, it points right. And then what about ES? ES, it points left. Okay, I can see that. And then now I need you to remember this rule. Remember this rule. When you go to an exam, make sure that you remember the rule. NB. Oh, shucks. NB. NB. You know what, guys? I think I know what we should do on this paper. We're going to create, okay, it's fine. NB, remember the rule. So the rule is that electric field they point away from positive. They point away from positive. Okay, electric field away from positive charge, and electric field they point towards a negative charge. So they point away from positive charge and they point towards. We are coming to that. So now look at sphere R. I'm just going to try and analyze the sphere R. So let's look at what we have here. Sphere R. Let's go and check on what we have on that guy. So this is my R, which is like this. And then we can see that point P is to the right of R. So this is my R. This is my point P. So can you see that point P is to the right of R? Okay, remember if this is my R and this is point P, this side is left and this side of R is right. So point P is to the right. I'm going to write this down there. For sphere R, we are saying that point P is to the right of R. I'm very sorry guys, I just have to explain everything there. So we know that the field due to R at P points to the right. So now let's look at this. The field due to what? Due to R. The field due to R, it points what? It points to the R, to the right. I hope you guys can see that. The field due to R, it points to the right. That's what is going on here. So that means the field is pointing away from R. Field is pointing away from R. So since it's pointing away from R, look at this. Away from positive. This tells us that R must be positive. Get in. So now you can see what I'm trying to do here now. This is my R and this is point P. So P is to the right of R, and now look at this. Electric ER is pointing to the right. So if it's pointing to the right, what can we say about sphere R? So sphere R, we say the field is pointing away from R. You see where is R and where is that arrow going? It's away. So since it's away, this tells us that R is positive. Because away from positive, the electric field will point away from positive. So without wasting any more time, I think already now you understand that if we analyze this for sphere S, we do the same. We say point P is to the right of S. So, right. So, for sphere S, look at this. Sphere S, where is sphere S? Point P, this is my S, and this is point P. So this side is right, and this side is left. So this point is also to the right of S, of that S. So you can just write it down. It's also to the right. And then where is this pointing? The point of ER is pointing to the left. So the field due to S at P points to the left. So this one, it points to the left. Right, just read the statement. The field is pointing to the left. So since it's pointing to the left, it's going towards what? It's going towards S. Can you see that? Look at the arrow. It's going towards S. So since it's going towards, this tells us that S must be negative. So S is negative. So already you know how to answer this one. You go on your table, you tick the one where R is positive. Let's quickly tick those. Where is A? We need R to be positive. We need R to be positive. So these two guys are out. Right. So since those two are out, we need, okay. So now, we know that sphere S is negative because that one is pointing towards. So towards is negative. We need to tick all the negative ones. Negative, negative. The row with 2 ticks is the correct one. It's a ding, ding, ding. Now you understand how to answer that one. So I think this one was very important, and for you to analyze the sphere R and sphere S to know where is this pointing. Guys, I'm having so much fun on my site. let's see what we get here. Oh, this is going to take longer. Let's see. They say that the circuit below was used in a practical what? In a practical investigation. The battery has an EMF and the internal resistor R. Ignore the resistance of the connecting the wires. Graph K and L below were obtained from the readings taken. And now they say that okay, we can see the diagram. There's graph K, there's graph L. Which one of the combination below correctly indicate the voltmeter reading taken to obtain graph K and L? Okay, so what I'm going to do on this one, you know what I'm going to do? I'm just gonna first, let's talk about, let's analyze graph K first. This graph K, let's analyze that guy. So K is a straight line. What is this telling you? It's a straight line that passes through an origin with a voltage. You see the voltage, it's increasing as the current increases. So this tells you that the voltage is directly proportional to the current, because the more the voltage increase, the more the current increase. So now what is this telling you? This matches the Ohm's law. Right. This is the Ohm's law. The Ohm's law says V is equals to the current times the resistance. So this is equals to the current times the resistance. So from this Ohm's law, so this graph must be the voltmeter reading across the external S. So it must be the voltmeter reading. So this tells you that graph K, it needs to be the voltmeter reading across the external resistor S. So where is that one? When I look at this tells us that this is where, let's look at this properly. It should be what? The external resistor across S, which is V2. So for this graph, we used V2. I hope you guys understand what is going on here now. Because we can see that the moment the voltage increases, the current also increases. Okay, so now let's analyze graph L. Let's see what is going on graph L. So graph L shows a voltage that is decreasing as the current increases. So the voltage, it decreases and the current increases. So remember, for a cell with EMF, and the internal resistor, the terminal potential difference that we use is V is equals to E minus the current times the internal resistor. So this is the formula that we use. So the current increase, and the terminal of the voltage decreases. If the current increases, this V decreases. So look at this. So this is going to be what the V1 is going to measure. So the V1 is going to measure that. So the V1 is across the battery. So the V1 is across the battery. Just know that if the voltage decreases as the current increases, just know that it will be across the battery. So this makes sense. V1 is for graph L. So this will be for V1 because the voltage decreases as the current increases. So this tells us that graph K is V2 and graph L is V1. So I'm going to give you a quick way to cram this so that you don't forget it. Now, if the voltage increase with an increase in resistor. Look at a circuit like that one, because look at this. This is my resistor and this is my voltage. Then if the voltage decrease and the current increase, look for the one that is across the battery, which is that one. So then we know what happens. So you just have to use your graph to check what happens if the voltage increase, what happens to the current. The voltage increase as the current increase. This side, the voltage decrease as the current increase. Then that will be easy for you. Let's tick on the graph. We know that graph K is V2. So I'm just going to analyze, tick the one for V2, V2. And graph L is V1. Tick the one for V1. The one with 2 ticks, it's a ding ding ding. So the correct answer for this one is C. Okay, which one of the following is the function of the split ring commutator in an electric motor? So which one is the split ring? So remember the split ring commutator, it has to do with rotating the coil. So for now I'm going to consider that A, because I know that the split ring rotates the coil. So let's keep on reading the one that so that we can choose the correct one. They say number B, it delivers current from the coil to the external circuit. No, you only look for the one that rotates the coil. Ensures that the coil rotates continuously in one direction. So we're going to also consider C. Ensures that the current black out, because we are looking for coil rotate. But remember, the split rings function is to make sure that the coil rotates in one direction. So now, option A doesn't have this statement, one direction. Option A is out. This leaves me with C. So the correct answer is C. I hope you guys are happy with that. The correct answer will be C. So now let's work on the last question. They say that which one of the following statements correctly describes the photoelectric effect? An electron absorbs the energy of photon and emits light. So they said that it emits light. Wrong. We know that it absorbs energy. It absorbs. So an electron, it absorbs energy. That's correct. And it do what? It ejected. And it's ejected. So emits light is wrong. They were supposed to say it's ejected. So this was supposed to be ejected. So now an electron emits a photon when it collides with another electron. So this is not the definition of photoelectric effect. This is not the definition, so it's out. An electron absorbs energy. Remember, this is what we ticked on top. And eject. We are looking for that ejected. That's correct, from the surface of the metal. So that's correct. We're going to consider taking C. A photon is emitted when an electron moves from a lower energy level to a higher energy level. A photon, guys, it doesn't, a photon emission, so the emission of a photon, it happens when electrons, they move down, not up, guys. They move down, not up. So the mistake that they made, they say they move from what? From a lower energy to a higher energy. So they are saying that they move up. The correct one was supposed to be down. So that was the statement. So this will make D to be wrong. So the correct answer is C.
Okay, so now let's look at this one. This is question 3 from the 2024 November paper 1. This is vertical projectile motion, one of the most easiest question, of course, if you understand the statement, right? So look at what is going on here. They said that we have uh, a ball that is thrown vertically upwards at the 12 meters per second velocity from the top of the building. 2 seconds. Okay, let me first focus on ball A. Now. So I'm going to have my building up here. Let me quickly draw my building. So this is my building. And from this building, we're going to have ball A that will be thrown vertical upwards. You know that if something goes up, it's going to reach maximum height, then it will continue going down until it hits the ground. Okay, so this will be my ground, right? So, and then the V initial at A is given as what? So I'm going to indicate that V initial at A. So I'm given the V initial to be equals to 12 meters per second. Okay, so now 2 seconds after ball A was thrown up, ball B is thrown vertically downwards. So at this point here, the very same, they say from the top of the same building. So from this point, we're going to have B, which is thrown downwards. So A moves up, B goes down after 2 seconds, okay? So this is B, and the V initial of B is given as what? 5.4 meters per second. Okay, so now I think there's something that I need to fix here. Direction. So they say that, let's say I choose up to be positive, okay? So if I choose up to be positive, you can see that the velocity of B will go down, which gives us negative, that 5.4 meters per second. Okay, we'll keep on going back to if we need something. Okay, both balls A and B strike the ground at time 2 seconds. Guys, look at this. I need you to understand what is going on here because this is very important. We throw ball A up, and then after 2 seconds, with ball B is thrown down, but they both reach the ground at the same time. So this tells you that the time that ball B, for ball B, so the time that ball B was projected up, the time for ball P is going to be what? We're going to take the 2, which is the time that the ball reached the ground. We minus that 2 seconds because it was, this will be my delta T for ball B because it was projected 2 seconds after, because if you understand that part, all good. So I'm going to say this again. Ball A is projected up at 12 meters per second. So 2 seconds after, ball B is projected down, but both of them, they reach the ground at time T. So to find the time that ball B was projected, we take the T, which is the time that they're going to reach the ground, we subtract 2. Ignore the effect of air friction. The position time sketch graph for both of the balls are shown below. Okay, so let me explain what is going on here. Let me start with ball A. So ball A, it starts at Z, which is the height of the building. Then it is projected up. So this is your Z. Okay, that point there, that's your Z. Then it is projected up to the maximum height. So this is point Y. The maximum height is at Y. Then it goes down all to hit the ground, which is point T. That's your T. Okay, so then for ball B, I think you can just see that ball B starts here, then it travels down. Okay, let's see what we have on the question. They say using the equation of motions only. Use the equation of motions only. They want you to calculate the value of each of the following. Number 1, T. You need to ask yourself, this is 5 marks. We can't donate those marks. Now, I really don't like when you guys donate marks because of those silly mistakes that you make now. So Using the equation of motions, calculate the value of each of the following shown in the graphs. The equation of motions, and we need to find t. What is t? T is going to be the time that both of these balls hit the grass. And how are you going to approach this question? First thing first, you need to remember to select direction. So I'm going to say up as positive. So up will be positive, then I'm going to do my data. Right, so if I take up as positive, I'm forced to take all, when I work on these other three questions, I should also work with up as positive, okay? Right, let's choose up as positive, and we're going to calculate the value of t. So to calculate t, we need to know how long it took ball A to reach the ground. Guys, remember, the time for ball B, it will just be t minus 2. So in order for you to know, to calculate the time it hit the ground, we need to understand how long it took ball A to reach the ground. So first thing first, let me consider the motion of ball A. Let me start with ball A. Okay, you'll go to your formula sheet, but you're going to do this. You're going to do what we call data for ball A. Then on data, you're going to write what you are given for ball A. So we set up as positive, and the V initial for A is 12. So this will be 12 meters per second, which is positive. I think it's best if I just put my data here so that I can do the substitution on the other side. So what we are saying is that for ball A, I'm going to write everything that I have from the statement from ball A. So I'm going to take, okay, sorry about that. So this is ball A. And I'm going to say V initial is 12 meters per second. And then what else do we know from ball A? We know that ball A will have the acceleration which acts down. It's 9.8, but it's negative because the acceleration always goes down, meters per second. And what else do we know from the statement? Nothing else. Now, this is what we know about ball A. Right. Then I'm going to use the equation of motions to do my substitution, okay? I'm going to use the equation of motion. So you'll go to, we are trying to find what? We are trying to find the, in order for you to understand, we need to find the time it took to reach down the ground, okay? So I'm going to use the formula that has delta y, right? Even though I don't know what is delta y, I'll explain why I'm going to choose that formula. So you'll go to your formula sheet, you find delta y, which is equals to V initial delta t plus 1 over 2 a delta t squared. So now someone will ask, why are we choosing this formula? Guys, look at this. We don't have the final velocity because I can't use the V final there at 0. I can't use that one. So I don't have the final velocity. I'm not going to choose, unless if I have the final velocity that it hits the ground with, then I can choose the formula that has the final velocity. So most of the formulas that they have the final velocity, I'm not going to choose that one. This is the formula I'll go with. Then when you do your substitution, delta y will be V initial, which is 12, delta t. So what is delta t? They said that both of the ground will strike at time t. So the time it will take ball A to reach the ground is t. So where there's delta t, I'll substitute t. This is plus 1 over 2 into negative 9.8. Then this is multiplied by delta t, that's t squared. I'm going to call this equation 1. Right. So if this is equation 1, then I'm going to do the same for ball B. I need the data for ball B. Right. So for ball B, we know that the V initial of ball B, look at this. Ball B, it's going down with 5 point, but we said it's going to be negative. So it's going to be negative 5.4 meters per second. And then ball B will have an acceleration of negative 9.8. Then you're going to substitute everything that you have there, put it on that formula to create equation 2. So delta y is equal to, where there's V initial, I'm going to put minus 5.4, which is multiplied by t. Then we add, what is this? Half of negative 9.8. Right. But now we are making a very big mistake. Remember, what is the time for ball B? We said that the time for ball B will be t minus 2. Okay, we need to first multiply the 2 seconds that ball A traveled up before ball B was projected. So this will be delta y is equal to minus 5.4 inside the bracket. Delta t for that one is t minus 2. Then I'm going to add half of negative 9.8. This is multiplied by that, which is t minus 2. And this is squared. You see? So we have two equations now. Both of these equations, if you solve for t, the t that you get is the time that it will take both of these balls to hit the ground. As you can see, guys, we don't have much space, but I'm just going to try and take the two equations and equate them this side, and then I'll try to work on them. So this is my equation 2. So I'm going to take equation 1 and equation 2 and try to solve them down here. So equation 1, because it's delta y and delta y. So delta y is equal to delta y. I'm not sure if you guys understand, but let me explain how this works. Both of them are equated from the same height. So I'm going to say delta y is equal to delta y. So I can equate the two equations and say this will be 12 t. Then look at this, half of 9.8. What is half of 9.8? If you punch that on the calculator, so it's like saying, I think we're going to use the calculator this time. It's like saying half of negative 9.8 is 4 point something. Negative 9.8. That's 4 point something. And this gives us negative 4.9. So this will be negative 4.9. So this is minus 4.9. Then the minus 4.9 is multiplied by what? It's multiplied by t squared. So this will be t squared. Then we're going to equate this to the second equation. Then let's multiply out the bracket here by that minus 5.4. So it's going to be minus 5.4t. Then we multiply the bracket by the minus 2 by that minus 5.4. So negative and a negative gives us positive. Then you're going to say 5.4 times 2 and see what you get. 5.4 multiplied by 2, this is equals to 10.8. So this will be plus 10.8. Then now I'm going to work on this too, guys. I know that this will give me, look at this, half of negative 9.8, that's negative 4.9. We said it's 4.9 into t minus 2 squared. So I'm going to write this as minus 4.9, then expand the bracket, t minus 2. Then first thing first, before I multiply out the bracket by the 4.9, I need to use the FOIL method to know what is that. So this is 2 squared minus 4t plus 4. So I need you to verify that using what? I need you to verify that using your, you can just pause the lesson and use your FOIL method. First multiply the bracket with t, then multiply the other bracket with minus 2, then add the like terms. So what's next? We need to multiply out the bracket with that minus 4.9. Because whatever that I get, I need to substitute it right there. Okay? So I'm trying to simplify this part here. That's what I'm trying to do. So when I multiply out the bracket, I get this as minus 4.9 t squared, then minus 4.9 times 4. So this will be minus negative 4.9. We need to take, we are multiplying out the bracket with negative 4.9. Negative 4.9, it's multiplied by negative 4. And this gives us 19.6. So this will be positive 19.6 T. Then we're going to say, we already know that 4.9 times 4, that's 19.6. This will be negative 19.6. When you say minus 4.9 times positive 4.9, it will give us minus 19.6. So now that this is factorized, this is simplified. What I'm going to do, I'm just going to put it down somewhere there. I'm going to put it down and say this is minus 4.9 T squared. I am very sorry, guys, about the space. Then, or maybe should I write this? Then I'm going to add, let me just put this one on top here. We're going to add 19 point, we are adding 19.6 T, then we subtract 19.6. So I'm going to group the like terms. So I don't want to waste time on this one now. So look at what I'm going to do. I have minus 4 T squared, and this side I have minus 4 T squared. So you can see that if this one goes this side, it will be positive. So those two will cancel. So those two are out. This side I'm only left with what? 12T, and this is equals to, I need to add the like terms this side. I need to add the minus 5.4T with the, I need to add that with that, what is this? The 19.6T. I need to add the two. Let me see what I get when I add this. This is going to be, we added the minus 5.4 minus 5.4, we need to add that with 19.6T, 19.6, and this gives us an answer of 14.2T. So this will be positive 14.2T. Then I need to add the positive 8. Let me just indicate that with a different marker. So this will be the positive 8. I have to add that with what? With the negative 19.6, because those are the like terms, right? So it's going to be positive 10.8. Then I subtract that 19.6, and this gives us negative 8.8. So this will be negative 8.8. Okay, so let's take the 14 to the other side. This will be 12T minus 14.2T. It's equal to negative 8.8. Therefore, I'm going to say 12T minus 14.2. 12 minus 14.2. What is that equal to? This gives us negative 2.2T. Negative 2.2T is equals to negative 8.8. Therefore, divide both sides by negative 2.2. Divide both sides by negative 2.2. Guys, I'm going to go all this trouble because I need the 5 mark. Unless if you have another method that you can use. Maybe another easy method that you can use is fine. You can just go with that method now. So when you cancel this side, T is equal to negative 8.8. We need to divide that. This is negative 8.8. We need to divide the negative 8.8 with the answer. Okay. We take negative 8.8 to divide that by answer. This gives us 4. Therefore, T is 4 seconds. That's your answer. So this tells you that the two graphs took, the two balls, they took 4 seconds to reach the graph. I hope you are happy with that. I hope you guys understand. Please just try to make sure that you pause the lesson, equate these two questions, equate them, and try to solve this on your own. Number 3.1.2, they say we need to calculate Z. You need to ask yourself, what is Z? Look at this. This is the position in meter. So it's the height of the building where the ball A was projected. So that's the height of the building. Right. If we are looking for the height of the building, I know the formula that I need to use because I'm looking for delta y. I can use, let's say, I'm going to look at, let's say I consider ball A. I'm going to look at ball A, or you can also look at ball B. You can also look at ball B, okay? So it's up to you what you want to look at. So let me just look at ball B now, because even if I look ball A, we're still going to get the answer. But look at this. It's easy for me to find the height from that point to that point. If I look at ball A, I know that the V initial at ball A was minus 5.4. So I'm going to say that for ball B, not ball A, ball B, delta Y is equals to V initial, this was V initial, delta T plus half A delta T squared. So I'm going to do the substitution. My delta Y will be the V initial of ball A, we set it's minus 5.4. The time, guys, we set the time for ball B, it's T minus 2, and now we know that T is 4, we minus 2, then this would give us 2 seconds. So I need to sub in there time as 2 seconds for ball B. So it took 2 seconds, ball B 2 seconds to reach the ground. So this will be 2 plus the half of the acceleration is negative 9.8. Therefore, delta T, this will be 2 to the power 2. Therefore, you just have to punch that on the calculator and see what you get. And another thing that you need to note is that ball A is traveling down, which means that the displacement of ball A will be negative as we set up as positive. So everything that goes down, the displacement of that thing will be negative. So when I punch this on the calculator, I expect to get a negative answer. And if I don't get a negative answer, then I'm gonna check and see, because this will mean that somewhere, somehow, my substitution is incorrect, okay? Then this is, we are adding, okay, half of negative 9.8. Okay, negative 9.8, then this is multiplied by 2. I'm not sure, guys, if this will give me the answer, but it looks like it's going to give me an error because of the graphs. Let me check. Okay, this gives us negative 30. You see, the answer, my answer is negative. So this tells me that the displacement of ball A is going down. So that's negative 30.4. So that's the answer. So this will be negative 30.4 meter. So since it's negative 30.4 meter, we can conclude and say Z is equal to 30.4 meter. The negative is just telling you where is this object moving. You understand? Yeah. So that's it for this one. Let's look at 3.1.3. 3.1.3, they say that we are looking for Y. Oh, okay. I think this will be easy. Look at this Y here. Y is there, if you look at the graph there, Y is the maximum height that ball A reached. And it's going to be easy for you to find the maximum height that the ball A reached. I can even consider the maximum displacement of the ball A, which is above the point of projection. I'm not sure if this makes sense. Let's consider the maximum point. Let's say the maximum displacement of ball A above what? Above the reference point. So I can say that I know that if point A started at this building, then it travel up, then it reach maximum, it comes back to this same point, then it continue moving down. So what I need you to understand is that the distance that it traveled going up is the same. You see, we can find the distance that it went up, and then we can add that with that distance, which is something that we already know, that the height of the building is 30.4. So if we can find the distance that it traveled to its maximum height, we'll know what is y. So we'll know what is y. I'm not sure if that makes sense, but let's work on that. So I'm going to use, because now I know that the V initial of A is 0 because it reached the maximum height, and then the V initial is 12. So I can use the formula that has the V final, the initial, the final velocity. And the formula goes like this. So this is 3.1.3. So the formula will go like this. And I think it's best if we just take this question up there so that we can have space to answer 3.2. Okay, so we are saying that the formula is Vf squared. It's equal to V initial squared plus 2A delta y. We are looking for delta y, right? And the initial velocity at the final is 0. And then V initial is going to be 12, and this is squared, plus 2 into the acceleration. So remember, the acceleration is going up. This is negative 9.8, then delta y. And then now I'm going to say the 12 squared. What is 12 squared on your calculator? I think it's 144. But let me confirm. 144. So if I have 0 is equal to 144, then I'm going to say negative 19.6 delta y, because if I say 19.2, it's okay, 9.8 times 2, that's 19.6, but it's negative, right? Then this will be negative 144 to the other side, negative 19.6. I'm going to isolate the term that has y, so that I can divide both sides by that negative 9.6, divide both sides by that negative 9.6. The answer that I get is my delta y. You see? So I just have to take the question and say 144 divide by, I know that the negative will cancel, so I'll just say 144 divided by 19.6. What is my delta y? My delta y is 7.35. Guys, I'm very sorry about the calculator, but just write the number that you see now, which is 7.35 if we round it off to 2 decimal places. 7.35. So this is the maximum height, 7.35 meter. So this is the maximum height. And if that's the maximum height, what will be the height? What will be the height at y? We need to add the 2. So we know that from this point here to that point, the distance between those 2 points, this one is 7.35, and the distance between that to the ground we said is 30.4, right, meter. So we just have to add the 2. So this tells you that at y the distance will be 30.4. You added that with 7.35. 30.4. I'm gonna take this at 30.4. 37. So the answer is 37.75 meter. And that's it. Easy enough. Okay, last question. They say that on the same set of axes, sketch the velocity time graph. The velocity time graph. So if they want the velocity time graph, I need to say this will be my graph like this. This is my graph, and then this will be my velocity, and this will be my time. I'm just gonna try and put everything that I know so far on this graph, and then I'll explain how this goes. So first thing first, the reference point, guys, it's 0. So when I say the reference point, where the graph start, not exactly where the graph started, I'm going to call the maximum height when the velocity is at maximum height. That's when the velocity is 0. I'm not sure if you guys understand what I'm saying. Look at this. V initial is equal to 0. It's at maximum height. So this tells you that if I say the velocity there is 0, this is your maximum height. Let me focus on ball A. Ball A, it starts with the velocity of 12. So if I say this is 5, 10, 15, we know that 12 will be somewhere there. So for ball A, it will start where? It will start at 12 with the velocity of 12, right? And then it moves up. Look at this. What happens when it moves up? It decreases in velocity. Okay, and we set up as positive. So when the velocity is moving up, it will be above that 0, but it will go down. Why? Because the velocity decreased all the way to the maximum height. So at this point, that's your max height. But I'm going to label everything when I'm done with my drawing. Okay, so then when it reached the maximum height, the ball A starts going down, meaning that now it has a negative velocity. Why? We set up as positive. So it will start having what? A negative velocity. It will go down with a negative velocity. The more it goes down, the more it hits the ground with a negative velocity. So this tells you that it will hit the ground at time. Let's say I decide to put my 4 there. So this will be at T4. This will be my T4. That's when it's going to hit the ground. I hope you guys understand. And this will be for ball A. This is the graph of ball A. Right. So one thing that I realized is that when I look at this, both balls are in free fall. So since both of them they are in free fall, the entire motion, so they are in free fall the entire motion, right? Therefore, this tells you that there will be parallel lines with the gradient. Né? So now to draw for the ball B, where is ball B starting? You look at the velocity that ball B was projected. This is the point where ball B was projected, and it was projected with the velocity of negative 5.4 because we set up as positive and that velocity is going down. So if I put minus, let's say I put minus 5.4 there. So velocity, the ball B is going to start at that point. Okay, so it's going to start at that point, and when I look at the time, it's going to be projected. We set T minus 2. 2 seconds after ball A was projected. 2 seconds after. So I'm going to put maybe 2 there and say it was projected 2 seconds after. Let's say from this point, 2 seconds after. Okay. Two seconds after ball A was projected. So maybe I can say this is 2. Then it was projected somewhere at this point. Then when it goes, it's moving down. You see, it hits the ground at T4. So it's going to move down and hit the ground at that T4. So it's going to move and hit the ground at T4. So this will be my ball B. Simple. Then this is your graph. If you give them this graph, you'll definitely collect all the marks. But let me help you understand what is going on at the graph. Now, you see this point here. This point here, this is the point where ball A is projected upward. So ball A, we're going to say is projected up, right? At 12, let's say at 12 meters per second, right? And then at this point here, at this point, ball B was thrown downwards. So at this point here, that point we say ball B was thrown downwards. And what was the velocity? At V is equals to negative 5.4 meters. And then we said at what? At T is equals to 2 after 2 seconds. Right. And then this point here and that point, this 2 point is going to be both ball reach the ground. Both of them. Both reach the ground. 100%. Okay, I think we did explain everything, right? And then now last thing is that both of these two lines, the lines, both of them, if you look at the lines now, I'm not sure where I'm going to put this one. This line there and that line there. Both of them are straight lines and they have the negative gradient. So both lines are straight line. Both of them, they are straight lines with a gradient that is equal to negative 9.8 meters per second squared. And that's it for this one, guys. I hope you really understand how to work around this question. Yes, I can say easy 16 marks, but I can say easy 12 marks. I know that you can have challenges when it comes to do the drawing, but this is what you need to do when you do the drawing. The most important thing is to say, oh, it starts at 12, it moves up. So since it moved up, it decreases in velocity until it reaches the max height. So this is at max. Then from there, it starts moving down. We set it down as positive, as negative, up as positive, down will be negative. So once it at maximum, it starts moving where? It starts moving down with a negative velocity until it reaches the ground at T4. So let's say that in an exam, they said, calculate the velocity that it will hit the ground. Whatever velocity that you get, you should make sure that it goes same as that point. And that's it for this one. I'm looking forward to work with you guys on the next question. Remember, if this is your first time on the channel, we still have massive questions to work on. Make sure that you join the family. Just subscribe to the channel and we'll make sure that you feel at home. Okay, so now let's work on that question for the next question here. We need to work on this. Let's continue working on the question paper. Let's see what we can do from this question 4. So now, looking at question 4, this is momentum, and I'm not sure if we're going to have enough space for doing the calculations here, but I'll try. So a trolley A of mass 1.5 kg, it's at rest on a frictionless horizontal surface. So that is the first statement that I'm given, and I see the word rest. So this tells me that since it's at rest, the V initial of A, it's 0 meters per second. I hope you understand that part. So trolley A will have the V initial of 0 meters per second. Okay, so they say that a second trolley B of mass 2 kg traveling horizontally at a constant speed collide with a trolley A. So they're going to collide, then they stick together and move at a constant velocity. Guys, constant speed and constant velocity, it's not the same. We're going to discuss that as we move. If you need to understand this, then based on the questions, then we'll talk about it. To the right, so covering a distance of, so they move to the right after collision and the distance is 0.8 meters in 2 seconds. So now what I'm going to do, I'm just going to put this information here and say, after collision, they move delta. Since this is horizontal, we're going to call this delta x. They move 0.8 meter, and at a time of what? 2 seconds. Okay, so now ignore all frictional and rotational effects. First question, state the principal conservation of linear momentum. So the principal conservation of linear momentum, it says that for 4.1, it says that the total linear momentum in an isolated system in an isolated system is conserved. Remember what we talked about on the multiple choice questions, né? So that's the total linear of momentum. So is conserved, right? Or you can say remains the same, or it remains constant. You can say that. So that's the principle of conservation of linear momentum. And then 4.2, they want you to calculate the speed v which the trolley beam moves before the collision. So you know what I'm going to do? When I look, I think we can have enough space to work this 4.2 maybe here on top. Maybe we can just put the 4.2 on top, or we can just move it down here now. So they said that they want us to find the speed which trolley beam moves before the collision. First thing first, they said they want us to state linear momentum. You know what? For the fact that they said, remember I said in physics, whatever that they want to state, just know that the following questions will be based on that. They say define the term free fall, and the question was based on free fall. They said define Newton's first law, and most of the questions were based on Newton's first law. So this tells me that if they said state the principle of conservation of linear momentum in width, I can just write that down and see how can that help me to find the speed v. I think you guys are learning how I attack these questions now. So this will be my 4.2. So on my 4.2, I'm going to say the change of momentum before it's equals to the change of momentum after. So now why are we using this? Let's quickly work on that, because remember there's a collision. Let's say before, we're going to say the mass 1, we need to multiply the mass 1 with the v1 initial, the velocity of the mass of the first object. Then we need to add this with the second mass multiplied by the velocity of the second object, and this we're going to equate it to what? We're going to equate this to m1 v1 final, m1 v1 final. Please just give me a second, this will make sense now. M1 v final, then we need to add this with the second mass multiplied by the velocity of the second object, which is b, and then this will be f, the final velocity. Okay, so you know what I'm going to do? Let me substitute what I have on this equation, because I think it's easy if we just substitute. So the mass 1, which is, we're going to say my mass 1 is trolley B, and I'm going to use my mass 2 as trolley A. Is this making sense? Yes, we can do that.
So this will be M1 on my substitution, and this will be my M2. So now my M1 is 2, my M2 is 1.5. Let's quickly substitute that. M1 we said is 2 into the initial velocity of that trolley B, which is V. They want us to calculate the speed V. So I'm going to substitute that as V. So I'm just going to leave this as what? As V. Because this is what I'm trying to calculate. Plus my mass 2. We set mass 2, it's 1.5. Which needs to be calculated by the initial velocity of trolley A. Remember, trolley A is the second mass, which is 1.5, and the initial of 0. Let's quickly substitute that, and this is 0. Then this is equal to, because now I don't want to confuse myself. I know that there's something missing, but now I just have to verify by substituting everything that I have on this equation. Then the equation will tell you what you miss and what you need to calculate. So now these two, this is after collision, the object move together. So since the object move together, they will move with the same velocity. So we can write this equation as the mass 1 plus the mass 2, then put these two guys inside the bracket and say this is my V final. So they will move with the same velocity. So I can add the two masses, which is 2. We add that with 1.5. Then let's close something here. V what? V final. The velocity that these two objects will move together with. So this will be my VF. So now look at this. Look at this. What is going on here? We are looking for this V, and the final velocity is missing. Let's go and try to find a way how we can calculate the final velocity after momentum and come back and substitute it here. I know that if I go back to the statement, we'll get something that can help us to solve this problem that we currently have, because we have two unknown variables. There's nothing we can do from that. Let's go back to the statement. So the statement said that after collision, because that's the velocity that we are interested in, the velocity that these two objects moved with. So after collision, they traveled a distance of 0.8 in 2 meters second, and this is the data that I have. So now I know that I can use what? The equation of motions from the vertical projectile motion, because this makes sense looking at what I have. I know that when you are in an exam, it's not easy for you to just think about it and say, you know what, this will be equation of motion. I can use the equation of motion to find the missing velocity. You know what you need to do? Think about it like this. Think about it like this. I'm just going to teach you something. Now, look at this. Delta X. Oh, delta X. I know that in work, energy, and power, when I have delta X, it's when I calculate the work done. But now, I can't use the work done to find the velocity. So where can I have delta X? Then you go back to your formula sheet. Now, you consult your formula sheet. Remember, we just assumed that you are in an exam and you don't know what to do. And now I'm training you how to master these questions. Now, then you'll see. It's a ding, ding, ding. So now look at this. I'm going to say, I'll go through my formula sheet. Okay, these are the constant values. Then when I go through my formula sheet, I'm looking for delta X. I'm going to check where I have delta X in my work, energy, and power. So there's no delta X. It's only here when we calculate what? The delta X, it's only here when we calculate the work the work done. So that won't help me because it doesn't have a velocity. I need to have velocity and delta X on one equation. Then if I have that, that can assist me. So now I'll really appreciate to get delta X and the velocity. So this one won't work. Let's see. Okay, look at this. This one is the V initial. We know that no matter what, that V initial can be our V final, but we can first find that V initial on that equation. So the only formula that can work, the only formula that can teach us, that can help us, it's one of these two, but I'm just going to choose the first one. So let's go back and write down that formula and work on it. I hope you guys understand how we are bringing that formula to what we are currently working on. Please don't be confused. So now we are saying that we're going to use the equation of vertical projectile motion that says delta x is equals to V initial then delta t plus 1 over 2a the delta t squared. Right, so now what I'm going to do, I'm just going to rearrange my formula and say delta x is equal to, remember the information that we're going to substitute, it's after collision. It's after collision, and after collision I need to have the V final. So I can, instead of using this velocity V initial, I know that I can substitute that as V final, but it's fine. Let's just work on this the way it is now. So let's do the substitution. When we substitute, we're going to say delta x, the distance traveled after collision, it's 0.8. So I'm just going to substitute this as 0.8, equate this to V initial, and they said this will be done in 2 minutes, so 2 seconds. So this will be 2 plus, now if I don't know guys, because look at this, please pay attention on this one. Now I think we are having so much fun. Look at this, because when I see a lot of tricks, this is where I enjoy them. The problem, I have this as 1 over 2a delta t squared. It's not squared. Is this squared? Did we write the squared here? No, we don't have the squared, so it should be delta t squared. Look at this. When I look at this problem, I know that the time is going to be that 2 seconds, because they said this will be done in what? This will be done in 2 seconds. So now, what about this a? Can we substitute a as 9.8? No, we can't do that. Why? Because delta x itself is telling you that we are working with what? We are working with objects that are horizontal to the surface. We only substitute a as 9.8 if the object is moving vertically. This is not moving vertically, but now you're going to be confused. How am I going to substitute to find a? Because now I'll have two unknown. I'll have V initial and a. So look at the question. Remember, we just underlined that they stick together and move at a constant velocity. Constant velocity tells you that the acceleration is 0 meters per second. The acceleration, it will be 0 because this moves at a constant velocity. Right, so this tells us that we're going to substitute that a as 0, which will make everything there to be 0. So this will be 2 squared. This will make everything to be 0. I'll have 0.8 equated to V initial multiplied by 2. Divide both sides by 2. Divide both sides by 2. Therefore, I have my V initial to be equals to, when I say 0.8 divided by 2, this gives me 0.4 meters per second. This V initial is the velocity after collision. This is the velocity that the two objects will move together with. So I can conclude and say, therefore my V final is equals to 0.4 meters per second. So now that we have the V final, we can just substitute everything now. So this will be 2V plus this is 0, then equate the 2V to 2 plus 1.5, I think that gives us 3.5. So this will be 3.5 that we need to multiply with the V final, right, of 0.4. of 0.4. So now I think you know what you need to do just to be on the safe side. On this step, after finding this guy, come back and substitute it here because there might be a mark. Remember, there might be a mark for the formula, and they'll give you a mark for the correct substitution. So come back and substitute it here before you do that step. So now I think it's easy for us to find V. We can just divide this side by 2, divide this side by 2. So V, it equals to 3.5 times 0.4, and we divide this by 2. This gives us 0.7 meters per second. So this is my velocity of trolley B before the collision. Right. So now they are asking that is the collision elastic and inelastic collision. So ladies and gents, if an object collides with another object, and then after the collision they move together. So after the collision, if after the collision they move together, it's inelastic. So the correct answer here is inelastic because they move together. For the fact that they stick together, we're going to say this is inelastic. But if they don't stick together, it's going to be elastic. So the correct answer is this one. Okay. During another, because they don't want you to give a reason, just choose the correct one. Please don't do guesswork now. During another collision, listen, during another collision, trolley B exert what? A greater force on trolley A. And the change in momentum of trolley A is the same as before. How is the time for the collision affected? How is the time for the collision accepted? Choose from increase, decrease, remain the same, and write down a relevant equation that supports my answer. Obvious. I'm going to use an equation first before I can even know if which one is the correct one to choose. I'll first write an equation. That's what I'm going to do. So during another collision, trolley B exert greater force. Which force are they talking about? The F net. Right? And the change in momentum of trolley B is the same as before. The change in momentum. So I also have the change in momentum, and what is the change? Is delta P. Then is the same. How is the time? This is delta T. So I'm going to find a way on trying to understand how is F net, delta P, and delta T in one equation. Go to your formula sheet. Guys, can you see what I'm doing here? This is nothing but the best. Look at this. What I'm giving you guys, the way I'm teaching you how to answer questions. This is the best because look at this. 4.4. During another collision, trolley B exert what? A greater force. We underline a greater force. We know that they are referring to F net on trolley A. And the change in momentum, then I write delta P, is the same as before. How is the time? Delta T. So I'm going to look for F net, delta T, delta P that are on one equation. Let's go back. I know that you guys already know which one it is, but I just want to make sure that we are on the same side. So when I look at this has to do with change in momentum. Should we go back up or where is it? Okay, so look at this. F net, delta P, change in P. So this is the formula that we can look at. Let's go back and write that formula down. Then we'll see what we can get from that formula and try to understand what will be the correct answer there. Okay, let's look at what we have here. I'm going to say I have my F net. Okay, where can we write this? F net, then this is F net times delta T. It's equals to the change in P, right? it's equal to the change in P. Therefore, let's make F net subject of the formula. You can divide both sides by what? You can divide both sides by delta T. So F net is equal to change in P all over the delta T. So the only thing I'm interested in, they said that how is the time for the collision affected? We are exerting what? A greater force. But now the change in momentum of A is the same. So I'm going to remove this statement from my equation. I'm not gonna focus on this because there's nothing changing on the momentum. So this guy here, this is something that you don't have to focus on your formula. I hope you guys understand what I'm saying there. So the only thing that you are interested in is to understand what happens if the F net increase, what happens to the time. Let's go into our formula. So I'm just gonna avoid the delta P. So F net, we know that is directly proportional to 1 over delta T. So inversely proportional, I'm sorry. So I have F net to be inversely proportional to the time. So this tells me that for the fact that F net is 1 over delta T, what happens if the F net increase? If the force increase, this guy decreases. So this tells you that, remember from Newton's law, if we have, let's not bring the Newton's law. So F net, it will be inversely proportional to delta P. So if the force increase, the time will decrease. So we can see that F net is directly proportional to delta P. If the F net increase, the change in momentum increase. And if the F net increase, the change in time decreases. So the correct answer there is decrease. Then when they say write down the relevant equation that support your answer, we can give them and say that, guys, take this and give us that 1 mark. You can say F net is inversely proportional to 1 over delta P. Please use the inversely proportional sign. And that's it for this question.
Okay, let's look at this electrostatics question again. So now on this question, they said that a charge sphere M is suspended from the ceiling by a light intensible insulated string. Another charge sphere N of mass 2.04 times 10 to the power minus 3 kg, carrying a charge of 8.6. Guys, you don't have to be stressed about this numbers you see, or if you don't understand the statement, you can also get a chance to analyze the statement when you are answering the question. So in most cases, when you answer the question, it becomes more easy for you to analyze or understand the statement, right? So the centers of the sphere are 0.3 meter apart. First question, state Coulomb's law in width. We need to state Coulomb's law in width, and you can also get the definition from your exam guideline. The magnitude of the electrostatic force that is exerted by one point charge on another is directly proportional to the product of the magnitude of the charges, and we say that it's inversely proportional to the square of the distance between them. Okay, so please go and try to read that electrostatic force definition, which it says K Q1 times Q2 divided by R2. The statement is just talking about that. So I don't want us to waste time on that one, because this is something that you can do on your own. Please go to your exam guideline, read the Coulomb's law in width. I'm just going to leave the formula for now. Okay. So next question says that they are asking us to, okay, they say state whether the charge on M is positive or negative. Or how are we going to do this one? Right, let's go to the statement. I need to understand what are they saying about N Okay, so if I can understand what they are saying about this guy, then I'll take it from there. So on the statement, they say that N has the mass 2.04 times 10 to the negative 3 kg. It's carrying a charge. Look at the charge. The charge of N is positive. Okay, so the charge of N is positive. So we can see that the sphere N has a positive charge. And what can we say? Since N hangs stationary below, look at this. This charge is hanging stationary below sphere M. There must be what? An upward electrostatic force that is acting on N to balance what? To balance the weight of N. So what I'm trying to say is that for N, if I draw a free body diagram, for N, I'm going to have a force that is going up, and that force, we call it what? The electrostatic force. So this is Fe, the electrostatic force. Then we have the weight going down, which is my Fg. So this is the free body diagram for N, for charge N, okay? So looking at the free body diagram, we have a force that it's acting up, and then now that means that sphere M is attracting sphere N upward. So this M, it is attracting what? It is attracting N upwards. And you know what we say when we say we have the force of attraction? Opposite charges attract each other. Therefore, M should be negative. So this tells you that in order for N to hang in there, we are saying that the sphere M is attracting sphere N upward. I hope you guys understand. So sphere N is positive and sphere M is negative. I hope you guys are happy with how we answered that 1 mark question. Right. What do we have next? Draw a label free body diagram for sphere, and we already answered 7.3. Wow, that was nice. This is nice, man. This is 7.3 because I've already showed you guys how to do the free body diagram. We have a force acting up, and we said this will be the electrostatic force. So the electrostatic force is acting up, the weight is going down. So that is already 7.3. This is good. Calculate the magnitude of the charge on sphere M, and this is 5 marks. Okay, but wait too. Look at what I have now. When I see this type of questions, this is where I get too much excited, because I know that, you see, I like doing like calculations. And now let me help you understand how to do this question. So they want you to find the charge on sphere M. So what you need to ask yourself is that, what is the formula for electrostatics? That's what you need to ask yourself. What is the formula for the electrostatics? Let me just write down the formula. I'm not sure where we're going to do this problem. We don't have much space, but I'm just going to try and put it maybe somewhere here. So we need to first, they want us to find the charge on sphere M. And the formula for electrostatics, it goes like this. F is equals to the constant force multiplied by the charge of M, which is what we need to calculate. This is multiplied by the charge of N. Everything is divided by R squared, the distance between them. So this is what we're going to do, and this is for 7.4. Okay, I think I have an issue here. I have a problem. I have a very, very big problem. Look at this, the electrostatic force on N. We have a certain free body diagram there. We have a certain free body diagram there because the weight now is included. So now this changes everything on how you calculate the electrostatic force. I think you guys can see I'm trying to move slow on this one. So if I say F net, it's equals to 0 because these are the vertical forces, right? So my F net will be equals to 0, meaning that I'm going to take up as positive. I'm going to choose direction. I'll take up as positive, or maybe we should take down as positive. Ne? Maybe we should also take down as positive. So that will be up to you which one you want to take as positive. Okay, so when I have this, I can say down as positive, then this tells me that all the forces that are going down, there will be what? All the forces that are going down, there will be positive. We subtract all the forces that are going up, which is the electrostatic force, and this is equal to 0. So what is this telling you? Is that F net is just equals to your weight. It's Fg, which is mg. Then we're going to minus the electrostatic force, which is K of, I don't think that will be good if we put it like that. Let me just rewrite the equation so that we can have space now. So we are saying that F net, it will be equals to, we take the weight, which is mg, then we subtract the electrostatic force between the charges of the charges, which is Qm and Qn, and then let's divide this by the distance between them. But now, what is your electrostatic, your F net? We said F net is 0 since these are horizontal forces, right? So F net is 0. This will be 0 into, then I need to do my substitution, okay? I need to do my substitution. So let's see what I get when I substitute on that equation. So I'm going to say F net, that is 0, and we equate this to the mass times the gravitational force. Okay, the mass times the gravitational force. So maybe to save time, I'm gonna say my Fg down there, up there. It's mass times the gravitational force. What was the mass? The mass was 2.04 times 10 to the power minus 3. So this is 2.04 times 10 to the minus 3. And this will be multiplied by the 9.8. You just have to put that on the, you just have to put that on the calculator and see what you get. Okay, 2.04. The 2.04 times 10 to the power negative 3. This guy is multiplied by 9.8. I need to put this one inside the bracket. I know that if, okay, the reason it's giving me error is because of that 9.8. I need to put a multiplication sign. So this is 0.012. If you round it off to do decimal place, so the weight will be 0.012. So this will be 0.012. Oh, not 0.012, it's 0.02. 0.02. This is your weight. I'm going to need that. I'm going to need that weight because of the substitution that we need to do now. Okay, so looking at this, I have my weight as 0.02. Then I'm gonna subtract what? I'm going to subtract that K. I'm going to subtract K of Qm Qn over R squared. The reason I'm doing this, I just want to move my equation this side, okay? I need to move it this side so that I can do my substitution here. So this will be 0.02. Then we are subtracting K, which is the constant. Go to your formula sheet, you'll find that this is 9 times 10 to the power 9. Then we are looking for charge M, and then this should be multiplied by the charge what? The charge N. So the charge N is already converted, right? So it is multiplied by 10 to the power minus 8. So this will be 8.6 times 10 to the minus 8. Please, when you do this, you don't have to include what? You don't have to include the signs, okay? Stay away from the signs. and the distance between these two charges is 0.3, and this is squared. So I need you to work your magic and make that QM subject of the formula. So I'm just gonna first explain what we need to do. First thing first, we're going to move the electrostatic force to the other side of the equation. Remember, this is equal to 0, right? So I'm going to say all this. Let me highlight what I'm referring to. So all this, we know that all of that is negative. So I'm just gonna move it to the other side to be positive. So to move it, let me remove the 0, remove the negative sign, then put an equal sign there. So 0.02 is equal to, so basically I've already moved it to the other side. Then next step, you remove the fraction by multiplying both sides by 0.3 to the power 2. So this will be 0.02. You're going to multiply that by 0.3 squared. Then you're going to be left with everything on the numerator. So you divide both sides by that 9. Guys, the reason I'm doing this is because of the space. 8 point. But I think you understand how to isolate something, to make something subject of the formula. Then this side will be left with QM. So we just have to know the charge of M by punching that on the calculator. Please follow the steps. Step number 1, multiply the 0.02 by that 0.3 squared. Then to make QM subject of the formula, you divide by this and that. Then you'll only be left with QM on the right-hand side. Let me go and put that on the calculator. Let's see what I get. Okay, so this is 0.02, which is multiplied by 0.3 to the power 2. Okay, and everything is divided by 9 times 9 to the power 10. And this is multiplied by, as you can see, between my brackets, I put multiplication so that I don't get error. 8.6 times 10 to the power minus 8. Then close the bracket. What is that equals to? This gives me 6.6666. Okay, so 0.2 times 3, 2, 9 times 10, 8.6. Times 10 to the power negative 8. I just want to confirm if everything. Okay, look at this. This is 10 to the power 9. Okay, 10 to the power 9. And this gives me 0.000000. Okay, it's fine. Let me just look at the big number that I'm getting there. I'm getting a very big number there. So it's fine. I just want to confirm if I got everything correct there. Yo, that's a very big number there. So you know what? I'm going to ask for help and say shift mode number 7. Let's put this to 3 and see what we get. Okay, equals to SD. Shift mode number 7. Let's put this to 9. I just want to see something. What's wrong? Yes, there it is. There it is. There it is. Just put it to 9. Just put it to 9. But in most cases, in an exam, they'll say you must put your answer to 2 decimal places. So shift mode 7. 7 is for scientific. Now I'm gonna say 3 equals to, let's see, as the, yeah. So we get 2.33 times 10 to the power 6. 2.33 times 10 to the power 6, I'll definitely take that one. Okay, so this will be 2 point. The answer for this one will be 2.33 times 10 to the power negative 6. That's the charge. And we're done. 5 marks. You see, I'm here to massify you guys. I'm here to bless you with this marks. Né? Yeah, I'm the weight mass in the weight massive. How does the electrostatic force that sphere M exert on sphere N compared to that exerted by sphere N on sphere M with respect to the magnitude, the direction? Okay, what do we have here? All right, so they want us to compare how does the electrostatic force, I'm trying to understand the question. We are going to compare the electrostatic force that sphere M exert on sphere N compared to the exerted sphere by N on sphere M with respect to magnitude. Okay, so if we check the magnitude, let's start with this one, the magnitude. Okay, so when two charged objects interact, each object exerts a force on the other. Right, listen. We have two charges that interact, and I'm saying that each object will exert what? A force on each other. This follows what? Newton's third law. For every action, there is an equal and opposite reaction. That's Newton's third law. So sphere M pulls sphere N. You understand? So sphere M, this guy pulls what? It pulls sphere N. So at the same time, sphere N, it pulls what? Sphere N, it pulls M. That's Newton's third law. The two forces, we call these two forces the action-reaction pair. Okay? Right. So let's now answer the question. So the electrostatic force that sphere M exerts on N according to Newton's third law is going to be equal in magnitude. So this will be equal in magnitude. Okay? So let me explain this. Even though the sphere may have different masses or charges, the force between them is going to be always the same. Right. So what we are saying is that the force, the electrostatic force of M on N, it should be equal to the electrostatic force of N on M. Simple. Right. Let's talk about that. Okay. So you see this guy here. What is this meaning? Is that if M, let's say M, it pulls N, and then it pulls M with what? With a force of 0.02 newtons. Then N will also pull back with the force of that 0.02 newtons. So the magnitude will be equal. Okay, so let's work with this one. What about the direction? What about the direction, guys? We said that the force that acts, the force act in an opposite direction. So the answer this is going to be opposite. Okay, opposite, and I'll definitely give you the explanation to that. So sphere N is positively charged. We said sphere N is positively charged, as you can see there, and then we have sphere M that is negatively charged. So the spheres attract each other. This one goes in that direction, this one goes in that direction. You can see that they go in an opposite direction. So sphere M pulls sphere N upward, and sphere N will pull sphere M downwards. So the force along the same line, but in an opposite direction. And that's it. I think, I thought that was the last question. Okay, the last question they say that point X is 0.1 meter vertical below the center of N as shown. Okay, we can see that from the diagram, and they want us to calculate the net electric field at point X. You need to write down the formula of the electric field. Try to remind yourself what is the formula of the electric field at a point. So E is equals to K times the charge over the distance between that point and the charge. So now we going to have the what we call, okay, so we need to find the electric point due to or between, let me just do this. Okay, let me just do this. Let me just do this. We need to find the electric charge, the E of this point due to that point. Let me do this. Okay, and then we also need to find the electric point of this point due to that point. Then we find the E net. Okay, so we find the E net, and remember, they will go in an opposite direction, guys. They will go in an opposite direction. So let's say I take up as positive. Okay, so if I take up as positive, what will happen? We're going to check, we're going to get the E net of that, the one, which one? The E net of, look at this. This one is going up, this one is going down. Okay, so if I take up as positive, I'm going to take the electric, how can I write this? The E of the N, which is the one that is going up. You subtract the E of the M, which is the one that is going down. We call this E net, as in like the net force, if you still remember the net force. Okay, let me just rewrite this. So the E net, it will be equals to, we said we'll take the one that is going up, which is for N. We subtract the one that is going up, which is for M. So let me quickly write the formula down, then we'll just work on doing the substitution. So the E net, it will be equals to the 1 for En. If you still remember the charge for this, it was given as we just calculated this to be 2.33. What was that? 2.33 times 10 to the power minus 6. So this is 2.33 times 10 to the power minus 6. Okay, so and then now this En, the formula, it should be K times Qn over what? The distance between them. So this will be K of the charge N over R squared. We're going to minus K of the charge M over R squared. Then the E net will be equals to the K is 9 times 10 to the power 9. And then the charge N, we set that this is 2.3, 3 times 10 to the power negative 6. Then this is divided by the distance between the N and the point X. So the distance between the N and the point N is given as 0.1 meter. So this will be 0.1. And don't forget to square that. Minus, then this will be 9 times 10 to the power 9. Then we multiply by the charge of M, which was given there on top. On the statement, they said the charge is 8.6 times 10 to the power minus 8. So I'm going to multiply that by 8.6 times 10 to the power minus 8. Divide everything by the distance between M and what? The distance between M, I think if what I'm doing here, guys, it's very, very, very wrong. Okay, the distance between M, I know there's something wrong that I'm doing, but I'll definitely fix this now. The distance between M and what? Let's fix this distance issue. Let me fix the distance issue, because we are approaching this the wrong way. You see now, because when you do the substitution, you can see that what you are saying is not making sense. Let me fix the issue here. This En, if you still remember, we said is the force. It's like saying this force here, the force that is going down is going to be the force that is going down is it's what we call the force of what? The force of N on M. The force of N. This is the force of N on M. So if we do the force of N, this is the force of N on M. It's on M. So the distance will be 0.4. Not zero, not that. Don't focus on between N and X. So that was what I was doing wrong, and I definitely have to fix it. This. So this one here, we say this is the force of M on N, and then the distance between that one is going to be what? Is going to be 0.1. So this will be 0.1 squared. I hope you understand. I think this is a very big trick, and if you don't get this one, marks gone. Okay, I'm saying this again. This is the force N on M, so it's acting on M. That's why we are using charge N, but it's acting on M. The distance should be between M and X. But look at the charge that we are using. It's for N. Same applies to the other one. For this one, this is the force on M. Is the force on M due to? It's the force on N due to M. So that's why the distance is 0.1. So don't say since this is the charge of N, the distance should be 0.1. That's what I was doing at first. Then I say, no, this is wrong. I need to fix that. I hope you are happy now. I hope you guys can get that one wrong. No, not wrong. Please get it right. I'm sorry, ne? Please get it right. If you get it in an exam, hopefully you guys will get that one correct. So what is the inert? I'm just gonna try and punch it back on the calculator and see what is the inert equals to. I'm going to take my time and punch this values. 9 times 10 to the power 9 times 10 to the power 9. Oh no, 9 times 10 to the power 9. Close the bracket, then multiply, open the bracket, 2.33, which is times 10 to the power negative. Okay, this will be 10 negative what? 10 to the power negative 6. Then let's close the bracket. Everything is divided by the distance of 0.04, and then this is squared. Then minus into inside the bracket. You're just gonna put this inside the bracket just to be on the safe side, and then let's punch in that one. I hope you are also doing this on your side so that we can see if we get the same answer. Obviously on my side I'm going to get the same answer. If you don't get the same answer as me, then you need to recheck your calculator and see what you did wrong. Obviously now I'm going to get the correct answer, because I really pay attention when it comes to punching my calculator. I can't just lose the last mark. I can't donate this mark. This was to the power 8. Okay, you see, I put the bracket on top. Then I had to fix that. This is 0.1 squared. Then this gives us, let's see, 1.3. Is this correct? What did we do? Let me see. This gives us an answer of 1.30. Okay, it's 9 times 10 to the power 9. I'm just verifying everything times, okay, 2 times 2.33 times 10 to the power negative 6 over, okay, now I see a mistake here, 0.4. I said I'll get it right. Now I'm getting it wrong, and I think when I got it right on your side, congrats, né? You did well. Don't be me. Okay, and then you should learn from my mistakes. So this is 5.37 to the power 4. Can we, this is a very big number, né? When it's like this, then it tells you that this is a very big number. So 5.37, let me say mode, shift mode, 7. Let's put this to 4. I want to see something if it rounded off my answer right. So this will be 5.366. So I'll go with 5.37. Okay, I'll go with 5.37 to the power 10 to the power 4. If I round that off, né? So this is my ENET is 5.37 times 10 to the power times 10 to the power times 10 to the power 4, then nanocoulombs per second. Oh, that's it. And that's how you collected that marks. I hope you guys really enjoyed this question. Yeah, and that's it for this one.
I hope you are happy about the steps that we did to find the 13 marks. It's a ding ding ding. Get in. So let's go to question 8 and see what we have on question 8. Question 8, they say in the diagram below, we are given that the battery has the EMF of 24 and the internal resistor of 0.3. So the light bulb L has a resistance of 9.5 and R is a resistor of an unknown resistor. Ignore the resistance of ammeters and connecting wires. We can see the diagram, blah blah blah, state Ohm's law in weights. So I think now you can even see that we don't have much energy for these definitions, and I believe that you guys can find the definition on your exam guideline now, because guys, it's been a long this is a long lesson, and let's just say that Newton's law said V is equals to IR. Reason, remember the potential difference across a conductor is directly proportional to what? To the current in the conductor at a constant temperature. Just give them that and you'll get your 2 marks. When both switch S and S2 are closed, so this switch here and that switch there, we close those 2 switches, what happens? The reading on ammeter A1 is 0.8, so I'm just gonna write it down here. It's the reading there is 0.8 amperes. Okay, so now calculate the current through the light bulb L. They want us to find the current through the light bulb L. You know what I'm going to do on this problem, how I'm going to answer this problem. So to find the current through the light bulb L, I'm going to say for this question 8, okay, for this question 8.2.1, first thing first, let me try to analyze this question correctly. They want us to find the current on this bulb, and I know that the formula that we're going to use is V. It's equals to the current times the resistor. But now let's write this properly and indicate what is this current for. It's for the light bulb L, so that you don't get confused and use the total current. So this will be the current of the light bulb. Then we're going to multiply that by the resistor. We're going to talk much about that. We are coming, and the resistor is given there as 9.5. Right, we have the resistor. We are looking for that, but we don't have this. The voltage across what? Across that parallel resistor. So we need to first find V. That's the meshing. So now this will be V. It's equal to the current of L into 9.5, because 9.5 is the resistor. You see, this is how I attack the question. 9.5 is my resistor. Now I know what I need to find to calculate the current of the light bulb. I need to find V. So now, what I need you guys to note in mind is that, remember that when you work with what is this? I'm going to use Ohm's law. I'm going to use Ohm's law and say that. Okay, how can I put this? I'm trying to say I'm going to use the parallel idea, because this 13 resistor here and the resistor of the light bulb. So the 13 resistor, okay, let's say the 13 resistor and the light bulb, they are connected in parallel. So this is parallel, this is parallel. So these two are connected in what? In parallel. So since they are connected in parallel, so we know that in a parallel circuit, so in a parallel circuit, what do we know about parallel circuit? Is that the voltage V is the same. V is the same across what? Across each branch. Okay, we are happy about that. So the voltage across the BL will be what? We need to find the voltage for, we can first find the voltage. So that passes through this point. So we're going to use this information there. I'm going to use this information here. The voltage through that branch is going to be the same voltage through that part, because these two guys are parallel. So first thing first that I'm going to do is to find the voltage on that, let's call this X, let's call this Y, the voltage for the X branch. So let's quickly find that. So V is equals to the current times the resistance. So the voltage is equal to, what is the current? It's given as 0.8. This will be my 0.8, multiply that 13 resistor. So this will be multiplied by 30. So the voltage, when we multiply these two guys, we get this as 10.4 V. So what we are saying is that in parallel circuit, V is the same across each branch. So I'm going to say the voltage for Y branch is equal to the voltage for X, and it's going to be equal to that 10.4. So to find the current, we're going to substitute that V as 10.4. So I'm going to take down my formula here and say V is equals to the current of L into 9.5, and then when I do the substitution, this will be 10.4, the current of the light into 9.5. Then what's next? Let's divide both sides by that 9.5. Divide that by 9.5. The answer that we get is the current of the light bulb. Then you'll have that 4 marks. Oh, we are collecting the marks. Got like, we are taking all the marks. This is 1.09 amperes. Got, we are taking all these marks like whippy. like Sambo. Each and every question, Sambo. Each and every question, Sambo. Each and every question, Sambo. At the end of the question paper, it's a ding ding ding. Okay, let's see what we have now. What is the next question? They want us to find on 8.2.2, they want us to find the reading on the ammeter A2. The reading on the ammeter A2. So I think it's best if, okay, let's look at where is ammeter A2 now. Boy, now look at this. I need you to be smart about this now. Please be smart about this. What is A2? Can you see that the current that passes A2 is the total current? So this is my A total. So A2 will read the total current. So if A2 will read the total current, to answer this 8.2.2, I'll say that my total current, I need to take, to find the total current, look at this. Let's call this the current of the 9 resistor, or let's call this current 1. So current 1 and the current that passes through this point, let's call it current 2, and the current that passes through the light, let's call it current 3. So guys, this is how current works. So when the currents get to that resistor, this total current was splitted through those resistors, then it comes back to this point as a total current. So it passes this point as an IT, I total. Then when it reaches this point, this is where I'm not sure if it's going to move in this direction or that direction, but it has to do with the concept from positive to negative or negative to positive, where you have to understand that between these two guys, which one is positive, which one is negative. That's not what we need to focus on this lesson. So now I know that if I can manage to calculate the current for this, the current for I2, and the current for I1, I can add all these 3 currents to find my total current, which is the current that will be reading by A2. So let's quickly work on that. So I'm going to say my I total, IT is equal to I1 plus I2 plus I3. So I think now I can find my, let's work this step by step. What is the current at, we know, what is the current at, hey guys, I'm very sorry, the noise is too much. I'm just gonna wait a little bit. Okay, so when we work on this, I'm just gonna check that I need to find my I total, and then we said we're going to find the total resistance of those currents, A1, current 1, current 2, and current 3. So I think it's going to be an easy thing for us to do, because already we know the current for what? We know the current for the second one. So let's quickly work on this one. Let's quickly work on this one. So what I'm going to do, I'll say that first thing first, I need to find you see, I get distracted. So let's start with the first current, which is 9 for the 9 resistor. Let's calculate the current for the 9 resistor. Let's start there. So remember, we said the voltage is the same across, the voltage is the same across each branch for parallel. So we can use that in advantage and say VP, it's equals to the okay, the current, the voltage for the parallel is the one that we're going to use to find. The voltage for parallel was, what was that? It was, we did calculate this, 10.4. So we're going to use that 10.4 V, which is the V parallel, is the one that we're going to use for the 9 ohm resistor. So let's quickly substitute and say the voltage is equals to the current of that 9 resistor, which is current 1. We need to multiply that by what? We need to multiply that by the resistor. Okay, let's do the substitution. This will be 10.4. It equals to the current 1 into this is 9. So I'll just substitute 9. Therefore, divide both sides by, we're going to divide both sides by that 9 to find the current. Therefore, what is my current? 1. The current 1 is going to be 10.4 divided by 9. That's 1.16. 1.16 amperes. So this is the first current. And then I'm going to substitute here and say my IT is equal to, I already have 1.16 plus the I2 is already given as 0.8 if you still remember. So I'm going to add this with 0.8. Then the current for this one, for I3. Do we know what is I3? Yes, we do. We did calculate the current for the light bulb, and I think it was 1.09. If I still remember this one, this was the current for the light bulb. I'm just going to substitute it and say this was 1.09. I think this one was an easy one. So when we add this three, what do you get on your calculator? This gives me 3.05 amperes. So now look at the marks. They start from 3, now it's 4, now it's 5. This tells you that the question keeps on improving. So the resistance of a resistor R, we need to find the resistance of a resistor R. So this is my R that we're going to look for. This is the R, and we need to find the resistor of that. So you know what I'm going to do? Let's analyze what we have. Unfortunately, we don't have space for this now. We used all the space, guys. Where are we going to work this question? I don't want to go to the blackboard, because we'll be going like left hand right, and someone is going to lose interest and get more confused. So let's try to just put it somewhere. So the resistance R, I know that to find the resistance R, I'm going to use the formula that says this will be 8.2.3. The formula that I'm going to use is V is equals to the current times R. But now the V, this V here, what is that V? It's going to be the V of R. We need to find the voltage of R, and then the current that we're going to use. The current that we're going to use is the total current, because R is going to read the total current, which is the same total that will pass through A2. So this tells us that the current is something that we already have, which is 3.05. So this will be the current of 3.05 times R. We are looking for this. We don't have that. So we need to find the VR. So this is where now we have the direction. Guys, I'm going to squeeze this thing like all over the question paper. So how can we find R? So what I need you to understand is that we can find the V external. We need to find the voltage of R. So we can use the formula that says V external, the formula that says V external. So V external is equal to V external. We take the voltage for the parallel one, then we add the voltage for the resistors that are in series, and there's only one, which is R. So I'm just going to add this to R. So now, do we know the V external? Is the V external given? Nope. Is the V parallel given? Do we know what is the V parallel? Yes. Because remember, the V parallel is the one that we calculated as 10.4. So this 10.4, that 10.4, this one, it's my VP, my V parallel. So this is 10.4. So I'm going to, what's going on? V external, it's equals to V parallel is 10.4. This is 10.4 plus, we're going to add this to VR. So now what is going on here is that we are looking for VR, but we don't have this. You see? So now this tells me that I need to leave the formula like this. Guys, I'm not sure, are you following? Unfortunately, you guys can't answer me, but what can I do to solve this? Okay, it's fine, let's continue. We don't have that, the VR, but now the next step is to find V external. So remember, V external, we can use the EMF to find the V external. So I'm just gonna work this thing up here. So let's put this thing down here. Guys, I'm very sorry. Let's go to the blackboard now. Let's go to the blackboard and try to analyze this step by step. Number one, we set that V is equals to I times R, and when we substitute, we set this guy, the voltage that we are looking is for R, which is equals to this I we set is the IT, the I total times the resistance that we are looking for. So now when we did that, we said this is VR is equals to, and we substituted that as 3.05, and this is R. Right. So now when it's in this form, what do we do next? We need to find we said what we're going to do next. Let's quickly go back, and you see now, that's why I didn't want us to go like this side, this side, this side. So far we have this, and then we don't have R. We are looking for R. Now we need to find the VR. And we said to find the VR, we'll use the external one. We'll say V external. Even the music, guys, it's really disturbing. I don't want to lie. I'm not sure how this goes on your side, but unfortunately we have to finish this lesson. Hopefully you guys can hear me on your side. So this will be V what? This will be V external. It equals to V parallel plus the V of the R, because it's the only one that is in resistor. And we set that the V external, it's equals to my V parallel, which was 10.4 when we were doing the calculation, and this is VR. What are we looking for? So the one that we are looking for, I'm just gonna put it as what? As a question mark. So this is what I'm looking for, but I don't have this. So now I'm saying that to look for the V external, what I'm going to do, I'll use the EMF. So EMF, let's just say E. You just have to get the formula on your formula sheet. So E is equal to the current multiplied by R times small r. So let's do the substitution. If we continue working on this, this will be equals to, let's multiply this guy. Now, so I times R, it gives us IR plus I and small r. So E is equals to, this is your V external plus this will be your V internal. Right. So let's substitute. We know that the EMF was given on the paper. Let's go back and verify. What was the EMF? The EMF was given as 24. So I'm just going to substitute that EMF as 24. So this will be 24. It's equals to V external. It's what we are looking for, plus the internal one. So the internal one, the V internal, we can definitely find that because we know that let me go back and change this. Now let's write this as that I R, because we have the total which was 3.05. 3.05, we can multiply that with the internal resistor, the small one. So the total was 3.5, which is that guy, and then we're going to multiply this with the small r. I hope you guys are following. So now this will be the small r is 0.3 because the aim is to find the V external. So let's isolate that. 24, this guy will come this side to be negative 3.05, which is multiplied by 0.3. Whatever that we get will give us the V external. So now you just have to work that guy on the calculator and let your calculator do the magic. Then what is 24 minus 3 times minus 3.05 times 0.3? So when I put this on the calculator, what I get is 23.09 V. So I think we are almost there, because if I look at this, we have the V external so far, and then we can go back to where this equation to substitute the V external that we just calculated. So now my V external, we said it's equal to 10.4 plus VR. We need the voltage of R. Then we have the V external as what? As 23.09. This is 10.4 plus the VR. So the 10.4 goes to the other side to be 23.09. We minus that 10.4. This is equals to VR. So when you punch this two on the calculator, the voltage of R is equal to what? The voltage of R is equal to 23.09 minus 10.40. This gives me 12.69 volts. 12.69 volts. Okay, so now when I look at this, guys, so for the fact that we've managed to get the 10 point, we've managed to get our VR. We take this VR, we substitute it back there. So this is my VR, and I need to take it back to that VR to find my R. So I think you guys understand the pattern, how this works. Now, you start by listing what you have and what you don't have. Then each and every time you calculate something, you go back to the formula. We calculated this, we go back that. Then now that we substitute, we calculated this, we go back that. I think you guys understand how this works now. So now what I'm going to do is that I need to substitute my VR on the formula. VR is equal to 3.05 times R. So now where there's VR, I can put 12.69. It's equal to 3.05 into R. So this is what I have so far. I can just divide both sides by 3.05 divided by 3.05. You see, now I'm having so much fun. So what is the value of R equals to when you divide both sides? Okay, when I divide this, I get my RS. If I round it off, R is 4.16 ohms. Get in. It's a ding ding ding. Okay. Now, what is the next question? For 2 marks, switch S is now opened, while switch S1, switch S2 is now open, while switch S1 remain closed. How will this affect the reading on A2? What's going on? They say switch S1, S2 is the one that is opened. I'm trying to clear the space here so we can do the magic, because that's what we do. That's what we do best, magic. But now look at this now. Switch S1, it's opened. So if switch S1 is open, let me think about this. How is this going to affect the circuit? What happens if switch S2 is open? The branch with A1, you see this branch is removed from the circuit, because by removing the switch, nothing will happen in that part. So one parallel branch disappears. So this guy will disappear. So it disappears. Right. So now let's go and analyze on A2. What will happen to the ammeter on this A2? Because one branch disappeared now, how is this affecting A2? What does A2 measure? That's what you need to ask yourself. What? Because the question is saying, how will this affect the reading on A2? Right. So that one disappears, and how this affect A2? We can see that we need to ask yourself, what does A2 measures? So A2 measures the total current of the battery. As you can see, it measures the total current. So what I need you to ask yourself is that what happens to the total resistor? We can use Ohm's law to answer this guy now. We can use Ohm's law to answer this. So we have, let's say, how will this affect the reading on ammeter A2? Choose increase, decrease, or remain the same. We are coming to that now. So let's use Ohm's law. I know that from Ohm's law, I is equals to V over R. So now look at this. If the resistor increases, the current decreases, because the current is inversely proportional to the resistor. Okay, so now we see that if the resistor increases, what happens to the current? The current decreases. And they are asking, so we have the total current. We removed one resistor. So what happened to the resistor? The resistor decreases. What's going on? If the current increase, the resistor decrease. If the resistor increase, the current decrease. So what happened here? What happened? We removed a resistor, right? So if we removed a resistor, this tells us that the resistor decreased. Okay, I'm just going to take it like this. If I remove a parallel resistor, if I remove a parallel branch, I'm increasing the total resistor. Okay? Yeah. So the total current decrease. So the answer is going to be decrease. Okay, let's try this again. We are removing what? A branch. And if we remove a branch, remember these branches are connected in parallel. The moment you remove one resistor, you are increasing the total resistance. So the resistor is increasing, so the total current decrease, according to this formula, is directly proportional. It's inversely proportional. If one increase, the other one decrease. So we removed one branch, meaning that we are increasing the total resistor. This decreases the current on A2. So A2 is going to read a less current. I hope that makes sense. I hope everyone is happy about that. How will the brightness of the bulb be affected? By opening S2, how is the brightness of the battery be affected? So this has to do with what? To do with power, because now we are talking about brightness. So the brightness depends on power. So let's write that down. So the brightness depends on power. So P is equals to VI. So if P is equal to VI, so what happened to the total current? We said the current decreases. From the previous question, we said the current decrease. So if the current decrease, what happens to the brightness? So what will happen to the power? So this tells us that the internal resistor effect, the battery has the internal resistor of what? The battery has the internal resistor of 0.3, if you still remember that. So when the current decreases, we're going to have what we call V lost. So the voltage lost inside the battery will decrease. So the terminal voltage do what? The terminal voltage will increase. Let me just try to explain this properly, because I know that someone out there really needs these 2 marks. Then, so we said the current will decrease, and if the current decrease, now we need to talk about the internal resistance effect. So we said the battery has the internal resistance of 0.3. So when the current decreases, we're going to have the V loss, that is equals to the current times small r. And look at this, the voltage inside the battery will decrease, because the V loss is directly proportional to what? To the current. If the current decrease, this decrease what? The V loss. The current decrease, these 2 guys will also decrease. So the terminal voltage will do what? The terminal voltage will increase. I hope guys you understand. So now what will happen to the bulb? The bulb is in parallel with the supply. This bulb is in parallel with the supply. So the higher the voltage across the bulb. And this tells you that the higher the voltage, the higher the current, means that the bulb will have more power. So the bulb will increase in power. That's how you answer this one. I'm very sorry if you don't understand this one, because I see that I'm also tired on my side, and I think this is the best that I can. This is the best that I can do. Yeah, I think this is the best I can do. Right. So what I'm going to do now, okay, so let's see what we have on the next question. Question 9. The diagram below represents a simplified version of an AC generator, and okay, so the induced current flows from X to Y. We can see that in the coil, when the coil is rotated clockwise, as shown in the diagram. Okay, that's what we see there. And then now the question says, the first question, what is the polarity of A? Choose from north or south. I know someone is going to do guesswork. Please sit in the lesson and you'll be able to understand this. Unfortunately, this has to do with the right hand rule. I'm not sure how we can apply the right hand rule while I don't have a camera on, so that I can show you guys this beautiful hand. The beautiful hand that is holding the pen that we are using to make Minjik Kayonane. So unfortunately, the recording that I'm using, I don't know how to do the settings to have the camera on, but as time goes, I'm 100% sure that we're going to improve. Okay, so maybe I can try and explain this one. Since I'm the best, hopefully when I'm done, you'll understand how to collect these 2 marks. Yeah? So when we talk about the polarity, first let's use the given information. they said that the coil rotate what? It rotates clockwise. Okay, so it rotates clockwise. I'm just gonna put there. And then another thing that they tell us that the current flows from X to Y. Okay, let's say X2 using an arrow. X to Y. That's how the current flows. So now let's apply the right hand rule for the generator rule. The right hand rule for the generator rule. I hope you guys are taking notes. Have your, okay, the hand right rule is going to be, remember the thumb. The thumb. This guy here is going to tell you the motion of the conduct. This will be the motion of the conduct. Right? And then your first finger, the one that, your first finger. So your first finger, this guy will tell you the magnetic field, the direction of the magnetic field. Right. So now it's going to be the magnetic field. So now what I need you to understand is that the magnetic field always moves from north to south. And then this is one, this is two. The last one about the hand right rule is that the second finger will tell us about the induced. The induced what? The induced current. I'm very sorry that you are writing on top of our diagram, but I'll make sure that when we do, you understand everything. So now let's talk about, once you understand these 3 points, let us discuss the direction of the magnetic field. So for the direction of the magnetic field, we need the field direction that makes current to go from that X to Y. Are you listening? We need, for the magnetic direction field, we need the field direction that makes the current go from X to Y. So for this to happen, magnetic field must go from right to left. Because for this to happen, the magnetic must go from left to right. Okay, so I'm going to say Y. Now look at this. The right magnet, we said for this to move from X to Y, the right magnet, the one that is on right, will be my north. So this is my north. Let's quickly highlight that. So north, don't worry guys, I'll try to explain this again. This will be my north, and then this will be my south. So now, how did we get the north to be the other one on the left, on the right, and why it's a south? Because we said that we are saying we need the field direction to make a current go from X to Y. You'll understand when we apply the hand right rule. So for this to happen, we need the magnetic field to go from right to left. And remember here I said my magnetic field always moves from north to south. So if we need it to move from right to left, it's going to be from this point, and then it points in that direction because it always moves from north to south. So the north one should be on the right hand side because we need the magnetic field to move from right to the left. I hope you guys understand. So now the question said, what is the polarity of A? So the polarity of A, the answer is south. So the correct answer here is south. Oh, Jesus Christ. Are you guys with me on that? Do you guys understand? I don't know if there's another way to explain this, but you see, when I just feel like there will be that one learner that needs more explanation, and if I think about this, I'm not sure the best way to put this. I'm not sure to put this. Let's try this again. Let's try this again. So first thing first, we said we need the direction that makes the current go from X to Y. And then now, if we need the one that the one that goes from X to Y, let's look at the thumb. We said the thumb is the motion of the conduct, and then the first finger is the magnetic direction. So now, when this is the magnetic direction, the second finger is the induced current. Right, so when we use the handwrite rule, just know that what is this? Your thumb, it will give us the motion of the conduct. So your thumb will be pointing out of the page. So this is your thumb. We are trying to use the handwrite rule, and then if I use the handwrite rule, let's try it. Maybe someone is going to get it if we use the thumb. So on my thumb, the thumb tells us that this guy here we said is the what? Is the motion of the conduct. So it's pointing out because this has to go clockwise. Okay, so you're going to have your handwrite rule, and then you'll have your thumb pointing out of the page. Okay, so instead of out of the page, let's say you are watching this lesson, you're going to have your thumb pointing where? Your thumb pointing towards away from your screen. Okay, so when it points away from your screen, should it point away or it should point towards your screen? Wait, let's just not leave the pointing away, but let's use this. So this guy, this thumb tells us that the magnetic field, remember, it's from north to south. So can you see that the thumb is pointing where? It should be north to south, and we need what? We need to make the magnetic, we need to make the direction to go from X to Y. We need to make the current go from X to Y. And the second finger is the one that tells us the direction of what? Is the one that tells us the direction of the current. Guys, I don't know how to do this while I don't have my current. This one, just take my first explanation, then if you don't understand this, I don't know, maybe I can just do a short video that I can upload after this one. Hopefully you guys can understand how we got south. I'm very sorry. So state one way in which the induced EMF of this generator can be increased. So just know that to increase the induced, there's only one way to increase the induced EMF. There's only one way. From the generator theory, remember that the EMF we say is directly proportional to what? The rate of change of what? The rate of change of magnetic flux. If you still remember, what is this? Grade 11 magnetic flux. So since it's like this, remember, no, there's not that there are many ways that we can do that. We can rotate the coil faster. This one is the best one. We can rotate. State one way in which the induced EMF of this generator can be increased. Number one, we can rotate the coil faster. Right. So another way we can increase the magnetic field strength, or we can increase the number of turns. I know someone is going to take that one, the number of turns. Right. The number of turns. Or we can increase the area of the coil. Just give them any answer that you think it will be best. Né? So sketch the graph of the induced current versus time for one complete rotation of the coil from the horizontal position as shown in the diagram below. Okay, so we're going to plot what we call the graph of current versus time. So to plot the graph, let's check what type of a generator is this. Is this a DC or an AC? Oh, it's even easy. It's given AC generator. So since it's AC, just note that the AC generator, they produce a sine wave. So when I say a sine wave, remember the sine. How is the sine graph? How is the sine graph? So just remember the sine graph now, a sine wave. This will make sense when we draw the graph. For now, just remember that it produces the sine wave. Okay, so let's discuss the important details now. Are we going to have enough space for another question? The important details. Hi, Wenaman. Guys, I'm tired. I think we're just gonna end the lesson now at because this is too much. Then this is the best I can do, guys. Maybe I can make another lesson to complete the question paper. But let's check how many questions left. There's only one left. Come on, come on. We're just gonna stop after drawing the graph, or we can also continue and do 1.9.2. So now, the current versus time produce sine wave. The important details that you need to understand when we talk about the AC generator. First thing first, number one, just know that it starts from what? It starts from 0 at start. Okay, it's going to start from 0 at start, and also that will depend, don't worry, start from horizontal position. That's one. Number two, then the current start from 0. Number three, what we know is that then increase to max, and then it's going to come back to 0. That's how it moves. It comes back to 0, 5, then negative. Then it comes to be negative. I'll explain every step. You can even see the writing that no, this guy is not doing good. Né? Then back to 0. Okay, let's draw the graph now. Let's draw the graph. So my graph will look like this. We know that we're going to say the shape this side is the induced current. Né? So this will be my induced current. Right. So we're saying that if this is the induced, this will be the time. It starts from horizontal. Right? So if it starts from horizontal, it starts here, then it starts being like horizontal a little, and then the current starts from 0. So this is my current. It starts from 0 because we know that this is 0. So it's going to start at 0. The current starts at 0. And then it's going to, let's do it like this, because let's use the steps that I gave you guys. Let's use the steps that I gave you. I'm going to say it starts let's put it this side using the steps. It starts from 0, it starts being horizontal, then that's 1. Then number 2, the current starts from 0, already indicated that. Number 3, then increase to max. So it increased to max, it creates max there, and then back to 0, and then again negative. Yeah, and then that's it. I'm sorry, this is the graph you can give them now. So now an AC generator produces a max output. They say it produces what? A max output. So the max output, I know that they are talking about the maximum output voltage. This is my VRMS. So the VRMS is given as 340. So this is 340 volts. And then 1120 watt electric kettle operates optimally when it connected to this generator. So this guy here, it's my average power. And the P average is given as 1200. The first question says define the root square. The term root square means find that on your answer sheet, guys. Hey, it's been long. Find that on your exam guideline 9.2.2. On 9.2.2, they want us to calculate the root mean square current passing through the kettle. So we are not even far to formula sheet. I'm just gonna scroll down. The question says find the root square mean. So what they are looking for is the root square mean, which is they are looking for. What was the question? Haibu, guys. Calculate the root square current. The root square current passing through the kettle. The root square current. So we are looking for IRMS. So we need to use the formula that has current. So we are looking for what? The current. So, but when we choose the formula, we need to choose the formula that has power. And the only one that I can use is this one. Which one can we use? This one, because VRMS is given, the P is given. Now we can find the current. I hope this makes sense. Né? I hope this makes sense. Or this one, in fact, we made a mistake. That's not VRMS. Né? I think you guys can see the reason why we need to end the lesson now. Because now we are losing interest and we start making those multiple mistakes. Né? So I'm just gonna, this is not my VRS, I was mistaken. This is my Vmax, not VRMX. This is my maximum voltage. I know that someone out there really saw that. So this is my Vmax. It's equal to 340 volts. So to use the formula that says P average is equals to VRMS multiplied by the current RMS. I think you understand where is this formula coming from. First thing first, let's calculate the VRMS. So to find that, I can say VRMS is equals to, the formula is there, Vmax over the root 2. Is there on your formula sheet? The formula is there on your formula sheet. So where is it? VRMS is equal to Vmax all over root 2. So let's quickly put that there and calculate this so that we can end the lesson. So this is Vmax divided by the root 2. So VRMS will be equal to, Vmax was given as 340. So this will be 340 divided by the root 2. So I need you to take a moment, punch that on the calculator. Let me remove this here. Okay, so when I put this on the calculator, I get my VRMS to be 340 over the root 2, and this is 240.42 volts. So I have this, I can substitute it back on this original equation to find my the root mean square current. So let's quickly do that. Let's work on that. So this will be P average, it's equal to VRMS times the current. Let's do the substitution. This is the P average was given as 1.2, if you still remember. So this will be 1200. It's equal to VRMS is the one that we calculated as 240. Multiply this by RMS. Divide both sides by 240. Divide both sides by 240. Then whatever that you get, it's your RMS. So when I punch this on the calculator, I get 1200 divided by 240.42. So this gives me 4.99 amperes. And that's it. The last question says calculate the resistance of the kettle. The resistance. So I'm not gonna waste time on this one. Let me quickly check my formulas. Maybe something will come out from those formulas. They want us to find the resistance, and I'm just gonna go through these formulas and check what I can do from them. I think I'm gonna go with Ohm's law. I'm gonna go with Ohm's law. Because I have the VRMS and I have the IRMS. I don't see any Ohm's law formula in this one. So let's go back up. What is Ohm's law? Ohm's law is this one. I'm going to go with Ohm's law. But remember, we are talking about the VRMS. We're going to use the VRMS, and the current is going to be the RMS. So we can use Ohm's law and do our substitution, collect that 3 marks. Né? So I know that someone is feeling for me and say, you know what, say, I rest. Say, I can hear that now you are tired. Say, yes, I'm going to rest now. So R is equals to VRMS over IRMS. So VRMS, we just calculated that to be 240.42. This is what we calculated. So this will be 240.42 divided by our IRMS. So when we divided this, this is the one that we calculated, which is 4.99. Let's substitute that, 4.99. So when you punch this, we should get R. So if I put this on the calculator, I get my R to be 48.18 ohms. 48.18 0.18 ohms, and that's the final answer. Guys, I'm very sorry, this is the best that I can do. Hopefully I'll do another lesson, just 10-15 minutes answering the last question. So for this lesson, this is where we're going to stop. Thank you very much, guys, for sitting in on the lesson from question 1. So if this is the first time you are watching our lesson, please make sure that you subscribe, and will make sure that you feel at home. Join the family so that you can get the notification when we upload our next lesson. Our next lesson will be on a past paper, which is Mathematics Paper 2 Sub-Exam. And hopefully after that one, we're going to work on Physical Science Paper 2, which is Chemistry. Thank you very much, guys, for sitting in, and that's it for this lesson.
Okay, let's look at what we have here. Wow, this is a nice question. So November 2024, paper 1, question 9, electrodynamics. Okay, so the graph below shows the induced current in a generator. So the first question, 9.1, they want you to tell us the type of the generator. Right, so if you open the memorandum for 2024, November, you'll find that they say this is a DC, which is incorrect. The memo, that's like maybe human error or something. I don't know what happened, because by looking at the graph, we can see that this is an AC. Okay, so let me explain why this is an AC, so that you can get it right in the next upcoming exam. So this is an AC because the reason I'm saying that the generator is an AC, we can see that the induced current, okay, it's always positive. So if the induced current, it's always positive, you can see that this part is positive, this part will be negative. The induced current, it's always positive, which makes this what? An AC generator. Okay, so this shows that it flows in just one direction. Okay, so in AC, it's going to flow, the induced current is going to flow in one direction. That's why I'm going to say this is an AC. Right, let's say, how do you see that we have a DC in an exam? So maybe they give you something like this, the graph that looks like this. Then from the graph, you can see that this is positive, this part is negative. So if the generator were DC, then the induced current will alternate between the positive and the negative. So it will alternate between the positive and the negative. I hope you guys understand how to note if this is an AC or a DC. So it will alternate between the positive and the negative. And that's it for that question. So now we said that state the energy conversion that takes place in this generator, right? Okay, so now they're asking you the energy conversion, right? So remember, in an AC, the electrical, what is this? The energy conversion is going to be from kinetic to electrical. So basically what I'm saying is that this is mechanical to what? It will be mechanical to electrical energy. Right. Now, remember that the reason we're saying this is that a generator, it converts what? It converts kinetic energy into electrical energy. And this is the what? This is the case for both alternating and direct current generator. But you just have to know if it's from mechanical to electrical or electrical to mechanical. Understand? But for AC, it's mechanical to electrical. Next question, give a reason why this generator is not suitable for the transmission of electric power over distance. Okay, so if you remember this, we have electrical power. The electrical power is usually transmitted by alternating current. Okay, right, which is the AC. Right. So now, since this allows us to be able to transmit what we call a high voltage, which means that the less energy is going to be lost to overcome the resistance. And then now, look at on the graph, you can see that the direct current only flows in one direction. Since it flows in one direction, we're going to say that there is no changing in magnetic field. And if there is no changing in magnetic field, the reason why this generator is not suitable for transmission is because the power, or you can say the voltage loss, the power, you can talk about the energy loss, cannot be reduced. It cannot be reduced. So it will be too large. So it cannot be reduced. It will be too large. Right. Or you can also tell them that the power, or okay, instead of the power, you can also talk about the current. Remember the current, we said the induced current flows in one direction. So the current cannot be made smaller. So we can't make the current smaller. So if you give them that explanation, you'll definitely get the marks. Okay, so but now look at this. If maybe you go ask a person that works with the transformers, they'll tell you that the transformers, they do not use what? They do not use the AC. They do not use the AC, or we can say they cannot be stepped up or down. They cannot be stepped up or down. And that's the answer. Okay, calculate the frequency at which the coil rotates in this generator. And the frequency, to find the frequency, we use the formula that says we're going to take the number of waves, or you can say cycles, divide by time. So how many waves do we have here? So remember, a complete wave is going to start from this point and then up to that point. So that's a complete wave. So this is my first wave and this is my second wave. How many are they? 2 of them. So to calculate the frequency, we say the number of waves and then divide by the time. The number of waves, how many waves do we have? 2 of them. And what is the time that it took for this both to complete, which is 0.04. And then you just have to punch that on the calculator and see what you get. Right, I know that maybe someone can prefer to take this the grade 10 way. It's fine. You can also use the grade 10 equation to find that. You will definitely get the same answer that we got here. So this will be 0.04, which gives us 50 Hz. Okay, someone will prefer to use the grade 10 way. It's fine. That is also correct by saying that the frequency is equals to 1 over T. But for this one, remember the one is the number of waves. The time it takes for one wave to be completed. And look at this. We said that the one wave completes at 0.2. So this will be 1 over 0.2. This should also give you 50 Hz. Calculate the root mean. Define the term root square mean current, RMS. The root square mean current. So they want you to define that. You can definitely get the definition on your exam guidelines. So to answer this 9.5, they want us to define the root square mean. The root square mean current. So this is the alternating current that dissipates the same amount of energy. Okay. Alternating is the alternating current that is the alternating current that dissipates the same amount of energy. I'm just writing this down just in case if someone is watching the lesson today and they are writing tomorrow. So you can just pause the lesson, try to cram the definition now. DC current. So you can just pause the lesson, try to understand this now. Okay, so the RMSR current is the alternating current which dissipates, or you can say it produces the same amount of energy as the equivalent direct current. So this is the official one, is the official definition that you need to put on your that answer sheet that you'll be given tomorrow or whatever when you are writing your exam net. Calculate the root. Okay, calculate the root square mean current delivered by the generator. You'll definitely find the formula at the back of your calculator or your please don't put formulas at the back of the calculator. They don't allow anything, but because they'll give you the formulas. So they want us to find this current here. I'm just gonna highlight that. They want us to find this. So how can we calculate that? I'm just gonna rewrite my formula down and I'll take it from there. So let me go back up. I'm going to answer 9.5 here. So 9.5 want us to find the root mean square current. The root mean square current, which is the I RMS, it's equals to the I max over the root 2. And this is 3 marks left. So by writing down, already you have a mark for that formula. Okay. So now the maximum current, the I max is the maximum current, and you can just read that from the graph, and then we can use this equation to calculate. Simple. The maximum one, which is 1.2. So this will be 1.2 divided by the root 2. Then we punch that on the calculator, we get the RMX. The current, your answer should be in amperes, right? So I'm going to take the 1.2, divide that by root 2. This gives us an answer of 0.85. 0.85 if we round it off to 2 decimal places. 0.85. Don't leave your answer like this. Put the SI unit to show that we are talking about current. So there's a mark for the correct substitution and mark for the final answer. Right. So I think electrodynamics is easy, but it depends on what you are given. Sometimes it might be difficult if you are given. It depends on what you are given on the question, and because if they bring it like this with the graphs, the questions are very easy. So now the graph shows below, okay, shows how the induced currents varies with the time after a change was made to the operation of the generator. So there is a certain change that was made, and the question wants you to describe the change that was made. You just have to look at the difference between these two graphs. So we had 2 waves, then now we have 1 complete wave. So you can see that we had 2 waves at first, now we have 1 complete wave. So what is that telling you? You can see that the change was made is that they halved. Look at this 0.6. At first we have 1.2, we moved to 0.6. What is that telling you? They halved the induced current. So the induced current was halved. Just say on your calculator 1.2 divided by 2, you'll get 0.6. So they just said half that 1.2. So they halved the induced current. Induced current, it was halved. And then the next one, maybe you can also talk about the how will this affect the graph. If you have the induced current, this is going to affect the period for each rotation. So the period increased from 0.2 to 0.4. So to complete one wave, at first it was 0.2. But now that the induced current is halved, this increased the rotation. So this tells you that it will take 0.04 seconds for the wave to be complete. You understand? So you need to be specific and tell them what you see on the graph. So the speed of the rotation is halved, and then the frequency was halved, or you can say the period was doubled. Okay, so they halved the induced currents, the speed of the rotation was halved. Simple. Or you can say the frequency was halved. It's fine. It's up to you which one you want to go with. And that's it for this question. This was an easy one. Easy marks. Looking at this was like easy 13 marks. Right. The question won't be easy if you are not well prepared, ne? And that's it for this one. Okay, this is what I want to work on now. This is physical science paper 1, ne? This one is from the 2025 June question paper of the Gauteng paper, ne? So they say that you are given circuit A and circuit B are connected as shown below. We can see that, and they say both circuits, the same battery is used, and all resistors are identical. All of them, they have the resistor of 3. All of them, R1, R2, R3. Even on that circuit B, R1, R2, and R3. All of them, they have the 3 resistor. Let me just go and put that on there. Let me go and put that on the drawing so that you guys don't forget this. Right? So this one is also 3. The resistor of this one is also 3. Then this is 3. This is 3. This is 3. Okay, so they said the battery has the EMF and the internal resistor of an unknown value. The voltmeter and the ammeter readings are indicated. Okay, first question. Define what is power. Okay, you can write the formula down for power. Use that formula to define it. Né? So it's the rate at which work is done. Power is the rate and that's the formula for power. Question 2, for circuit A. So we only focus on circuit A to answer 9.2, not question 2. 9.2, we only have to focus on that circuit A. What will be the current through the resistor R2? Guys, look at this. R1 and R2 are connected in what? In series. So I just want to explain something. Right? This is your I total. This is your total resistor, which R1 will read the total resistor of 2.4 amperes. Right. But now, remember what happens when the total resistor goes into resistors that are connected in series. The resistor will divide according to the resistors. Oh, the current will divide according to the resistors. Okay. But in this case, I don't want to go into too much details because we can see that these two resistors are equal. So this total resistor, it will be divided into 2 equal parts. So each resistor will read 1.2 amperes. Each resistor will read 1.2 amperes. So I don't want to waste time on that. they say that what will be the current through R2. So R2 will read 1.2 amperes. So this tells you that the 2.4, it will be divided into 1.2 and 1.2. Okay, so now remember that the current moves from the positive one. So you just have to check between this guy and that guy. Which one is the bigger one? The bigger one is positive, the small one is negative. So the current moves in that direction. So this tells you that this, when the current gets to that point, it will divide. Then the 1.2 will go that side. Then the 1.2 will go this side. So on some of my upcoming lessons, I'll explain how will the currents divide if the resistors are different. But in this lesson, I just want us to only focus on what we are given, because if I give you too much information, you'll be confused on what we are currently working on. Okay, so now they want us to the next one, 9.2.2. So on 9.2.2, they say calculate the power dissipated by both R2 and R3. We are still in circuit A. And let's say you don't know what is going on the question. You don't have to understand, but let me teach you what you need to do if you don't know what is going on there. So I'm going to say power. They want me to calculate power. We know that power is P. And then I'll go on the formula sheet. I'll definitely go to some of the past papers, maybe go to the formula sheet. Let me quickly go to the formula sheet of this question paper, and then I'll go where it talks about the electric circuit. I'll indicate all the formulas that have P. This is the formula for 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 P. Then now you don't know which formula you need to use yet. Then let me help you how to choose the formula. Okay, so when I go back this side, the set calculate the power in both R2 and R3. I'll look at what I have in that R2 and R3. So now look at this. I know that R2 and R3, they will read the total current of that 2.4. So I'm going to write this down, that the I total for these two guys, the R total for these two guys is going to be 2.4 amperes. So this is what I know so far. And then both of them, they will have the voltage of, you see this voltage is for both R1, is for both R3 and R2. So they have the V of 3.6. So this is what I know so far. Then I'll go and choose the formula that has the I for current and V for voltage. I for current, V for voltage. I can use that formula, and then I'll explain if, let's say, you want to use this one. We are coming to that, but the easiest one is to take what you are given, which is the voltage and the current, and I'll definitely use that one. Let me quickly do my substitution. So to calculate the power, I'm going to say P is equals to we set VI. Then you just have to substitute what you were given. We know that we set that the voltage, that's 3.6, and then the current is 2.4. Then you going to punch that on the calculator, see what you get when you punch the 2. So it's going to be 3.6, which is multiplied by 2.4. So this gives me an answer of 8.64. So that will be my power. So the power is 8.64 watts. So now let me indicate okay, first thing first, the formula, important, there's a mark for the formula, right? And then for the substitution mark, and then for the final answer mark. So now I know this looks like this is an easy problem to work on, but when you look at the final answer, let's say you forget to write W because you don't remember the SI unit for power, then you're going to lose the mark. You can't say 8.64. What are you talking about? What is this 8.64 for? So always in physics, the final mark should have an SI unit. Okay, so And that's there are some of the questions where the final mark should not have an SI unit. For example, the coefficient of static friction, the coefficient of kinetic friction. You see, the coefficient doesn't have an SI unit. Okay, so now this will be the formula. There's a mark for formula, mark for the substitution, right? So now another one that we can use. Let me say maybe you prefer to use this question. P is equal to I squared times R, or you can go for this guy. You can also go for this guy because these two formulas, we have the current, we have the V. So let me explain what you need to do. The only thing that is missing is the resistance, is the R total. But when I go to the question, they said the power dissipated in what? R2 and R1. So you'll need to find the total current on what? The total current for R2 and R1. And if I look at that, they are connected in series. So it's going to be 1 over R. It's equals to 1 over the first one. We add the second one. So if you choose to use those two formulas, you'll have to first calculate the total resistance for those two currents. And then when you do the substitution, this will be 1 over both of them are 3, and this will give us 1 over R to be 1 over R. Hey guys, I'm sorry. I think I'm going to use a calculator for this, but I think this will be 2 over 3. Ne? This will be 2 over 3. Yeah, I think that's 2 over 3. 1 over 3 plus 3, that's 2 over 3. And then, okay, we're going to add 1 over 3. This gives us 2 over 3. So this tells you that the 1 over R is 2 over 3. Therefore, you can conclude and say R will be the reciprocal of that, which is 3 over 2, and R will be just 1.5. So this is the total resistor for those two resistance. And then if you choose to use that formula, one of those two formulas, let's start with the first one. We can start with this one and see what we get. So I think that should give you the same answer. So this will be power is equals to, let's start with the one that says V squared over R. So the voltage we set is 3.6. This will be 3.6 squared. Divide that by R, which is 1.5. And this should give you the same answer of 8.64. You can also confirm that on your calculator. Then let's say maybe someone preferred to use this one. Power is equal to the current squared R. So the current we set, the total current is 2.4 squared, then into 1.5. This should also give you that same answer. Right, I'm just going to move to 9.3. So on 9.3, we're going to focus on second B. First question, 9.3.1. Calculate the energy that is used for resistor R1 if the current flows for 10 minutes. Remember, I said even if you don't understand what is going on the second, you can still get the questions right. Just look at what they are looking for. The energy. What is the symbol for energy in physics? The symbol for energy is W. The symbol for power is P. Then you'll go to your formula sheet, look for all the formulas that has W. You tick all those formulas. Okay? Then you're going to choose the formula that has what you already know. The set for resistor R1. We know that R1, resistor R1 is equal to 3 ohms. Okay, so if the current flows for 10 minutes, and then we are given delta T, which is 10 minutes. Remember when we calculate energy, the time should be in seconds. So we need to take that 10 minutes, convert it in seconds. So we know that 1 minute has 60 seconds. So we can take the 10 multiplied by 60 and see what you get. So this will be 600. So that's what I'm going to do. Immediately when I see minutes, I convert so that I don't forget to convert that. So this will be 600 seconds. Then I have the resistor, I have delta T. Let me go and look at my formulas. I have the resistor, I have delta T, and then which formula will work? So let me start with the first one. This one won't work because I don't have the charge there. And then looking at the next one, I have the voltage, I have the current, I have delta T. So this one can work. Look at this one. I have the current, I have the okay, will this work? We have the current. Do we have the current for R1? Yes, I think we do have the current and the resistance, the time. That will also work. And then even this one will work. So I'm just going to choose any of these formulas to find what I'm looking for. Né? So let me take the first. Maybe I can go with which one? Okay, let me just choose the formula that I'll go with. Maybe this one, because all these formulas will give me the correct answer. So now I'm just going to just work it out here and say the energy is equals to the current squared, the resistance times the time. Then you just have to substitute the current on R1. So remember we said when I look at this, what was the question? Calculate or the energy used for R1. Okay, so I know that for R1 the resistance is 3. And what is the current? Oh, guys, I'm so sorry. We are on circuit B. I can see that. We are on circuit B. So the R1 is this one. And now what will be the current for R1? So look at this. The total current is 1.26. So all of these resistors they will read the same current. All of them. They will read the same current because they are connected in what? They are connected in series. All of them, they will read the same current. So now I know that the current for R1 is 1.26 for that 3 resistors. So I can just substitute and say this is 1.26. This is squared multiplied by the resistor, which is 3. The time is 600. Then you punch that on the calculator. Let me see what is that giving us. So this will be 1.26, which is squared multiplied by 3, and then multiply that by, I think this is going to give us a very big number. Né? Okay, let's see. This gives us 2857.68 if we round that off already, or it's already rounded off. Okay, so this will be 2857.68 joules. So also indicate the SI unit for that, because when they mark, they'll give you a mark for the formula, mark for the substitution, and a mark for the final answer. Right, going to the next one. How will the current be affected if R1 bent out and was not removed? So this guy, this is bent out, but it is not removed from it is not removed from what? It is not removed from the circuit. So remember we said that the bigger one, it will be positive, and the small one, it will be negative. And then we said current move from positive to negative. So this tells you that current will be stuck here. It won't be able to pass through those other resistors. So the current will be stuck. So what happens? Right only increase, decrease, or remain the same. We need to focus on how will the current be affected. So no current will go through the circuit. This tells you that the current will decrease. Okay, as there will be no current that is going into the circuit. And they want you to give a reason. You're going to say, since that one is blocked out, no current will go through. Will go through the circuit. Right. So now, if there is no current that will go through the circuit, what will happen is that the voltmeter, we know that the voltmeter has what? The voltmeter has a high resistance and will not let current pass through. So the voltmeter has the reason that the current won't pass through is because the voltmeter has a high resistance and it will not let the current pass through. 9.4, they want you to define the EMF. So EMF, this is the maximum energy provided, or you can say the work done by a battery per unit charge. So the EMF is the work done, this is the work done by the EMF, the work done by the battery per unit charge. Per unit charge passing through it. Okay, I'm very sorry guys about the writing there. Through it. So last question, 6 marks. Why is this question 6 marks? Let's see what is going on this question. Because once it says 6 marks, there's too much work to be done because of the mark allocation. Resistor R1 is replaced by a new 3 resistor. Oh, so remember we said this resistor is burned out, then now it is replaced. So meaning that it's back, we have a new resistor, it's back. So now when it is replaced, let's see what they want us to do. So we have the that resistor back, the one that was removed, it's back. So now they want us to calculate the EMF and the internal resistor of the battery used in circuit A and circuit B. So let's say that I know that the formula for EMF, you'll get this formula at the back of your question paper. Let me just go on and also remind myself of the formula. The formula of EMF, E is equals to the current into R times the internal resistor. So E is equals to the current into R plus small r. So by looking at the question wants us to find EMF, which is something, this won't be easy for us to do because we don't have the internal resistor. We need to first find the internal resistor. How are we going to find the internal resistor? We can say, okay. When I look at this, okay, go back to, I just want to find a way because this looks like more complicated. Let me go back to the diagram, because if I don't have this, I can use simultaneous equation. I can use the EMF of this battery and that battery, but I'm not sure if I'm on the safe side to do that. Then I go back and check. So first thing first, I look at the batteries. Okay, the batteries look similar, and then in both circuits the same battery. Okay, nice. Look at this statement. Wow, this is good. Right, you see, it's even when I was still in high school, when I do physics question and there's something that doesn't make sense, I go back to the statement. Look at this. I'm looking for where they are talking about the battery. We know that EMF has to do with the battery, right? So they say the same battery is used. So E for this, E for A, it's equals to E for B. Then this gives me the right to just equate the two. So I'm going to first form an equation from circuit A. For A, what will be the internal, the EMF? So EMF is equals to, I'm going to use this formula and substitute. So the current, we know that the total current for that one, we said for A, the total current is just 2.4. So I'm going to sub in that 2.4. Remember, the 2.4 is multiplied by the R. We need the total resistance. Né? So the total resistance we add is going to be R1. Then we add the total R for parallel. So it's going to be R of series plus the R of parallel. And we just calculated the R of parallel to be 1.5. So we're going to take the 3, we added that with 1.5, which gives us 4.5. So the total resistance for A is 4.5. Remember, this R, it's your R, this is your R total. So this will be 4.5. Okay, we take that 4.5, we add it with small r, then I'm going to equate and say this is my equation 1, and then I'm going to do the same for B. E is equals to, for B, I'm going to say it's equal to the total current for B. It was 1 point something. So the total current 1.26. Then let me go and sub in that value. So this is 1.26 into the total resistance. We just have to add all this resistance. So it's going to be, the total will be R1 plus R2 plus R3, since they are connected in series. So it will be 3 plus 3 plus 3, which gives us 9. So this will be 9 plus R. Then we said that the EMF is the same. This will be my equation 2. We said that the EMF is the same for both circuits. So we can equate the two equations and say 2.4 into 4.5 plus R, it's equals to 1.26 into 9 plus R. I don't know the best way to do this, if you can multiply out of the brackets first, and or maybe you can just, I don't know. You know what? Let me just multiply the bracket this side and see what I get. 2.4 times 4.5. Okay, let's say 2.4 times 4.5, 2.4. I'm multiplying out the bracket with that 2.4. This gives me 10.8, so this will be 10.8 plus 2.4 times R, that's 2.4 R. It's equal to 1.26 times 9. 1.26 multiplied by 9. That gives us 11.34. So this will be 11.34 plus 1.26 R. So I'm going to take this 2.8 and move it to the other side. Ne? So I'm going to take this 2.8, move it to that other side, take the 1.2 to this side. So what is that giving me? So this will give us, let's quickly work on that. This gives us 10.8. We subtract the, oh, we said that 10.8 will go to the other side. So this side I still have 2.4. So from this 2.4, I need to subtract something, okay? Oh, okay. So I'm going to take the 2.4 R, subtract 1.26 R, because it goes to the other side to be negative. And then we take the 11.34, we subtract the 10.84. What is 2.4 minus 1.26? Let's see, 2.4 minus 1.26, that gives us 1.14. It's equals to 11.34 minus 10.8. That is equals to 0.54. This is R, 0.54. Divide both sides by that and to find R. So I'm going to divide the 0.54 by 1.14. So divide the answer by 1.14. This gives us an answer of the resistance to be 0.47. That's the resistance, 0.47 if we round it off, okay? So the internal resistance is 0.47 ohms. Okay, but now the question said find the value of EMF and the internal resistance. So already we have the internal resistance. We can just come back to this equation and do the substitution to find the final EMF. So the EMF, because the EMF will be the same for both of the circuits, so I can either use circuit A or we can use circuit B. So this will be the current for A. if I use A, the current will be 2.4, right? Into the total current for A, it will be 4.5, then plus R, which is the one that we calculated as 0.47. Right. So E is equal to, I just want to rewrite that equation, okay? 4.5 plus 0.47. Therefore, what is the EMF equals to? Let's go back to the calculator. 2.4 into 4.5. We add 0.47. 11.928. So the EMF is 11.928, and that's the answer. So guys, I need you to go and do this for me. Now, please do this for me. So remember, E, it's a battery, so the answer should be in V. So guys, please do this for me. Remember, I just calculated the EMF using A. I need you to calculate the EMF using B. Drop in your comments and confirm with me if you get the same answers when you use B. So remember, when you use B, the current should be 1.24 and the total current should be 9. Please, 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 guys, go and confirm by substituting your internal resistance of 0.47 and tell me if you get the answer. I need to see you guys dropping all the comments. And if you don't get it right, if we don't get the same answer, then this will tell you that there's something wrong with whatever that we did. And that's it for this one.
Question 2. They say that a crate of mass 25 kg slide down a rough inclined surface. So now on this question, they said it slides down a rough inclined surface at a constant speed. So the constant speed means that the acceleration of this is 0 meters per second. Very important for you to note that down. Right. I'm sorry. There's a constant speed, and okay, so the acceleration is 0, and we have the velocity. So this is the velocity. 2 meters per second is the velocity. So please don't confuse the velocity with the acceleration. Towards point A. So this box here has to move from that point to point A. And then they say, while the force F acts on it. Can you see where is this force going? The force is pointing up, but the box is still moving. So this tells you that they are not applying enough force to prevent the box from sliding down. They say that this is parallel to the incline as shown below. A constant kinetic friction of the force of 40 newtons. So we are given Fk. The kinetic friction as 40 newtons. And then it acts on the crate when the plane is inclined at an angle of 30 with the horizontal. We can see that. Let's answer the following questions. So the first question says that they want us to state Newton's first law in weights. Please make sure that you consult the exam guideline on how to state Newton's first law. So Newton's first law says that a body will remain in its state and which state are we referring to? The state of rest. The state of rest or motion at a constant velocity. At a constant velocity. Right. Unless a non-zero resultant force acts on it. Unless a non-zero resultant force acts on it. So guys, I need to give you a tip when you work with physics questions. This is how the physics questions work. If they say state Newton first law, just know that most of the questions that you're going to answer after that will be based on Newton first law. And remember, Newton first law is F net, it's equal to 0. But we'll keep on reminding you on that one. Let's start with the 2.2. Draw a label free body diagram showing all the forces that are acting on the crate as it moves towards point A. So we need to indicate all the forces. So if you look at this, we have F going up, and then we know that this is on incline, is going to have the weight that is parallel to the horizontal, and we call that weight Fg parallel. But now these are not the only forces. We also have another force acting up, which is the force of friction. Why? Because the box moves down. So remember, the force of friction always acts in an opposite direction of the motion. Then we're going to have the weight acting down. This is my Fg. Then I'm going to have what? My Fn, my normal force. Right, I'm just going to draw that free body diagram here and say this is my 2.2. So on 2.2, we are saying we have there the Fk going up, which is the kinetic friction, and we have F, which is the applied force, and then we have Fg parallel acting down. Then there's a weight going down there. So I think if I put it like this, it looks like it's not on incline. Let's quickly fix that now. Guys, I'm not on fire yet, but I'm just doing quick homework so far. So this is my kinetic friction, and then this will be my guys, I'm very sorry, what is this? Okay, so this will be my force applied, and then the force that is going down is Fg parallel, and then we're going to have the weight going down. This is Fg. Then the normal force will be perpendicular to the surface. Okay, I hope when you draw this, I'm just gonna remove my component. Let's avoid also putting the components when you draw. So I'm just gonna leave it like this because this is 4 marks and I should give them 4 forces. Right, the next question, which is 2.3, calculate the magnitude F. They want us to calculate the applied force, so I'm not going to stress much about that. First thing first that I need you guys to pay attention on is what is the question saying. The question says calculate the magnitude of F, and F is a what? It's a force that is horizontal to the surface. So you need to draw the free body diagram indicating all the horizontal forces, which is your Fk going up, and then your force that they want us to calculate going up. Then we have the Fg parallel going down. So now we're going to say F net is equals to Ma. Right, so I need you to remember that they said that this moves at a constant speed. The acceleration is 0. So therefore, your F net is just 0. Then we take direction. I'm going to choose up as positive, meaning that all the forces that are going up, then we subtract all the forces that are, oh, no, I won't take up as positive because I forgot that this object is moving down. So I'm going to take down as positive. The direction of the motion as positive, it's always the best. So let's take down as positive. So all the forces that are going down, which is Fg parallel, we minus all the forces that are going up, equate this to 0. So now I think since you are preparing for final examination, you already know that Fg parallel is equals to mg, the sine of theta, and Fg perpendicular is equals to mg, the cos of theta. Right, so the Fg parallel, where there's Fg parallel, we're going to substitute. So I think I'm not sure if we're going to have enough space to work this thing. I don't know, but let's try to keep going. So we're going to say this is FG parallel. We just said this is what. Let's quickly change the marker so that we don't make a mess. So FG parallel is mg. The sine of theta, we minus fk minus f, this is equal to 0. So if you understand where is this equation coming from, we're just gonna move it down there. We're just gonna move this equation down and solve for that, what they are asking us to do. So let's rewrite that equation. We said we're going to have mg, the sine of theta is equals to, okay, I'm just gonna name this as 2.3. 2.3 it's mg, the sine of theta minus fk minus f is equal to 0. So now I need to do my substitution. What is the mass? They said this is a 25 kg crate, so the mass will be 25 multiplied by g, which is 9.8, the sine of that angle, which is the sine of 30 degrees, minus the frictional force, which was given as 40 newtons. So I'm going to substitute that as 40. So we're going to subtract 40 minus f, this is 0. Right. So remember that is equated to 0, and I'm very sorry about that mess. Né? Please forgive me. So now this will be equals to, I have f to be equals to, so I'm just going to move the f to the other side to be positive. This is 25 into 9.8 sine 30 minus 40. You punch that on the calculator, you'll have your f as what? Let's quickly put that on the calculator. So what is the value of f? That's 25 times 9.8. 25, 9.8, the sine of 30 minus 40. So I get my f as 82.5. 82.5 newtons, and it's going up. That is my force. So just in case the next question wants us to use this question, I'm just gonna highlight it for now. Né? Right, and that's it for this question. Let's see what we have on the next question. Oh, that was 2.3. Now they say when the crate reaches point A, now this crate is at point A. We can see from the diagram, you see now the crate is at point A, F is removed. They removed that applied force. So we no longer need this. And the angle of inclination is decreased to theta. Look at the angle is decreased to theta from 30. They change the angle to theta, so that the only thing that you need to understand is that the angle decreased immediately, so that the crate continue moving at 2 meters per second towards point B. So now the crate is moving to point B. Okay, use the relationships. You see now relationships. Some of you guys, I know that you are in relationships. So now when I say relationship and you look at the lesson, there's still 5 hours. And now you have a relationship that you need to attend. Hey, don't stand up, ne? Please sit down. Let's finish this lesson. Forget about that relationship. So when I look at this, I'm going to say the relationship between the forces acting on the crate between the points. Oh, they want us to use the relationship between the forces acting on the crate between A and B to show that UK is equal to sine theta all over cos theta. Alright guys, I'm going to have a problem with this one because I don't know what they want me to do, but look at how I'm going to analyze the question. First thing first, they said UK, the coefficient of kinetic friction. Where do we get that coefficient of kinetic friction? Where is that guy coming from? So I know that the UK comes from the formula that says frictional force is equals to the kinetic friction times the normal force. Okay, so if it's like this, how do I bring theta on this equation. Let's think about it. Ne? Let's think about this. What is the normal force equals to? Because this is uninclined. So remember, if this is uninclined, when we draw the free body diagram, the normal force acts up, and then the force that is opposite to the normal force, that will be your Fg perpendicular. Then let's go back up. Remember, we said what is Fg perpendicular equals to? It's mg the cos theta. Okay, now I have the cos theta. I can celebrate because I can see that I'm going somewhere. Ne? So I'm just gonna write this properly. Then we'll try to explain that again. We'll try to explain that again. We said Fk is equals to Uk times the normal force. And we're saying that the normal force, look at this, the normal force on incline is equals to the Fg perpendicular. I think you understand why, because these are horizontal, these are vertical forces. So we're going to say up as positive, then we take the normal force, we subtract the force that is going down, which is Fg perpendicular, equate that to 0. So what do you get when you solve for normal force? Can you see that the Fg goes to the other side to be positive, which gives us Fg perpendicular. Normal force is Fg perpendicular. So where there's normal force, we can substitute. We set Fg perpendicular, it's mg the cos of theta. So where there's normal force, we can substitute this as mg the cos theta. So now look at this. I have the cos theta, and now I have the UK. How do I bring the sine theta into the equation? How do we bring that? I know that the only way in physics, especially in Newton's law, where we can get the sine theta is from this formula, the Fg parallel. What is that has to do with this? So I'm going to go back and say, no man, the Fk is a horizontal force. So if the Fk is a frictional force and it is going up, how can I work on that? So I know that if I draw the free body diagram indicating the forces that are acting on the crate, this is moving down, the Fk is moving up. This will be my Fk, and another force that acts on that is what? Fg parallel. Oh, now this makes sense. Remember, using Newton's law, this is equal to 0. So I'm just going to work on this now and say for 2.4, I can say that F net is equal to 0 because they said this moves what? At a constant velocity. So now I said we take down to be positive. And if we take down to be positive, we're going to say that all the forces that are going down minus, look at this, I'm looking at that free body diagram, minus all the forces that are going up. So now I know that I need to bring the Fk and what? And the Fg parallel. Why? Because the Fg parallel is the one that will bring us that sine theta. We need to put this in one equation, and the only way to do that is to use Fg parallel minus Fk, like F net is equal to 0, equate this to 0. Therefore, my Fg parallel is equal to the Fk goes to the other side. Let's substitute. What is your Fg parallel? So Fg parallel is mg the sine of theta. So this will be mg the sine theta, equate this to Fk. So now on Fk, we know that the normal force is mg the cos of theta. So my Fk will be equal to the coefficient of kinetic times mg the cos theta. So I have to substitute that. Where there's k, we need to put this as the coefficient of mg times the cos of theta. So what is next? The next thing is to solve for the UK. We can divide this side by mg, the cos theta, divide that side by mg, the cos theta. So now what happens when you divide both sides? these two guys, the mg cos theta cancels. This side, the mg and the mg cancels. Therefore, we've managed to show that the UK is just the sine theta over the cos theta. I'm sorry guys about the space, but I think if I can give you the notes like this and send you this PDF, that's when you're going to be like confused, that's when you're going to be confused. But since you walk with me step by step, then you understand why we have 2.3 there, why we have 2.4, why fk equals. So I think everything makes sense. So we've managed to do that. We've proved that UK is equals to sine theta over cos theta. So on 2.5, oh nice, this is the last question. 2.5, the coefficient of kinetic friction between the crate and the inclined. So we are given the coefficient of kinetic friction as 0.19. So they are saying that UK is equals to 0.19. Using the identity that sine theta over cos is tan, calculate the frictional force as the crate slides from point A to B. So you know what I'm going to do? Let me avoid the identity for now and try to understand what is the question saying. The question says calculate the frictional force. So now you're going to write the formula for frictional force. Which formula is for frictional force? That formula. You write it down and say, I know that Fk is equals to mg. Oh, it's UK times mg, the cos of theta. This is our Fk, if you still remember. So on that Fk, we're saying Fk is equals to the coefficient of kinetic friction, then mg, the cos of theta. So definitely this will be 2.5. So now we can see that we have the UK, which is given as 0.19, and then the mass of the crate is 25, and this is 9.8. So the cos of theta, this tells you that to find Fk, you need to first calculate theta. So that's why they gave us that identity. Then I'll go back and say they said sine theta over cos theta, I can write it as tan theta. But we know that sine theta over cos theta is what? Remember this, it's sine theta over the cos of theta, and it's equal to 0.19. We just proved that part. And then they said we can say sine theta over cos theta is equal to the tan of theta, it's equal to 0.19. You know, if I was the one setting this question paper, you know what I was gonna do? I was gonna say hence, and I was not going to remind you that part, that the identity, just to check if you know the identities from maths. So I was not gonna tell you, and then maybe I can say this is 4 marks if I was the one doing the question paper. Unfortunately, that's not me setting the question paper, so it's much easier, right? So now when it's like this, I can find my angle theta using the tan inverse. So we can say that theta is equal to the tan inverse of what? That 0.19. So when you punch that on the calculator, what is theta? Let me quickly do this. The tan inverse of 0.19, that's 10.76. 10.76 degrees. So now that I have this, I'm just going to substitute it here on cos theta, which is 10.76. So when you punch this whole thing on the calculator, we should get our Fk, the kinetic friction, the answer for 2.5. So I'm just going to put it on my calculator. This is 0.19 times 25 multiplied by the cos 10 times 76, and this gives me 47.323, 45.73 if we round it off, 45.73 newtons. And that's it for this lesson. I'm very happy that this wasn't easy. Imagine if they just give me to write this question paper. It's easy, and I pray that even the question paper for this year becomes like this easy. Né? So the reason most of the time some of the questions are easy, are difficult, or you make mistakes, you guys panic in an exam. Don't panic, because your brain won't function well. Okay, let's see what we have on question 3. Okay, so now let's continue on question 3. So on question 3, they say that a ball is dropped from point A and reaches point B in h meters below point A. So in a what? In time t. So the time from this point to that point, we have the time as t. That is t. So they say that the ball takes 2 seconds. So the ball takes 2 seconds to fall from B to point C. So from this one to this, the time takes 2 seconds. So that is delta t, 2 seconds. And then the distance from point B to point C. From point B to point C is given as 8 meters. See the diagram below. Ignore the effects of air friction. Define the term free fall. Free fall is a motion under the influence of gravity force only. Okay, the motion under. The reason I'm also writing this definition is that, remember we said we're going to answer all the questions on this paper. So it's a motion under the influence of gravity of gravity. Let's say gravitational instead. Gravitational force only. Then you'll get your 2 marks. So the next question, show by means of calculation that the time t is equals to 1 second, and this is just for 2 marks. I think we can try to analyze the question. Maybe we'll be able to answer this one the easy way. So now what I'm going to do, I'll look at, they said by means of calculation, show that the time t is equal to 1 second. What is time t? The time t is the time the ball traveled from A to point B. We need the time it traveled from A to B. So the time it traveled from A to B, we need to know the information that is given on that path taken. Okay, so now if we manage to analyze the question correctly and know our data, then it's going to be a ding ding ding, right? So now if we work on this one, let's see what we have on this one. I'm going to say that from A to B, what do we know so far about from point A to B? First thing first, we know that here it starts at rest because they said it is dropped. So it starts with an initial velocity of 0 meters per second. That's what we know. And then we know that from A to B, the acceleration A is equals to 9.8. Let's choose the direction. I'm going to take down as positive. The reason I say let's choose the direction is because I need to understand if my acceleration will be positive or negative. So since it's down, acceleration always acts down. So this will be 9.8 meters per second squared. That's my acceleration. And now we are looking for what? For t. So I'm just gonna say we are looking for delta t question mark. So which formula can we use? Because we know that delta y the distance traveled from A to B, it is given as h. Let's first use this information, then we'll take it from there and see what we get. So now we need to choose a formula that doesn't have a V final. So if we go to the formula sheet, I'm very sorry that we need to scroll all the way down, but trust me, this is for the best. I need you to understand. Okay, so let's look for the formula that doesn't have V final. This one, it has V final out, V final, that one on work. And then let's go this side. Do we have a V final? No. This is delta y. This is the formula that we can use. Delta y is equal to V initial delta t plus 1 over 2a delta t squared. So we have the formula. Let's go back up and see what we can do about that formula. Okay, so now on this one, we're going to say delta y is equals to V initial delta t plus a half a delta t squared. So do the substitution. Delta y from A to B is given as h. Remember, delta y is h, so I'm just going to say this is h. It's equals to V initial is 0, which will make all this to be 0. So I'm just going to substitute that as 0, because anything multiplied by 0 is 0. Then we add 1 over 2 into 9.8. Then what is delta t? The time from A to B, delta t is given as t. So the time is t. So this tells you that you need to substitute that to be t squared. So let's quickly work on h. What is h equals to? H is equal to 1 over 2 times 9.8, which is 4.9. So this will be 4.9 t squared. Guys, how can this help us? Because I'm trying to understand how can this information help us. We need to prove that t is 1 second. So let me think. Just give me a second to think about this. But let's do it together. By means of calculation, show that the time is equals to 1 second. Okay, and now I know that if this is point A and this is point C, we can find the time it takes for the ball to travel that. So if this is t and this side is 2 seconds, what will be the time? So this tells us that t from A to C, the time will be t plus 2. Then we can use that to find what? We can use that to find delta t. So what I'm trying to say is that let's calculate the distance traveled by that ball from A to C. Then we're going to use the same formula that says delta y is equals to V initial delta t plus half of a delta t squared. Let's substitute. What is the height? Please pay attention. From A to C is going to be h plus 8h, which is 9h. Equate this to V initial. It start at 0, which will make everything to be 0. This thing is 0. I'm not going to waste time on that. Then plus 1 over 2. The acceleration is 9.8. Now, delta t from A to C. We said that the time it will travel from A to C, delta t will be that t plus the 2 seconds. So where there's t, we need to substitute what? T plus 2, and this is squared. I'm sorry, let me quickly rewrite this equation. Right, because I don't want you guys to get lost. I don't think we are having so much fun yet on the vertical projectile motion. Hopefully on the upcoming questions, we're going to enjoy that. So this is, we said this is h. Okay. We said that delta, this will be h, it's equals to, this gives us 0 plus 1 over 2. Where there's a, we put 9.8, and t we said is t plus 2. t plus 2 is coming from the time it takes to move from A to C. Then now if we work this thing out, now remember we said the time from A to C, it's h plus 8a, so this will be 9h. So I'm going to have this as 9h. It's equals to, if I work this thing out, half of 9.8, it's 4.9. So this will be 4.9 into t plus 2 squared. So now if you still remember, this t here, you see this t on this equation is the t that we are looking for, because where did we get that t? We got it from the time it took to travel this, which is t. We added with the time it took to travel that part, which is 2. So this t that we substituted is the one that we are looking for. But we have a problem, a very big problem. What is our problem? That part. We don't need the h. We need to get rid of that h so that we can be able to isolate t. So I think we can call this equation 1 and we can call this equation 2. So now when I look at equation 1, I know that h is 4.9 t squared, and the t, even this t, you see this t here is the time it takes to travel so from A to B. So this tells you that the t is the same, is what we are looking for. So if we can substitute that, where there's h, let's put the 4.9 t squared. So I'm going to substitute this, and when we substitute, what do we get? We're going to have this as 9. Where there's h, I'm going to put the 4.9 t squared and equate this to 4.9 into t plus 2 squared. So now I know that since I have something like this, I can divide both sides by 4.9, because I see an opportunity that the 4.9 cancels and I'll be left with 9 times t squared, which is 9 t squared. Equate this to, I'm only left with what? This side, I'm only left with t plus 2 squared. Come on, do your algebra. Remove the square. Square both sides. The square root of 9 is 3. And then let me quickly write this down. Let's go back to maths just for a moment. Now, remember, if I have 9t squared, which is squared, this will be root 9 multiplied by the root of t squared. Root 9 is 3, and then the square root cancel, we are left with t. So this will be 3t. So I'm just going to substitute that as 3t. So now let's put this. This will be 3t. It's equals to, the square root cancels. I'm left with t plus 2. So let's bring the t to the other side so that we can have 3t minus t is equal to 2. Then this will give me 2t is equal to 2. Oh, nice. Look at this. When we divide both sides by 2, what is the value of t? Therefore, t is 1 second. Then it's a ding ding ding. Therefore, remember we said 2t is equal to 2. Divide both sides by 2. What is t? T is equals to 1. Then it's a ding ding ding. We've managed to prove that the equation for that time t is equal to 1 second. Okay, so on this next lesson, question, they say using equations of motion only, calculate the speed which the ball reach point C. So now we have a lot of information there, but maybe we can just try to erase this part so that you can understand what is going on here. They said they want us to find the equation of motions. Using the equation of motions, we need to calculate the speed with which the ball reach point C. So we need the speed that it will hit the ground with, and I'm going to say V initial there, it was It starts with 0 meters per second. And then what do we know? We also know that A, since it's traveling, it's going down 9.8 meters per second, because we said down is positive. And then remember, we know the time it will take to reach point C. Let's talk about the time. We calculated this t to be, we proved that this t is 1, and we know that this is 1 second, and to travel from B to C, that's 2 seconds. So when we add those two, it's 3 seconds. So the time it will take to reach point C is 3 seconds. So we're going to look for V final. So we need to use the equation of motion that we don't have there. We're going to choose the equation of motion that we don't have delta y. So let's go and choose the formula that we're going to work on. So we need to choose the formula that doesn't have delta y. So if I quickly go down there on the formula sheet, and then let me see what I have. This one, I can use this equation because this one doesn't have delta y. This one won't work. This one won't work because of that delta y. So now let's say V final is equal to V initial plus A delta t. Then we can just do the substitution and work on this step by step. Okay. So now let's see what I have so far. This is V final. The formula is Vf. It's equals to V initial plus A delta t. Just substitute what we have. We are looking for V final. Initial is 0. We added this to 9.8 times the time that it will take to reach C, which is 3 seconds. Therefore, what is your Vf? You just say 9 times 8 times 3, and this gives us 9 times 8 times 3. This will give us 29.4 meters per second. 29.4 meters per second. And that's it for this question. Right, so let's look at what they need on the next question, what they want us to find. So determine the height for 2 marks from which the ball was dropped. The height from which the ball was dropped. So what I'm going to do here, they want us to find the height from A to C. Okay, they want us to find the height from A to C. But look at this. We know that the height from A to B is h, and the height from B to C is 8h, which gives us the height from A to C to be 9h if we add those two. So I'm just going to say my delta, the height from A to C, to answer this 3.4.1, the height from A to C, we know that it's 9h. So now the aim is to find h. How can we find h here? How can we find the value of h? Okay, it's fine. You know what I'm going to do? To answer this question? I'm going to say, remember this data. This data here is the data that we used to find V final, but we know that this data is from A to C. Né? So since it's from A to C, we can also use that data to find delta what? To find delta y from A to C. So this will be delta y is equal to V initial delta t plus 1 over 2a delta t squared. So let's use this information. So delta y from A to C will be equals to V initial. But now look at this. You know what I'm going to do? Remember, the aim is to find h. So I don't think this will work. Because the aim is to find h. Let's go back and look at h. H is the distance from A to B. So the information that we need to use from A to B is that one. So we know delta y is h. So where does delta y? I can substitute h. It's equal to v. Initially it was 0, which will make all this to be 0, plus 1 over 2. We know that acceleration is 9.8. Then the time the ball took to travel from A to B, because we are looking for this h. So we're going to consider from A to B. The time we set it's 1 second. So I'm just going to substitute that as 1. And this is squared. So this is for 3.4.1. So now, therefore, when we punch that on the calculator, what do you get as your h? Your h will be half of 9.8, which is 4.9. 4.9. So my height h, it's 4.9. But now, what is the question saying? 4.9 meter. What is the question saying? They want the ball from which the ball was dropped. Now we know what is h, and now we set 9h is the height from A to C. So we can substitute that and say this will be 9, which is multiplied by 4.9. So when you punch that on the calculator, you'll get the height that it travels. So maybe we can just put this here and say this is 9h, which is we can say that this is 9h, which is the distance from what? From A to C. And then we know what is h. We can substitute h and say this is 9. Where does h? We put 4.9. Right? So when you punch that on the calculator, what do you get? We get, this will be 9 times 4.9, which is 44.1 meter. So this is the height the ball traveled from A to C. I hope you are happy with that. But now, they say determine the height from what? The height of the ball at point B. What's going on here? The height of the ball at point B. Is this not what we... Oh, let's go. What is point B? So the height at this point. So this is easy, man. 8h. We know that from this point, the height is h is. The difference there, it's what? The difference there is h8, and already we know what is h is 4.9. So we can, to find that, we can say that h, the delta y at point B, is equals to 8h, which is equal to 8 into 4.9. Then we multiply the two, then we can get the answer. Right, so when you multiply these two, let me quickly check this. So we are saying that we need to take the 8, multiply it with 4.9, and this gives us 8 multiplied by 4.9. What is this equals to? 39.2. So this is equals to 39.2. And that's it. This is 39.2 meter. I'm very sorry guys about the space, but I know that I make most of the questions easy, so I don't think you're going to be confused. So now let's talk about 3.5, which is the last question of this question 3. Okay, so far we are up 1 hour and 45 minutes. So sketch the position versus time graph of the motion of the ball from the moment the ball was dropped until it reached point C. So this was A, this was B, and this was C. So this is where the ball was dropped, then it moved downward. So let's draw the position time graph. Always remember that okay, the position will be on my y-intercept. So now this will be my position in what? In meter. And this will be my time in seconds. So when I have this type of question, guys, I'm going to draw the graph and I'll definitely explain so that you can understand. So if you still remember, we said we take down as positive. So we have down as positive, and if this is down as positive, let's look at the height that our ball traveled. I'm going to explain this. So let's draw the two graphs for the positive and for the negative. should we only do one that is positive? Okay, let's say we set it down as positive now. So down is positive, and then let's go back. Remember that the height, the maximum height is 44.1 meter. This is the height that will be traveling by the ball. And they said that on your graph, indicate the following. Take the ground as the 0 position. Remember, so at this edge 0 is the ground. Okay, take the position of the ball, or the position of the ball at which the ground was dropped. They want us to indicate the position, which is this one. It was dropped at 44.1 meter. So I'm going to write it down here and say this is negative 44.1. So I know that you are asking yourself, why am I putting it down here? I'm going to explain, don't worry. By the end of this, so just give me 1 minute, 2 minutes, then you'll understand the concept of graphs. So this is negative 44.1. So this is where my graph will start. Okay, so my graph will start here. So when it starts here, where is the graph going? The graph will start from this point, then it will move all the way down to 0, because we said we take down as positive. Okay, so now let's indicate some of the information on this graph. Let's indicate some of the information. So this is my graph, then it moves to that 0. So remember, we set that when we did our calculations, we set it will take 3 seconds for the graph to reach the ground. So delta t here, this will be 3, and then now this 3 is from A to C. So now we need the time and the position of the ball when it was at point B. So what was the time at point B? If I still remember, it traveled this point with 1 second. So this tells us that somewhere here we can put 1, and then we can indicate that 1 second. And then when you indicate the 1 second on the graph, it's very important that let me redraw my graph and put it in the right shape. So the right shape, it's like putting it like this. Okay, let's try that again. Okay, there we go. So now this point here, it should be my 1 second. This is at point B. But now if it's at point B, what was the distance at that point B? Remember, we calculated this on 3.4.2, because we also need to indicate the distance. We said from point A to B, it traveled 1 second. And then what was the distance? 39.2. So this will be the negative 39.2. It's somewhere there. I hope you guys can see that. This is negative 39.2. That's that answer. So now when you have it like this, then you are done drawing the graph. But let's try to explain this so that this can make sense. Remember, we set it down. We take down as positive. So if we take down as positive, just know that the positive direction, it's a down. So down as positive means that this is the positive direction. The positive direction, it's equals to downwards. Right. So anything above the ground, it's negative. Anything above the ground, it's negative. And we're going to say anything below. Okay, anything above, it's negative, and anything below the ground will be positive. Okay, but now look at this. Look at what is going on here. Point A is this point, which is the top. So I'm just gonna say this is my top. Exactly. So now this top should have what? The top should have what we call a negative position. So the top should have a negative position. I know that someone will prefer to put no. The top should have a negative position. And then at point B, which is this one, this is point A, and this is point B. At point B, this should be, if this point is negative position, this one will be less what? This one will be less negative. Right, look at this. The more we go up, we reach the ground, and the ground is just point C, which is 0. So now we're going to say, if down is positive, the graph starts at negative. So it starts at negative. So this tells you that if we take up as positive, we were going to start here and say this is my 4.1, then the graph will move down to that point. So this one is for positive, then somewhere here we're going to have that 39.2. This one is if up is positive. Right, then this one will be, sorry, the graph is not accurate. I think you guys can see that because at 1 second we were supposed to connect this graph next, but let's just leave the positive because let's focus on making you to understand the one that we choose to be positive, which is down. Right, so now because the ball is falling in the positive direction, which is down, so that's why we start from negative 44, then it goes up. So the best way to cram this for you, you know what you have to do, buddy? If you want to get a ding ding ding, you know what you have to do? Just cram this and say that if I take down as positive and I want to draw the position versus time graph, for positive, that if I take down as positive, the graph starts at negative. Just know it like that. I think it's easy if we can just leave it like that. And that's it for this question. It's a ding ding ding. Then we go to what? We go to question 4. So let's see what we have on question 4. Hi there, grade 12s. Welcome to Spark Genius Academy with Polite. If this is your first time watching our lessons, please make sure that you hit that subscription button so you don't miss the next lesson. Trust me, you don't want to miss the next lesson. So on this lesson, we're going to talk about the diagram that it is not drawn to scale, and this has to do with work, energy, and power. So the vehicle has the mass of 1,500 kg, and it starts from rest at what? At point A. What is this telling you? The V initial at point A is 0. So I'm just gonna say this is 0 meters per second. Okay, so now we can see that it's gonna travel A to B, which is rough inclined, and point B is 200 meters vertical above the ground. So we also have another statement here that is given. On this statement, they say the total work done by the force that moves the vehicle from point A to point B in 90 seconds. So we are given the work done by what? The work done by the force to be 4.80 times, let's fix this, guys. This is not 106. This is 10 to the power 6. So there's a mistake because this question is from a past paper. So this is 10 to the power 6, not 106. I hope you guys understand that part. So this is what we are given so far, and the first question say define the term non-consecutive force. What is a non-consecutive force? So when we say a force will be, let me give you guys the definition. So a force, we're saying that it's non-consecutive. It's non-consecutive if the work, so I'm gonna underline the word work because it's very important that you keep this in mind. So it's a non-consecutive force if the work
if the work that force it does on a moving object, okay, let's put it like this and say a force is non-consecutive force if the work it does on a moving object. So the work is done on a moving object between 2 points. Between 2 points. It will depend on what? It depends on the path taken. So it depends on the path taken. It depends on the path taken. So I'm gonna underline that path taken because it's also very important that you make sure that on your definition you include the path depends on the path taken. Okay, so the next question is say they want you to explain, is force F a consecutive force? Choose from yes or no. Look at force F. They're referring to this that force F. So the force F will do the work on the object, and look at the object, it's moving, and the object on incline, it will depend on the path taken. So if this is rough inclined, it will be harder for the force for the object to move up. But if the incline was smooth, this tells you that the object was gonna flow up smooth. But now you can see that it depends if the incline is rough or if the incline is smooth. So you can see that force F is a non-consecutive force because this work done on that 1500 kg, it will depend on that path taken from point A to point B. So now we can't say force F is a consecutive force. So the correct answer is no. Force F, the force F is not a consecutive force, but it's a non-consecutive force. So the force F, this is a it's a non-conservative force, right? So the next question, they want you to calculate the average power. So we're going to denote the average power by the symbol P generated by force F. So in order for you to calculate the power, you need to go to the statement and check what do you have. So now look at this. We can see that we are given the statement that the work done by the force is 4.80 times what? Times 10 to the power 6. And we are also given delta T. So I'm just going to write down my data. Let me put my data down here. So I'm given the work done by F. This is equals to 4.80. And this guy is multiplied by 10 to the power 6. And we also have delta T, which is 90 seconds. So this object will take 90 seconds to move from A to B. So now when they want power, you just have to list what you are given then. Then when you list everything that you are given, you go to your formula sheet. The formula for power, you're gonna choose the formula that has the work done, delta T and P. And which formula is that one? Which formula is best for us to use? So if you go to your formula sheet, you need to choose the formula that has the P, it's equals to the work done over what? The work done over delta T. So I think this one is just an easy one. So I'm going to explain how they mark this question. So P is equal to the work done is 4.80, and that's multiplied by 10 to the power 6. Let's divide this by delta T, which is 90. So so far by writing these two steps, guess what? You already have 2 marks because this is 3 marks. You already have the mark for choosing the correct formula. You have the mark for the correct substitution. Okay, so now when you have it like this, you can just go and put this on your calculator. So you can put this on your calculator and say 4.8 okay, this will be 4.8, which is multiplied
by 10 to the power 6. So this is multiplied by 10 to the power 6, and let's divide that by 90 and see what we get. So I'm going to divide this by 90 equals to 5.3. Oh, it's 5333, and the 3 is recurring. So how many 3's do we have before comma? 4 of them. So this will be the power is equals to 5333.33 and so on. So there's only 3 recurring. If you can see it like this on the calculator, it is telling you that the 3 is recurring. So we have, okay, there are 4 before a comma. We can write this in scientific notations. Okay, so the best thing that you can do when you round this off to the nearest to scientific notation. So I already have this, right, which is the 5.33. Then how many 3's do we have now? 3. There are 4, so this will be 10 to the power 4. But you don't have to stress. Remember, you can also use your calculator to do this. Now, please try to use your calculator to write that in scientific notation. So the average power, it will be 5.33 times 10 to the power 4. Even if you leave it like this, I think you can also collect that last mark. So now we are given a statement here. They say that the speed of the vehicle when it reaches point B is 25 meters per second. So I'm just gonna go and write this down here. So my V final is given as 25 meters per second. My V initial is 0. Let's see what we need to do on the next question. So the next question says, state the work energy theorem in weight. So remember the work energy theorem, it says that the net work done is equals to the change in kinetic energy. But they want you to write it in weights. You're gonna say, you just write this equation in weights. That's how easy it is. So you're gonna say the net, someone might prefer to say the total work done. The total work done. So the total work done on an object, So it will depend on what is equal. We say it's equal to what? It's equals to the object's kinetic energy. So it's equals to the object kinetic energy. So this is very easy, just easy to mark. So I think if you get something like this in an exam, it will be your lucky day. 2 definition in 1 question. This is question, I'm not sure, but it might be 5 or question 4. So they want you to define a non-consecutive force, 2 marks. Then you have another 2 mark definition. This is best. Né? So now they want us to use the energy principles to calculate the total work done on the vehicle by the frictional forces. The frictional forces. I think the word frictional forces might cause some confusion, but don't worry. When they say use the energy principle, the one that I'm gonna use is that one we just stated, the work energy theorem. So I'm gonna say the work done, the net work done, is equals to the change in kinetic energy. So, but now we need to identify all the forces that are doing work on that object. Which forces are doing work on that object? We need to go. Remember, if the object is on this inclined, we have a force that is pulling it up, and then we're gonna have a frictional force. I'm gonna call it Fk since it's moving, and then we're gonna have the weight that is going down. So I need us to work on all these forces. Let's start with the work. They want us to find the work done by the frictional force. This is what they are looking for. The work done by that force, the frictional forces. So when they say calculate the work done on the object by the frictional force, they are looking for the work done by Fk. So we're gonna work on that, but one thing we need to find the net work done means we add all the work done by each and every force. We add them. So first thing first, we know that the work done by the F applied, it was given on that statement. Let's quickly check that.
So we know that this was given as 4.80 times 10 to the power 6. Okay, let me quickly write this down. The work done by this is 4.80 times 10 to the power 6. You know, I'm gonna write everything down that I need because I don't want to make any mistakes. Né? So remember, we said we have 3 forces that are gonna do work. The next one that I want us to focus on is the FG. Look at this, guys. The displacement is going up and then FG is going down. So this is my FG. So if I'm looking for the work done by FG, this will be equals to FG delta X, the cos of what? The cos of theta. Right, let's do the quick substitution here. We know that FG is mg, and this will be delta X, the cos of theta. So the mass of the object, what is the mass of the object, is given as 1.5. Né? And then we know that G is the 9.8. So I'm just going to rewrite this thing down here. We know that we are saying that the work done by that FG is equals to what? It's equals to FG delta X, the cos of theta, and FG, its mass times the gravitational force. I still have that delta X, the cos of theta. So now I'm just gonna substitute. This is 1500 multiplied by 9.8. Let's talk about the displacement. Remember, this is for FG. The displacement will use that one, the 200. Né? So this will be 200. The cos of the angle between the force and the FG. The angle between the force of gravity and what? And the displacement. So in work, energy, and power, if the force that is doing work, in this case we are referring to FG, it's in an opposite direction. It's in an opposite direction with what? With the displacement. Just know that the angle is what? The angle is 180. Because we are looking for the angle between the force and the displacement. So the displacement is going up and the force of gravity is going down. So they are in an opposite direction. So this tells you that this will be the cos of 180. So the work done by the weight, it should be whatever that you get when you punch that on the calculator. But I won't advise you to put it on the calculator yet, because let's avoid rounding off. I hope you guys understand how we got the work done by the FG. So I'm just gonna go down and state it here and say the work done by FG is equals to FG delta X, the cos of theta. Then let's substitute this. This is my mg delta X, the cos of theta, and this is 1500 into 9.8, 200, the cos of 180. And that's it. When you have everything like this, I think now let's expand the formula so that we can see what we need. What do we need now? So I'm gonna say the work done. Remember this formula. The work done means that we need to take the work done by FG. We add it with, remember in work done, we add all the forces. It doesn't matter if this is a vertical force, others are horizontal. You add all the forces that are doing work, because we are saying the net work done. So this will be the work done by the FG. We're gonna add that with the work done by the F applied. Then we're gonna add that with the work done by what? The work done by Fk, the frictional force. We equate this to the change in Ek. So now please don't focus on direction and say the F applied is going up, the frictional force is going down. Please just remember that the work does not have direction, so you don't have to do it the same way you do when you're doing Newton's law. Just focus on adding the forces, don't look at the directions. Né? So this is equals to the change in kinetic energy, and the formula for change in kinetic energy is 1 over 2 mv final squared, we minus 1 over 2 mv initial squared. So that is the formula for the change in kinetics. So now we have the mass, but we need the velocities. So we still remember that the V initial was given at 0 meters per second because it starts at rest. So this is my V initial. It starts at rest. This will be 0 meters per second. And my V final, that's 25 meters per second. Okay, so I'm just going to substitute everything there. My V initial is 0 meters per second. And my V final is 25 meters per second. So let's do the substitution and see what we get when we work on this. So now, when we substitute, we know that the work done by FG, this was 1,500, which is multiplied by 9.8, and then we have that as 200, the cos of 180. Right. So we're gonna add the force, that is the work done by the applied force, which was given as 4.80 times 10 to the power 6, and then plus, this is the one that we are looking for, the work done by the frictional force. So this is what we are looking for. Let's equate this to what? 1 over 2. I see that we don't have much space. I think if we don't have much space, can we please take maybe the 1 over 2 out as a common factor? Let's take this 1 over 2m, 1 over 2m out as a common factor. So meaning that I can say this is half of that mass, which is 1,500. I'm going to take it out as a common factor so that inside the bracket I'll have the final velocity, which is 25. So this will be 25 squared. We need to minus the initial, which is 0. Right. So let's just punch this 2 on the calculator. I need you to say this and that. Let's add the 2 now on the calculator and see what we get. So we have 1.5, 1,500, and this is multiplied by 9.8. Then I'm gonna put multiplication between my brackets so that I don't get an error. Times 200 times the cos of 180. Okay, so the cos of 180, I'm just gonna put an equal sign for now before I add that 4.80. Before we add the 4.80, then I'm gonna say let's add the 4.8 times 10 to the power 6 and see what we get. So when we punch this, this is 1.86. We get this as 1.86 times 10 to the power 6. So this will be 1.86 times 10 to the power 6. Then we still have the work done by FK, which is what we are looking for. And let's equate these two. Let's see what we get when we put that on the calculator. Half of this will be the half of 500, 1,500, né? 1,500, close the bracket, and then we need to multiply this by 25 squared and see what we get. 25 squared. So this is 469 times 10 to the power 5. So I'm not sure. Let me just say shift 9 equals sign AC. Let's clear the calculator and see what is the answer. The answer, if it is not in scientific notation, that's 46, 8750. It's 46, 8750. So this tells you that you can also put this not in scientific notation. So I think we can just put this again on the calculator and see if it is not in scientific notation, what is that answer. So this is 1,500 which is multiplied by 9.8. 9.8, which is multiplied by 200. Close the bracket, and this is multiplied by the cos of 180. And let's see what do we get there. So this is negative 294. So it's negative 294. Okay, let's write this down. So I guess this was not correct. So let's write this not in scientific notation. I'm just gonna write this answer that you see here on the question paper. Negative 294 and 4 zeros. Okay, so this will be negative 294. 1, 2, 3, 4 zeros. So let's make the work done by frictional force subject of the formula. So the work done, this will be the work done by the Fk. What is this equals to? Because now when we have it like this, oh guys, we forgot to add the, on this number we need to add that 4.80. We forgot to add the 4.80. Let's add the 4.80 on answer, times 10 to the power, this was 10 to the power 6. Let's add this and see what we get. So this is 186 and 4 zeros. So we need to, instead of writing this, I think it's best if you say 186 and 4 zeros. You see, the moment I saw that we're gonna get our frictional force as positive, that's when I saw, because remember the negative 294, it was negative. When it comes to the other side, it becomes positive, which gives us the frictional force as positive. That's how I saw that normal. There's something missing here, because the frictional force should be negative. It's gonna do a negative work done. So the answer is 186 and 4 zeros. So this side we're gonna write it at 186. So this is 186 and 4 zeros. Right. So now we need to move that one to the other side. So I have 468750. We need to minus 186 and see what is the work done by that frictional force. We just have to punch this on the calculator. So I'm gonna say 468750. Let's minus answer and see what we get. So the answer should be negative. So this is negative 1391. Negative 1391 at 250 joules. Or you can also write this in scientific notation. It's fine. You can write this in scientific notation and say, you can put it in scientific notation and say this is negative 1.39 times 10 to the power. So this will be times 10 to the power 6 if you put it in scientific notation. And when you have it like this, you're gonna collect all the marks. You're gonna collect all the marks, and this is the end for the activity. Please make sure that you note all the mistakes that we did in this lesson. So the first mistake was adding this and forgetting that we still have that. So make sure that you add the 2 to get that 186. And also please make sure that you do the correct substitution, because in most cases there's a mark for writing the correct formula and there's a mark for the correct substitution. I hope you guys understand that part. And that's it for this lesson. If you enjoyed the lesson, please make sure that you hit that subscription button so you don't miss the next lesson. Please trust me, you don't want to miss the next lesson. I think we spent a lot of time on this question and we were just supposed to just move, but it's fine. Let's look at question 5. The water is drawn from a water source that is 12.5 meters below the ground by an electric pump. Okay, so they say it is drawn below and the water is 12.5 meters down. Okay, so now the water is lifted vertically upward at a constant
speed as shown in the simplified diagram below. So the water will move up and then it will go in that direction on the ground. And this is our electric pump that we are using to take the water down. Ne? So the pump lifts the water upward at a rate of 2.5 kg per second. Ignore all the frictional. What is this weight? Physics, man. Yes, yes. Define the term non-conservation force. What is a conservation force and non-conservation force? When we talk about a non-conservation force, we are talking about a force for which the work done, a force, I won't forget this one, a force for which, we can say this is a force for which we can say the work done in a moving object. So remember, we need to say in a moving object. So the work done in a moving object between 2 points. Depend on the path taken. So it depends on the path taken. That's the non-consecutive force. But please try to consult your exam guideline. Ask your exam guideline, hey buddy, how do you want me to define this? Next. So 5.2, they say draw a label free body diagram showing all the forces acting on a fixed mass of water as it moves from the source to the ground. So the mass of water. So let's say this point somewhere here, I have the mass, let's call this MW, the mass of water. Because even water, guys, has mass, né? Let's call this MW. So if the mass is moving and is this on this point, so what you need to ask yourself, how did the water, what happened? How did the water move from this point to that point, to that point, to that point? Because there is a force that is applied, and what is that force? Is the force of the pump. So let's call this F pump. Then, now, we know that the water, since it has mass, is going to have weight that is acting down. So this will be my FG. So there, to draw the free body diagram, this is 2 marks. This tells us that we need to have 2 forces. So to draw the free body diagram, you already have it, and that's it. So this will be my 5.2. We are saying that the free body diagram will be the force of the pump and the weight of the water, Fg. So now, let's continue answering this question. The pump lifts 200 kg of water from the source to the ground at a constant speed. Calculate the work done by the pump. So when they say the work done by the pump, so now remember, I told you guys, please, you see, if you can listen to me, listen to polite, guys, listen to polite, and I will tell you this politely. Whatever that you do, if you don't know how to answer the question, just try from starting from what is the question saying, the work done by the pump. So now I said that, listen to polite, I said that each and every question, they will start by asking you to define something. Most of the calculation will be based on that definition, non-consecutive force. So this is NC, the work done by non-consecutive force. So on your work, energy and power, go and look for the formula that has NC, then you will definitely have an idea on what you need to do. You'll definitely have an idea on what you need to do. But now, what we're going to do is that when I look through this problem, they said that, let's go and check what is the formula for non-consecutive force. I'm going to look for the formula that has NC then. Hey buddy, where are you? We are looking for you. This is the one. The work done by NC is the change in EK plus the change in EP. Let's quickly go back and write that formula down. If you listen to polite, and then you're going to collect your marks politely without like too much stress, no stress. Ne? So the work done by NC, this is equals to the change in, that was the change in EK. We add the change in what? The change in EP, potential energy. But now I think this is going to be more complicated, and I'll try to make it more easy because, hey, this 3 marks, I need that 3 marks. Right? So you know what I'm going to do? I know that the work done by a non-consecutive force. What is a non-consecutive force here? There's only the non-consecutive force will be the work, the force applied by the pump. So we need to find the work. So this will be the work done by a pump. So this will be the work done by P for pump. This is equals to. So now remember, the change in EK, the formula for change in EK, it's, I'm just going to write this down. EK, we know that EK is equals to 1 over 2 mv squared. Do we have the velocity? Let's go back to the statement because we don't have the velocity. They said this moves at a constant speed. So the velocity of this is what? Because of the weight constant, the velocity is 0 meters per second. So this gives us the right to say everything on EK, it will be 0. So I'm just going to say this is 0 plus the formula for this is mgh. So to find the work done by P, we can say this is mgh, and the mass of the water is given as what? The mass of the water is given as 200, and then what is G? Is just 9.8, and the height, the water that will travel is 12.5. This is my height, so I'm just going to write the 12.5 there. So this will be 12.5. So when you punch this on the calculator, you'll find the work done by the pump. So let's quickly put that on the calculator. 24,500 joules. That is the work done by the pump. But guys, when I look at this, let's look at this formula here. The work done, let's say you don't understand that you are in an exam and you don't understand that the work done by a non-consecutive force is NC, then you consider using this formula. The work done by which force is doing the work? Is the pump, because it's moving the water. I'm trying to think about this question. So is force, the work is equals to F delta X, the cos of theta. Let's go and see if we use that formula, are we going to get the same answer? Because now someone might not prefer to use the work done by a non-consecutive force. So let's say someone says the formula that I will go with is the work done by what? What did we call this? The work done by the pump. So this is F pump. Ne? So we said we'll call it the F pump because it's the one that is doing the work, it's the one that is moving water from deep down all up to the ground. And then we're going to say this is F of the pump. It equals to this will be the force of that pump. So let's write this because so that we can get space. Né? Okay, so now if we look at this, let's just clean here so that we can make the space. Né? So we are saying that we can use the formula, the work done by the pump is equal to the force of that, let's call it FP, the force of the pump, delta X, the cos of theta. So I think the challenge here might be calculating FP. Let's go back to our free body diagram, because each and every time I need to calculate a force, I check my free body diagram. So we know that these are vertical forces. So this tells us that we can equate this and say F net it's equals to 0 because these are vertical forces. So we take a force that is going up, which is the FP, I'm going to call it F pump. We minus the force that is going down and we equate this to 0. So the aim is to find the force that is done by the force of the pump. So this is equals to the weight. So FP is just mg. What is the mass of the water? It's given as 200 multiplied by 9.8. So we just have to punch this to find the force of P. We just have to punch that on the calculator. Okay, so now when I put this on the calculator, I get the force to be 1960. So 1960 newtons. So that is the force done by the pump. So I think if I go back here, I can substitute the force done by that pump, which is 1960. I'm going to multiply that by delta X, the distance traveled by the water, which is given as 12.5. So I'm just going to put it there and say this is 12.5. Okay, I'm very sorry guys, sinuses there and there. Okay, so I'm saying that I just want the work done by FP, the pump, it's equal to the force, it's 1960, delta X is 12.5. The cos of, let's go see what is the angle there. Remember, the force is this one, and it is in the same direction as the displacement. So since they are parallel, the angle is 0. Remember, when you calculate the work done, you check the force and the displacement. If they are in the same direction, the angle is going to be 0. So this will be the cos of 0, and the cos of 0 is just 1. You just have to punch this on the calculator, and I believe that this should give you the same answer that we got here as 24,500 joules. So let's quickly verify that. And ladies and gents, when I put this on the calculator, this is 1960, 12.5 times cos 0. This gives me the same answer. And that's it for this problem. We're not going to do okay, that's it. So now on 5.3.2 they say this was 5.3.1. That was 3 marks. Next, the speed, calculated the speed at which the water is lifted. They want us to find the speed, the constant speed. I think this is if you go back to grade 10 and when you were doing waves vector in grade 10, we said that the V in grade 10, why are they asking something like this? How can you remember that V, the constant speed, This is 5.3.2. The constant speed is equals to distance over time, right? Distance over time. That's the formula that we need to use. So now the distance, we know that is 12.5, but what about the time that it will take to for the water to travel that 12.5? We need to find that. So to find the speed, we're going to say this is 12.5 and this is divided by, we're going to divide that guy by delta t. So now how are we going to find the time? Guys, remember that this is water going up. This is water that is going up, and looking at the rate that we are given here. You know, when I was still in school, when I do calculations, this is what I do now. I'll be calculating, then I go back to the statement, I check, Rayman, why are they giving me this? Because I haven't used that. So this tells me that maybe this calculation has to do with that. So that's how I used to find my way around. So now, looking at this, what is 2.5 kg per second? Guys, I know that most of the time when you're doing the caps, you normally don't get this kind of SI unit. But now, because the question paper is a sub exam, remember this is a sub exam, anything can happen on this question paper. That's the issue with the question paper. Anything can happen. So what I need you to know about this SI unit. The SI unit is the mass flow rate. This is what we call the mass flow rate. So what I'm trying to say is that you are given the mass flow rate. We see it that by kg per second. So this is the mass flow rate. So now if this is the mass flow rate, the question that you need to ask yourself, what is the formula that we use to calculate the mass flow rate? The formula for mass flow rate, that is equals to the mass, which will be the mass of the water, divided that by the time. So we can use this formula to make what? We can use this formula to make that time subject of the formula. So the mass flow rate is given as, remember, it's 2.5. So this will be my 2.5. It's equal to the mass of the water is 200 over t. Let's find t. So this will be 2.5 multiplied by t is equals to 200. Divide both sides by 2.5. Divide both sides by 2.5. Therefore, what is t equals to? T is 200 over 2.5. When you punch this on the calculator, what do you get? So this is 200 divided by 2.5, and I have my answer as 80 seconds. So now that I have the 80 seconds as my time, I can use this time and substitute it on this equation to find the constant speed at which the water is lifted up. So now this will be 12.5 divided by 80, and what will be the constant speed? So when I put this on the calculator, I get my constant speed V to be equals to 0.16 meters per second. So now I need you to pause the lesson. Look at how I answered this 5.3.2. Try to find a way how I work around questions. Even if you can go back to some of the questions that we did, look at how I answer my question. I start by focusing on what I have, and then when I see that there's something missing, I find a way to find whatever that is missing. Look at this. my focus one was on constant speed, and the formula for constant speed is d over t. And now I know that the distance is 12.5. Then what is missing? The time. Then I find a way on how to calculate the time. Look at this question on work, energy, and power. We just did our substitution. We find that VF is missing. We find a way to find VF. I think it's best if you work like that, né? Right. So now, when we... Oh, was this the last question? Nope, there's still 5.3.3. The average power, calculate the average power dissipated by the pump and ignore the energy losses in the form of heat and sound. So when they want the power, if they want the power, I'm just gonna first do my data on that 5.3. So for the 5.3.3, if I do my data, I'm just gonna check that they need power. Before I do data, let me go first and check the formulas that has P for power, and then I'll take it from there. So when I look at this, where is power? Electrostatics is power. Where? Under okay, energy, work, and power. Okay, it's somewhere here. Let's look at the formula for power. All the formulas that have power, P average, it's F over average, this one work. And then another power is this one. What is W on top? The W is the work done. Do we have the work done? Yes. Do we have the delta T? So the delta T is the time that it will take that guy to move up, and we got that as 80 seconds. And this one, I don't remember what was the work, but we did find the work. So the correct formula that we can use. Okay, I think this one is easy. I think this question is easy, so we don't have to do much explanation on that. We just have to choose the formula and do our substitution. So no need for data, because already we know that P is the work done over delta T, and the work done, I'm just gonna go back. Oh, it's even here. The work done by the F pump is 24,500 joules divided by delta T. We just calculated it to be 80. Okay, so now guys, I think it's a ding, because I think that physics questions are easy, but we're going to talk about why most of the learners lose marks. Why is it difficult to get the marks that we need? Let's talk about that, guy. But first thing first, let's close this question and say 24,000 divided by 500 over 80. What is this equals to? So on my side, I got 306.25 watts if we round it off. So guys, the reason the questions are easy, and I think you guys can agree with me. But when we talk about why is it so much difficult for us to find the marks that we are looking for, look at this. When we started doing the calculations, we calculated the work, which is 24.2. So let's say we make a mistake somewhere on this 5.3. We lose these marks, and then how will this 2.4 affect our next questions? Let's work on that. Let's see. So this will affect 3.3, because we're going to do wrong substitution. Then when we do wrong substitution, what happens? Going another 3 marks. Pa. Okay? Then now this tells us that even if we do the 5.3 wrong and we don't manage to get this 80%, the 80, it will also affect that question. So another 3 marks going. So now this tells you that out of 13, we're going to get what? We're going to get 2 marks for definition, 2 marks for the free body diagram. Unless if you forget to name your forces, because you are too much excited and say, free body diagram, easy stuff. Then you say, pa arrow kodimo, pa arrow down, then you are done. You just leave it like that. They'll be like, and then what is this? You see? Yeah, I think that's why physics we lose marks. It's not like it's difficult. It's easy. Make sure that you take everything step by step.
Okay, grade 12. I want us to look at this one, right? 2024 November paper 1, question 5 of your past paper, physics. So if this is your first time watching my lessons, guys, please subscribe to the channel, leave a comment, tell me what you want us to do next. Okay, so now when I look at this question 5, it's from November 2024, and question 5. Okay, so we have a constant force F that is applied at an angle of 30 degrees to horizontal on a crate of mass 6 kg that is initially at rest. Okay, and they say this is shown on the diagram, and they tell us that the constant frictional force of 10 Newton acts on the crate at it move from rest at point 8. Okay, so I'm just gonna include that on my diagram just to see how this looks like. So if the force is moving to the right, this is where my Fk will go, and they say the frictional force is 10 newtons. Okay, so now they say that the distance between point A and B is 1.5. The speed of the crate at point B is 2 meters. Guys, let's work on this. From rest, okay, the weight rest means that the initial velocity is 0. So I'm going to say from rest, my V initial, that's 0 meters per second, because I need to analyze this before I go into answering questions. The speed of the crate at point B, so this is my V initial, which is 0 meters per second, and then V final at B is given as 2 meters per second. Okay, define the term work done by a force. So the work done on an object. So when you define the term work done by a force, you can define that by defining the formula of the work done. We know that if we write the formula down, okay, let me quickly write the formula down, then I'm going to define the work looking at that formula. If you still remember the formula for the work done, it goes like this. So work done, it's equals to the force multiplied by the displacement and the cos of theta. So when they say on 5.1 and they want you to define the work done, I'm going to say the work done on an object is the product of what? Is the product of the force. Is the product of the force and displacement. Is the product of the force and displacement. Okay, the product of the force and displacement. Okay, and then we say that of is the product of the force and the displacement of what? Of the object in the direction of the displacement. Of object in the direction of displacement. But now, since you're in matric, I'm going to advise you to go open your exam guideline, define it how they want it in an exam guideline. You can say is the work done on an object by a constant force. It's where F is the magnitude of the force, or you can just go to your just go and consult your what is this, your exam guideline. So now they say draw a free body diagram showing all the forces that are acting on the crate as it moves, and this is 4 marks. So I'm going to give you an exam tip. So an exam tip that I want to give you is that since there are 4 marks awarded for this question, okay, this tells you that you should have 4 forces that are acting on this object. 4 forces, because now they no longer give you marks for the component of the force. They no longer give, so no need for you to include the components. So when you write your free body diagram, you're going to say you have an applied force going in that direction, then you're going to have the weight going up, which is force number 2, Force number 3 is going to be the normal force. So the weight, which is Fg, it will go down, and then this is my frictional force. So those are the forces that you need to indicate. So to answer your 5.2, so the 5.2 will look like this. We're going to say the free body diagram with the F applied, and then we have the Fg, which goes down, and then the normal force is going to be opposite direction. Please make sure that you also name your forces, and then we're going to have the frictional force. You can call this Fk since it's moving, it's fine. That's your free body diagram. Easy. Collect that format. 5.3. Use energy principles. Use energy principle to calculate the magnitude of force F. Guys, I don't want to go into too much details. I just want to make sure that by the time I finish answering this question, you guys understand everything here. So I'm going to give you the best way to approach this question. There are many ways that you can do, but I always like to make my life simple. So I'll go with the easiest method. Okay, right. I'll go with the easiest method. So the easiest method that I'm going to go with is that they said you must use energy principles. Okay, you must use the energy principle only. We need to use either the work done by the non-consecutive force or the work energy theorem. So let's explain this energy principle only. So the energy principle, the first one, you can use what we call the work done by non-conservative force. Or you can use the work energy theorem. How? Look at this now. So you know what I like to do? I'm going to choose the one that gives me something like an easy way to go. So I'm going to write two formulas for the non-consecutive force, and I'll definitely give you the formula for the work energy theorem. So the work done by a non-consecutive force, it's equals to the change in EK. Then we add this with what? We added this with the change in potential energy, EP. Okay, that's the work. This is for this one, the work done by the non-consecutive force. The work energy theorem, it says that the work done, the total net work, it's equals to the change in EK. It's equal to the change in EK. Right. So these are the two formulas that we can use to solve this. It's up to you which formula you want to go with. So that's up to you. Even if you use one of these formulas, you'll still get it right. Okay. So now let me explain the first one, which is the non-consecutive force. So you're going to what you're going to do now, I need you to look at the free body diagram from that question 5.2. And then you need to determine which non-consecutive force that is acting on the crate. And you won't be able to determine the non-consecutive force if you don't understand what is a non-consecutive force. Okay, so now we know that in this case, the work done by the applied force and the frictional force of 10. So I can see that the non-consecutive forces acting on the crate is going to be the work done by the applied force and the frictional force. I hope you guys understand. So let me work on this one. Then it's up to you which method you'll go with. So the work done by the non-consecutive force is equals to the change in EK, and we are adding this with the change in EP. Right. So if you still remember, I'm saying that the work done by the non-consecutive force is going to be the work done by the frictional force plus the work done by the applied force and the frictional force, the FK. We're going to equate this to the change in kinetic energy, which is 1 over 2 times the mass. Then I'm going to open the bracket and take my V final squared minus my V initial squared. Close the bracket. Then we're going to add this with the change in what? The change in EP, which is mg. Inside the bracket, you need to take the final height minus the initial height. Okay. Right. So now I'm going to look at this and see how will this help us? How can this help us to solve the problem? How can this help us to solve the problem? Okay, so now what I'm going to do, I know that this is something like a horizontal force. You need to ask yourself, does this guy have what we call, does this have potential energy? Because since it's a horizontal force, does it have a potential energy? That's what you need to ask yourself. Because the moment you start making a mistake using this, the potential energy, you need to understand what is a potential energy. It's going to be the energy that only the objects that are acting vertical, they will have the potential energy. But this is horizontal. I'm just going to say my potential energy is 0 because of the height. Okay, so we don't have vertical height, so this tells you that this will be 0. But let's say that this thing was moving on an incline. So you can see that if it starts on an incline, and this is point A, this is point B. So if it starts from point B, it goes up, and they tell you that this is the height. So it starts at the ground, which is 0. Maybe it goes to 5 meters. So you can see that H final is 5 minus H initial is 0. But we don't have, you see, this is how the object is traveling. It's not on incline, it's not moving vertical upward. We don't have potential energy. So everything there will be 0. I hope this makes sense, okay? So if it is on the horizontal, just know that the potential energy is 0. So it will only have the kinetic energy. Okay, I hope you guys understand that part. So now, when I do this, when I do the substitution, I need to find the work done by the applied force. Okay, so the work done by the applied force, I'll say F times the delta X, the cos of theta. Then I need to add this with the work done by the frictional force, which is Fk, the delta X, the cos of theta. We equate this to half mass into Vf squared minus V initial. Remember, plus 0, so it's just 0. This is what I'm going to do. But when you write your equation, there's a mark for this equation. Just make sure that you write everything in that form. Now, let me do the substitution, and I'm going to move easy with you guys on this one. We are looking for F. So we don't have F. The displacement, look at the displacement. The direction of the motion is 1.5. It's going to travel 1.5 meters. Then I'm going to sub in that delta X as 1.5. Then the cos. So now when I use the cos, I'm going to use the cos that is between the displacement and the F applied, which is also one of the most important things that you need to understand. So this is my displacement. Okay, this is my delta X. So the angle on that cos is the angle between the applied force and the displacement, and it's given as 30. Please make sure that you understand that part. So it's given as 30, so this tells me that this will be the cos of 30 degrees plus Fk. The frictional force was given as 10 newtons. I'm going to substitute 10 newtons. Right, so this will be 10. Right, the displacement is the same because we're going to move a distance of 1.5 meter. But now let's talk about the angle of theta for the kinetic friction. Okay, so let me draw this down so that this can make sense. Whatever that I'm going to explain, it is going to make sense. We are moving from point A to what? To point B. Right, we are moving in that direction. That is the direction of the displacement. And now, where is friction going? Friction is going in an opposite direction, what is that telling you? Frictional force will have a negative work done. So it is going in an opposite direction as the displacement. And what is the angle between the displacement and the frictional force? 180. Angles on a straight line, that's 180. Let me give you an example. Let's assume that in this case, the applied force was not applied at an angle. It was applied horizontally to the displacement. Let's say this is what I have. Delta x. You know, when I teach, I don't like to do example. I don't like to put example for something that is not even on that paper, but it's fine. Let me make sure that you understand what I'm going to do here. So look at this force. It is in the same direction as the displacement. What will be the work done by F? It will be F delta x, the cos of theta, which is equal to the F, then delta x. I want to show you guys theta. This will be the cos of the angle between the force applied and the displacement. It's 0 degrees, so it will be 0. So to conclude this, if the force is parallel to the displacement, the angle we use 0. If the force is going in an opposite direction as the displacement, we use 180. And if the force is applied at an angle, you substitute that angle. I hope this makes sense. Now, let's go back to the question. I'm going to substitute. We said this will be the cos of 180 degrees. Oh, okay. 180 degrees. So this will be the cos 180 degrees. Then this is equal to 1 over 2. What was the mass of this? 6 kg now? So this will be 1 over 2 into 6. Close the bracket. V final, we start at 0, we end with 2. So the V final is going to be 2 squared. We minus the initial, which is 0 squared. So now the only thing that you can do, you need to make F subject of the formula, and I'm going to approach this according to what my maths teacher used to tell me, that when you work with these problems, especially in physics, do not round off, only round off the final answer. So I'm going to teach you guys how I avoid rounding off. So I'm going to write this as half, right? And then this is multiplied by 6. This is 2 to the power 2. Then I take this part, everything there, I put it this side, it's negative. So I'm going to put that inside the bracket as 10 into 1.5, the cos of 180. I'm going to put it inside the bracket because then everything there will be negative. Then now I can divide both sides by that 1.5, the cos of 30, divide everything there by 1.5, the cost of 30. Right, you can also apply the method that you prefer to isolate F. It's up to you which method you prefer. Let me just put that on the calculator and see what I get. I'm going to say this is on top I have half, which is multiplied by, okay, let's put this half inside the bracket. This is multiplied by 6 multiplied by 4. I'm just going to say 4 because it's 2 to the power 2, right? Then I'm going to subtract everything inside the bracket. I have 10, which is multiplied by 1.5. Close the bracket. 1.5. Okay, this is multiplied by 1.5. Come on. Then close the bracket. Oh, not yet. Let's multiply that by the cos of 180 and see what we get. Okay. Now I can close the bracket. Everything is divided by 1.5, which is multiplied by the cos 30. Guys, please trust me. If you prefer to pass the calculator for each and every step, it's fine. You can do that. But if there's a point where you have to round off, you can avoid rounding off, okay? So it's up to you what you want to do. So this gives me 20.78 if I round it off to 2 decimal places. So my force applied is going to be 20.78 20.78 newtons. That's 20.78 newtons. So this is the best way to solve this without having some mistakes of rounding off. Right, I'm going to work this using the network done. This will be a very short one. So I think I can just put it on the other side, okay? Okay, so this was the work done by the non-conservative force. And another energy principle is the work done by the change in EK. So what is that equals to? The net work done. The net work done, we need to find the net work done by F. We added that with the net work done by frictional force. Equate this to the change, which is 1/2, and then this will be my mvf squared minus my 1/2 mv squared initial. Okay, so you can just say, remember, the work done by frictional force, this will be F delta X. Okay, let me just do this. This will be F delta X, the cos of theta. We're going to add this with Fk delta X, the cos of theta. It's equals to 1/2 m out as a common factor. Then I'll say Vf squared minus V initial squared. Let's do the substitution. We are looking for F, right? Then delta, it's 1.5. The cos of F we said is 30, if you still remember. Then F, this one it was given as 10, and we said the distance is 1.5. And then this will be the cos of what? This will be the cos of 180. Okay, this is equals to, can I please write this one down here? Just say this is 1/2. The mass is 6 into, this will be, we said this is 2 squared minus 0. So I think you can also see that the change in the work done by the network is equal to the change, which is the work energy theorem. It gives us exactly what we have on that step. Okay, it gives us exactly what we have on that step. So you can see that there's no difference. So we have all exactly what we got previously, but now the difference is that, don't forget that when you use the work done by non-conservative force, if you don't include this on your formula, everything will be wrong. You're going to lose 1 mark for the formula, right? So I'm not going to waste time on that. You can see that still this one will give us F is equal to 20.78 newtons, which gives us the same thing that we got this other side. I hope you guys understand that part. Okay, the last question, it says that a 2 kg object is placed in a crate. So this is my crate and I need to place a 2 kg object. So if I'm not sure, it's like saying placing a 2 kg on top like this, then this is 2 kg. What is the statement saying? What effect will this have on the work done by the same force when the crate is again moved from point A to B? So look at this. We are adding 2 kg block. We need to understand how will this affect the work done. They are not saying how will this affect the force. The work done, if we still use the same force. Okay, will the work done increase, decrease, or remain the same? Okay, so you know what I'm going to do? I'm going to say that to answer this question, let me say I know that the work done on an object by that F, it's equal to delta, it's equal to F delta X, the cos of theta. What is this formula telling you? It is telling you that the work done by force F, it depends on the magnitude of the force, the displacement, which is the covered, which is the 1.5 covered, and also the angle. You understand? So the work done, it depends on the force, the displacement, and the angle that the applied force is applied with. So this tells you that when we add the 2 kg block, okay, when we add the 2 kg block on top of that one, this does not change the size of any of these quantities. So this is it depends on the force, it depends on the displacement. So the force, we still have the force as what? 20.75, because they said the same force, and then the displacement is still as 1.5, and angle theta is still as 30 degrees. Okay, so now look at this. By adding the 2 kg block, this does not change any of this magnitude. Therefore, this tells you that the work done by the force does not change. So if the work done by the force does not change, the answer, the correct answer here, it remains the same. And they don't even need a reason for that. But I don't want you to do guesswork and say, today I'll go with increase. I feel like increase is the correct answer. Please don't feel. Just know that this is the correct answer. Work something out. Right. So we're going to say it remains the same because by adding the 2 kg block, this does not change anything. However, it does change something, which is if you know this, the frictional force will change. Why? Because if you add a 2 kg block, if you add a 2 kg block in the crate, this will change what? The magnitude of the normal force. This will change the magnitude of the normal force, and the magnitude of the normal force affect friction. Remember, the frictional force is equal to the coefficient of friction times the normal force. So if the friction increase, the Fk also increase. If the friction increase, let's say if the normal force increase, the friction increase. So you can see that by adding a 2 kg, this affect the normal force, which will also affect the friction. So maybe in the upcoming exam, they might change the question and say, what effect will the work done have on the frictional force? You understand? What will the work done by the frictional force on the crate from point A to B increase, decrease, or remain the same? So you can see that the work will change if they talk about the work done by the frictional force. I hope you guys understand, and I hope you guys really enjoyed this one. I want us to look at the next question. Please make sure that if you have been subscribed to the channel, now is the correct time to click that button. Please subscribe to the channel, guys, and then I'll make sure that you feel at home. I don't like Doppler effect, you know? I don't like Doppler effect, but what can we do? We just have to answer it now. Okay, let's work on this Doppler effect question. So they say that a bird emits sound waves with a frequency fs, the frequency fs, as it flies at a constant speed, and the constant speed is vb. So this is the velocity of the bird. Hey, why am I saying the bird? The bird. Okay, so towards a vertical cliff. So this is my vertical cliff. It is traveling towards that cliff. The wave reflected on the cliff with the same frequency, the wave reflected off the cliff with the same frequency that they strike the cliff, and with a wavelength of, this is the wavelength, it's given there as shown in the simplified diagram below. Take the speed of the sound in air to be 340 meters per second. Okay, and now name and state the phenomenon that result in the change in frequency of the detected sound waves. It's Doppler effect. Now just look at this. We know that this question 6 has to do about Doppler effect. So just state Doppler effect down and then try to name it. So this is Doppler effect. And what is the definition of Doppler effect? When you state it,
the change in frequency. Doppler is the change in frequency. Okay, the change in frequency of the sound detected okay, by a listener. By a listener. By a listener because the sound and the source, because the sound and okay, let's say because the sound source have different velocities. Guys, this is the best I can do. Now please try to consult your exam guideline on the definition. Has different velocity relative to what? To the medium of what propagation. That's the part I remember. So now have different velocities. Just try to go to your exam guideline and try to find the correct answer for that one. But we know it's something like this. Then 6.2, they say that on 6.2 showed that Fs, which is the frequency of the sound waves emitted by the bird, is 21,250 minus 6.25 VB. So you know what I'm going to do? I'll focus on finding my Fs. So you know what we're going to do. Now let's work this thing down here. Let's work on it. I'm not sure if this will be enough space. Okay, this is 6.2. On 6.2, they want us to show, you know what I'm going to do first? Let's analyze what we given there. Let's talk about the wave equation. So I think we know what is the wave equation now. So the wave equation, we use the formula V is equals to F times the lambda. So if you don't remember how to you don't remember this formula, hey, just go to the grade 10s, ask them, guys, I've done this like 2 years back, 3 years back. Can you please help me with the wave equation? But don't worry, after this lesson, you're going to understand that wave equation part. So now we are looking for what? We are looking for, let's first find the frequency at a cliff. The frequency at the cliff, because if we look back up there, we have this, the reflected wave, so we can find the frequency at the cliff. Okay, let's see if this works. If we manage to prove this, then this is correct, guys. Let me just try to drink something. Maybe I'll be okay. Let me just try to put something. So we can complete this question, okay? All right. So let's make F subject of the formula. When we make F, we can divide both sides by the lambda, which is the wavelength, Therefore, my F is equals to V over lambda. So that's what we have next. So for the reflected waves at the speed, at the cliff, we need to find the frequency. So I'm just going to put it down here and say for the reflected waves at a, for the reflected waves at the cliff. So my frequency, okay, let's start with the speed of sound. We are given the speed of sound. They said we should take it as 340. So this will be 340 meters per second. And then the wavelength, which is lambda, we know that it was given as the reflected wave. We have the lambda as 0.016. So I'm just gonna do this and say this is 0.016. Guys, just write what you are given, man, and then do the substitution. Just take this, you'll know what to do next. So the frequency, now we need to name this frequency. This is the F for the frequency. Okay, so this will be what? This will be the frequency at cliff. It's equals to V over lambda, which is from that formula there. And then now when I substitute V is 340, that guy, divide by the 0.016. Please punch that on your calculator. Therefore, we'll find the frequency at a cliff to be equals to, when I put this on the calculator, what do we get? Nice, 21,250 HZ. So now you'll see me smiling in an exam. You'll see me smiling because I know that this 21, I'm on the right track. Then you'll see me smiling, and they'll be like, see me like, that's when you start to sit well now, because you are measuring this question paper. So now, because of that, I'm going to start having like a confidence, because I can say that, you know what, I'm going somewhere, and not only somewhere, I'm going far. Right, so now let's work on this. So now that you have that, the frequency at a cliff, this frequency at a cliff, please guys, it's not your FS, ne? It is not that FS. Right, why is this frequency not for that FS? Why is that the frequency, not the frequency of the sound waves? Because the bed is moving towards the cliff. I hope you guys understand that part, ne? The bed is moving towards the cliff. So this is not, this guy here, it's not the frequency of the source, because the bed is moving towards the cliff. So if the bed is moving towards the cliff, this tells us that the cliff receives a higher frequency than the one emitted by the bed. Okay, so now I'm going to write it down. Let's look at the problem. What is going on here? We have the source that is moving. So this is my source. This is my source, and my source is moving. And then we're going to have the we have the observer that is stationary. Which one is going to be our observer? The wave reflected off the cliff. Maybe I can consider my cliff as the observer, and the observer is not moving. So the observer, which is stationary. Guys, I don't know how they teach you Doppler effect at school, né? But what my teacher used to tell me is that first thing first, to choose the correct formula to use, number one, write what you know about the source. The source is moving. which is the bed. Number 2, then say the observer. Tell us what you understand about the observer. The observer is stationary. Then, if the source is moving and the observer is stationary, the correct formula to use, let's go to Doppler effect and choose the correct formula. I think when we see this, we're going to remember this by looking at the formulas. So this is wave, sound, and light. So now, this is the formula. Ne? These are the formulas. So because you are looking for Fs, I'm just going to focus on that formula. So this one, let's not think about it. Right. So my teacher used to say, think about this. The source, we said that the source is moving, and the observer, it's what? The observer is stationary. So this tells you that the velocity of the listener is going to be what? 0. So the velocity of the listener, which is the cliff, is 0 meters per second. And then now, if the velocity of velocity of this is 0, now let's talk about the source. The source is moving towards the what? The source is moving towards the observer. So since the source is moving towards the observer, the sign for this one, it will be negative. So if the source is moving towards, it will be negative. So let's go and write the formula, the final formula. I hope you guys understand how I chose my formula. So now I'm going to say that the formula to use is FL. It equals to V on top, because I know that the velocity of the listener is 0. So this will be equals to V over, and then this will be V minus velocity of the source, which is my VB. Why am I saying this is VB? Okay, fine. Let's write the formula first, then we'll do the substitution next. I think everyone will be happy about that. V of the source times Fs. Okay, so now we have the frequency of the listener at the cliff. The frequency of the listener, we just calculated this to be 21,250. So this, when we substitute, is 21,250, and then equate this to say V, we already know, is 340. I'll have 340 on top. This is divided by V, which is also 340, minus the velocity of the source. They said that this source, it moves at VB. So the velocity is VB, and I'll definitely substitute that as VB. Right. Multiply this by Fs, which is what we are trying to find. And then when it's like this, I'm going to say that we make Fs subject of the formula. And how can we make Fs subject of the formula? You know what I'm going to do? First thing first, to think about this, how can I make Fs subject of the formula when I have this? Maybe we can start by multiplying. Maybe we can start by saying 2125 is 2125. 21250. Let's multiply this by the 340. The 340 minus VB, and then let's say on that side we are left with 340 times Fs, because we this is over 1, we just said this times that, and the 1 times that, so this is also over 1. So when it's like this, I can, if you don't understand this part, please pause, work on this problem. Now pause the lesson, work on this problem. So this is 2.1, this is that times that, and this is the 1 times what we have on top. But remember, this is over 1. First thing first, these two will multiply. And then this whole thing will be multiplied by that 1. Okay, so now I'm trying to move slow on that one. Then now we can divide everything by 340. Divide everything by 340. Right, so when we divide everything by 340, what do we get? When we divide everything by 340, so I can see that I'll have fs, these two cancels, and then I can write my fs to be equals to, so now the question said prove that fs it's equals to 2150. I want to teach you this thing to think, because some of the things they just straightforward, man. This is 21250 minus 62.5 VB. So now I know that whatever that I do, I don't have to do anything on this guy. I just have to leave it like that. I need to leave it like that. So I can rearrange my equation and say this is 21250. Then I need to leave it outside. So when I leave it outside like that, inside the bracket, I need to work out on the, come on, how can I, do this, madam? Inside the bracket we'll have 340 minus VB over 340. So I just arranged my equation there. So now this will give me fs to be equals to 21,250. Inside the bracket I can say the 340 divided by the 340 minus VB divided by the 340. Remember fractions, how fractions works. If we have one denominator and on top you are subtracting or adding something, if I have A plus B over C, I can write this as A over C plus B over C. That's what I applied on that step. That's what I did on that step. Then when we keep on moving, I'm going to say Fs now. It will be that 21,250 inside the bracket. This is 1 minus. So if this is 1 minus, I'll have this as VB over 340. What's next? Multiplying out the bracket by that 21. So this, if we multiply out the bracket, we're going to say this times the 1 and this times everything there. Let's quickly work on that, guys. So now this will be Fs, it's equals to, this will be 21,250 times 1, which is just 21,250. Then minus, I'm going to have the 21,250 multiplied by VB over 340. Okay, so what is my Fs equals to? This is 21,250 minus, how many marks is this question? Maybe I'm the one making it more complicated, I don't know. So now this is 4 marks. It's fine, I need that 4 marks. I'll go all this trouble to find the 4 marks. So 21 minus, so now I know that I can just say 21. When I multiply by this, it will be 21 divided by 340 times VB. So I can write this as 21. I'm just going to write it down here. I can say this is 21,250. Divide that by 340. And then multiply that by VB. And 21, what is, if we punch 21,250, we need to get the answer as 62.5. Let's put that on the calculator. So when I put this on the calculator, I find Exactly 62.5. Now I'm smiling. Now I'm smiling. It's a ding ding ding. Guys, sir, you said you don't like Doppler effect, but you are explaining it nice, guys. I just don't like if I don't like it, I don't like it. But to teach it, there's nothing wrong with teaching this topic. I can just make you be the best, né? There's nothing wrong. I just don't like Doppler effect, né? So now let's work on the next question. 5 marks. So this tells me that we're going to work on more calculations. Yes. Another 5 marks. Calculate the frequency of the reflected sound waves detected by the bat. It's 850 Hz, higher than the frequency of the sound waves emitted by the bat. The frequency of the reflected sound waves, the reflected sound waves detected by the bat, it's 850, higher than the frequency of the sound waves emitted by the bat. Calculate the speed of the bat, which is Vb. So let's first analyze what is the question saying, and where are we going to write that? We don't have a space. I'm going to cry. We don't have a space. Should we go to the blackboard? Yes, let's go to the blackboard now. Let's duplicate that. Let's take everything to the blackboard. So I'll go back, read the statement, then come back and write what I understand from the statement. They say that the frequency of the reflected sound waves, the frequency of what? The frequency of the reflected sound waves. So what I'm going to do, I'm going to say F detected, which is the frequency so F, the frequency that is detected, it's equals to, and the statement is saying the frequency of the reflected sound waves detected by the bat is 850 Hz, and that should be higher than the frequency of the sound waves by the bat. So this tells me that this is going to be Fs, which is the frequency of the source, because they said the one that is detected is higher than. So F detected, we need to add that 850 Hz. I hope this makes sense. So from this we know that F detected is equal to Fs by times 180. Please pause the lesson. Make sure that you understand why we are adding those two. The frequency of the reflected sound waves detected frequency is going to be 850, higher than the frequency of the sound wave. So the frequency of S plus 850, because F D is equal to that. F D is 850 higher than the frequency. So it's going to, we take Fx, we add 850. I hope this makes sense. Yeah? So now when it's like this Doppler effect, it happens again. Please, let's go back to the question. Look at this. After the reflection, the cliff acts like a stationary source, and we did write it down. So if it acts as the stationary source, it sends back the sound. So it's going to act like the stationary source, sending what? The sound back. Now the bat is moving where? The bat is moving towards this reflected sound. I hope you guys see. It's even there on the diagram. The bat moves towards that reflected sound. So this tells us that the bird is going to detect a higher frequency. And then what is this? We need to write down the formula for a moving observer. Let's go and write it down. So the formula for a moving observer, we set F. We need to find F detected. And I'll say this is, remember we said that this is V. So if this one, for a moving observer, this will be V plus this time we say VB, because this one is not 0 and this is divided by V. So if we go to the formula sheet, you know why I don't like this Doppler effect question is this choosing, because if the equation that we choose is wrong, we're going to have a lot of problems. You see now? So now look at this. We need the formula of what? The formula of the moving observer. So we need the formula for the moving observer. So now we know that the listener this time, this will be, what are we saying? The velocity of what? Of the moving observer. So now if this is the formula that we use, the velocity of the source, what is the V of the source? Is just 0, because the observer this time is the one that we're going to focus on. So I think instead of Fs, you see why I don't like Doppler effect? Maybe someone might forget to say this is Fl, because we're going to use the frequency of the listener. So what I'm trying to say, this changes and is going to be my F of what? F of D, which is detected. This is F of S, and then we equate these two. On top we're going to say V plus my VL is the velocity of that moving source. So it's going to be VB, it's not 0, over, because we are using the frequency of the moving source, the V detected. And then this is divided by what? This is divided by, this will be 0, and we just divide this by B. But now when we multiply this, make sure that you use the formula. Instead of Fs, we need the frequency of the listener. Right, let's go to our blackboard and write that down, guys. I hope you understand why. You understand the formula that I did. But if you don't get it, it's fine. We still have marks. You're going to eat. Don't worry. So this will be the F detected. It's equal to this formula. Then multiply that by the frequency of L. And then now we can do the substitution. If you still remember we just calculated. We know that F, the frequency of, what is this? The frequency at a cliff, it was 21250. So this is my FL, this guy, the frequency of the listener. So my FL, it's equals to 21250. Okay, I hope everyone is happy on that. So let's do the substitution. So the frequency detected, it's equal to the speed is 340, plus we are looking for VB. This is divided by 340 multiplied by FL. We know that FL is 21250. So now we just have to work this thing out, because now we have two unknown, the two unknown, F detected and the VB, and we are looking for VB. But if you still remember we said the F detected, it equals to Fs plus 850. Okay, so now if it's like that, we can just substitute this on the formula. So where there's F detected, right, look at this, where there's this guy here, we can substitute what? the fs plus 850. I'm not sure if we do it like that, it's going to be the best for everyone, but this is the only way to do this. Now, this is the only way. So when I do this, and I don't think of this, the way I answer my questions, you can get my solutions to be the same as the ones on the memos. I don't think so. But you know what? What I know is that these were the answers that I was giving them, and they were giving me full marks. So Luena, you can do the same, because if you check the memos on past papers, some of the answers are very short, and you'll be confused to ask yourself, where is this coming from? Where is this coming from? So that's why we struggle to study even when we have the answers. We have the memo, and this is the question, but it becomes more difficult for us to study. So what I need you to do, please don't depend on the memo, né? Because there's nothing on the memo. The memo is very short. Where's my SP pen? You see, guys? Okay, so now we can substitute that and say my fs plus 850 is equals to 340 plus VB over 340. So this is multiplied by 21250. Okay, so now when I have it like this, I think this becomes another issue that we can fix it like, then it will be a ding ding ding. So this fs, if you go back to your, let's go back to what we currently worked on. On the previous equation, we proved that fs, let's do this with a different marker. So we proved that fs it equals to 21250 minus 62.5. I never thought we're going to no, we are not wasting time, we are learning. But I never thought that we're going to spend so much time on Doppler effect. So fs, if you still remember, I'm just going to put it down up here, that my fs is equals to 21250 and then minus 62.5 VB. So if I substitute my fs, this tells me that I will only have what? I'll only have VB to calculate. So my fs is 21, my fs will be 21,250 with minus 62.5 VB. Then you add that 850, né? You add that 850, equate this to 340 plus VB over 340, and then this is multiplied by 21,250. You know, I'm busy laughing because now that we are on this step, and then when we are on this step, there's only VB on the equation. We just have to use the algebra. I know that someone who's watching this lesson is like, you know what, sir? I got this. I can take it from here. Okay, guys, it's not easy to get here. You have to think. But now I'm just laughing when making this lesson now, and I'm saying that someone out there now is saying, you know what, sir? Just leave this one up to me, because now I know that I can add this like terms, and then whatever that I get, I can move the VB to the outside. What? Okay, let's try to take this step by step. Now, so let's rewrite this equation down. Then we're going to take it. Then you can take it from here. Then I'm just gonna let you take it from here. So you know what you can do? Pause the lesson. Take it from here. Let's see if you can get the same answer that we're going to get by the time we finish solving the problem. So this is equals to 340 plus, yeah, this is you guys, I'm laughing, you know, like, yeah, okay, so I can take it from here, 21,250. Okay, so now so when I have this, let me simplify the left hand side first. Né? I think I can simplify. I can start by simplifying the left hand side. Or can we start by simplifying the left hand side? Let's simplify the right hand side first and see what we get. So if I simplify the left hand side, remember the 340, we can write as 340 over 340 plus VB over 340, and everything here is multiplied by 21. Okay, let me do this. Right hand side, and then this is 21,250. So this is 1 plus VB over 340, and this is 21,250. So now when we multiply out the brackets, we get this to be 21,250. Is 21,250 plus what? Plus, guys, we multiply the bracket, is going to be like this. I think we did this on the previous lesson. 21 times that is this, and then we say we multiply this by that. I know that this is going to be 6.25. So let's quickly write this down. So this will be plus 6 what? This will be plus 62.5 VB. Right. So this is my right hand side. So let's take this right hand side and do what? Should we equate this to the left hand side? Yes, we can. Let's just say this guy. You see, I'm very sorry guys about the background noise. Unfortunately, where I stay, we just there are no rules, so you can do anything you want, and now no one can say anything to you. So this is the right hand side, and then when I have it like this, I'm going to say equate the right hand side to left hand side. But before we do that, let's add the like terms. I think before we do that, let's add the like terms and say, should we add? Do we even have the like terms? Nope. You know what why I'm not going to do to add them, because I know that these two will cancel. So let's say I have 21,250 minus 62.5. Okay. Let me quickly work on this. Okay. You see, if I was brave, I was gonna just go each and every room and steal like those speakers. Each and every time you buy a speaker, I steal it. Each and every time you buy another one, I steal it, because now I need to teach when you always have your music on. You see, I'm very sorry guys, but let's continue the lesson. So this will be 21,250 minus 62.5 VB plus 850. I equate this to 21,250 plus 62.5 VB. I said you always make your solutions long. Okay, it's fine if I make my solutions long. These 2125 and 2125, they are on different sides. So when we bring the other one to the other side, they cancel. This is what you guys want me to do. Okay, I will definitely do that. The 625 and the 62.5, these are the like terms. So I need to bring them on one side and then add them, because now the one is negative on the right hand side and the one is positive. So when the other one goes this side, it will be positive 62.5 plus positive 62.5. So this tells me that this side I'm left with 850 is equals to, I take this and add with that which will give us 125 VB. Is that what you guys want? Let me give you what you want. Divide by 125, divide by 125, therefore what is your VB? The answer that you get is your velocity. So it's 850 divided by 125, then the velocity, I got 6.8 meters per second. .8 meters per second. And that's it for this Doppler effect. Get in, it's a ding ding ding. Let's see what we have on the next question. Electrostatics. Okay, let's see what we have. Question 7. Start on a new page. You see now? Okay, let's check what we have on this question 7. A small negative, we are given that a small negative charge Q is placed at a fixed distance from the charged sphere Q. We can see the diagram experience a force F as shown in the diagram. The charge Q is now removed. Draw the electric field pattern for the charged sphere Q. So I need you guys to read the diagram carefully, and I'm going to assist you how to read this diagram carefully. So now let's work on this. So first thing first, I'm going to give you guys a lot of notes. So number 1, what do we see about sphere Q? Sphere Q is on the left. So I'm going to write left here, and then small charge Q is on the right. So this one is on the right. That's what we note so far. So now small charge Q is negative. This guy here is negative. That's what we know so far. And then the force on Q is pointing to the left, which is towards Q. We can see that this one, where is this pointing? Left. The arrow is to the left. So now, after reading this this diagram carefully, we need to decide whether the force is attraction or repulsion. So how can we do that? Remember that because the negative charge Q, this charge Q is pulled towards Q, the force is attraction. But if it was going away, the force was going to be the force of repulsion. So the force is attraction. I'm just going to write that down. Because the small charge Q is pulled towards Q, this tells you that this is the force of attraction. But if it was moving away from Q, it was going to say it is repelling to Q. But now it's moving towards Q. This is the force of attraction. Guys, just give me a second. I know that, sir, they said draw. What are you doing? Where are you going? Why don't you just put the drawing? No, I won't put the drawing. I won't give you something that you don't understand. Please make sure that you stay with me on this. By the time I'm done explaining this, everything will start making sense. So remember, so since this is the force of attraction, we know that attraction happens between opposite charges. So the attraction happens between opposite what? Honey, what is this, the spelling of opposite? Opposite charges. Right, I think now you see where I'm going with this. So we said this is attraction, so this tells us that this is opposite charges. So we can therefore say, since Q is negative, therefore we said this is negative, this will make this Q to be what? To be positive. Right. So now we're going to use this information to decide the electric field pattern. So the electric field lines, remember, the electric field lines, they do what? The electric field lines, they point away from what? They point away from positive charge, and they will point towards negative charge. Right, so look at this. Q is positive. So if this is my Q, which is positive, the electric fields, they will point away that Q. So they'll go out of the negative. They'll point away. They'll point away. Give them this drawing, you'll definitely get your 3 marks. But now, why is this 3 marks? Okay, it's fine. It's fine. Just give them, maybe there will be the marks for saying Q is positive, 1 mark. I don't know, but it's fine. The correct shape, maybe there's a mark for that. Straight lines, a mark, I don't know. I don't know how they do this one, but the only thing they're interested in, I think, is the positive and the direction, and that's your 3 marks. Congratulations if you understand this. Now, you have your 3 marks in an upcoming exam, if they ask it in this way. So now let's go to 7.2. Sphere S is attached to the ceiling at point P. We can see that. And then by a light intensity ball string, when sphere R on an insulated stand. Okay, sphere R is on in an insulated stand. We can see the stand then, and then they say that is brought to close to sphere S, they repel, and sphere S comes to rest with the horizontal distance. So they think that they bring this close to that one, then they repel. This one goes in another direction. This one goes in another direction. So I'm just gonna, I feel like I'm moving fast now, right? Let me underline the word repel. Okay, so they repel and sphere X comes to rest with the horizontal distance between the center of the spheres is 0.3 meter. We can see that sphere R is directly below point P. The string makes an angle theta with the vertical as shown in the diagram. State Coulomb's law in weight. Do you guys want me to state Coulomb's law in weight? It's fine. Come on, guys. Coulomb's law. The magnitude of the electrostatic force exerted by one point charge on another point charge is directly proportional to the product. Guys, I'm just gonna give it to you in weight. I'm very sorry. Please go to consult your exams guideline. So F is equals to Q1 Q2 all over R squared. And then if I still remember the formula correctly, this should be K. Right, this is Coulomb's law. So we are saying the force is directly proportional to the charge and inversely proportional to the distance between them. That's Coulomb's law. Let's work on 7.2. Let's see what we have on 7.2. They say draw a labeled free body diagram showing all the forces acting on sphere S when it is at rest. So this sphere S, it's not moving, it's at rest. So now they said that if we go back to the repelling weight, they said these two guys, sphere S, they repel. So now if they repel, this tells you that for S, the electrostatic force for S will move in that direction. So this is the force of electrostatics. Let's call this Fe. And then now this F has that, I'm not sure if we can call this the rope or we can call this the tension. Do we have the rope? Maybe let's use that for tension. But remember, the sphere S, it will definitely have a what? The weight of Fg. So if we draw a free body diagram for that guy, if we draw a free body diagram, the free body diagram will look like this. For 7.2.2, the free body diagram will be electrostatic force in that direction, and then the tensional force going that side, the weight going down. And that's it for this question. Is it 3 marks now? So a sphere R has a charge of positive 6 nanocoulombs. So this is positive 6 nanocoulomb, and This one has positive 3 nanokilo. And the mass, this mass, it's what? I'm just gonna convert that just to save myself from forgetting converting the mass. The mass should always be in. The mass should always be in meters per. What is this? In meter. So what is this? How do we convert from? How do we convert from grams to? It should, the mass should be in kg. Ne? The mass should be in kg. So I'll take that 0.15. The 0.15 I'm going to divide that by 1000. Ne? From grams to kilograms we divide by 1000. And what do we get? Am I right when I say we divide by 1000? Yes, we divide by 1000 from grams to kilograms. Then we're going to divide that by 1000. So if we divide by 1000, we get this as 0,00015. So that is my grams in kg. Get in. So now the question says calculate angle theta for 5 marks. So go back to the diagram, try to understand what is angle theta. This is my angle. So now when you have this type of question and you want to find angle theta, make sure that you use this 3. Please listen to this. Ne? What I'm giving now is very good. Ne? Use these 3 forces to create what we call the vector diagram. Then on the vector diagram, make sure that it is that theta inside. So I'm going to teach you how to do this. Ne? I'm going to teach you the easiest way. Look at this. FG is going down. Ne? So since FG is going down, this tells me that I can move this FG here and take it from that point P and write it down there and say FG is going down, because I need to create head to tail method. Ne? And then FE is going in that direction. Remember we said from vector head, when we use vector, the arrows that you see on the free body diagram, they will be the same on the vector diagram. They will point in the same direction. So now this tells you that we need to take this point. This is the starting. If you still remember what we did on, was it the yesterday's lesson or is today? What is this? This is physics, no? Let's quickly go back up. I think we did something like this. I'm not sure if it was our previous lesson or this is the lesson. Okay, I guess it was our previous lesson. Or is this? Oh, get in. This was on the multiple choice question. This was on the multiple choice question. Remember what we talked on the multiple choice? Each row must start where the previous one ends. And then the last vector must bring you the starting point. Let's go back. Guys, I'm sorry when I say it was yesterday, today, because remember I'm not taking like one day to record this lesson. As you can see, if you can check the time, these are different times. So I take breaks and so on. Right. So when it's like this, let's quickly work on this. So you know what I'm going to do? I'm going to say that, the FE should be on top of that arrow there, and it's point in that direction. And then this one, the head of the tension, should be on top of that one, and then it will go in that direction. So can you see that the arrow takes us where we started at that point? It takes us where we started. So now when it's like this, I know that this will be my hypotenuse, which is, this is 90 degrees now. So this will be my R, and then if this is my theta, this will be my X, and this will be my opposite, which is Y. So let's quickly work on that. Ne? Let's quickly work on that. I'm just going to move my diagram here and redraw my diagram. So I'm going to say I have the force of Fg going down. So this is my Fg. Then in that direction, this is my electrostatic force. Guys, you are lying. I make this easy. Ne? And then this is what, this is my tensional force, and we said this is angle theta, this is 90. So we'll refer to that diagram. So now they said that they want us to find angle theta. So I think when I look at this diagram, can I find tension? It won't be easy for me to find tension, but it's easy for me to find this guy because it's the electrostatic force. I can use the electrostatic force formula to find Fe. So what I'm saying is that I can use the electrostatic force and say that Fe is equals to the formula for electrostatic force is K of Q1 Q2 over R squared, and we are coming back to that. Let's just leave it like that. We can find this guy easy, and we can find the weight, which is Fg. So we can find Fe and we can find the weight as mg. I think we can use what? We can use opposite, which is y, and adjacent. Then we'll go to SOHCAHTOA, or you guys call it SOHCAHTOA, whatever. The most important is not to pronounce it, but the most important thing is for you to know how it works. So we say that we have y, which is opposite, and we have x, which is adjacent. So we're going to use the one that has O and A, which is the tan. So this tells me that to calculate this guy, I need to use the tan of theta is equals to opposite, which is y, and my opposite is Fe. Divide that by what? Divide that by my adjacent, which is Fg. So now this tells me that I know what I need to do. My next assignment or my next mission is to find Fe and Fg. That substitute that, then solve for theta. Let's work on that next. So my Fe, what is Fe equals to? So Fe will be Fe, it's equals to, let's write this down. What is this question for? 7.2.3. So this is 7.2.3. So Fe is K. We know that this is a constant, which is 9 times 10 to the power 9. Close the bracket. Q1, the first charge, it was 6 nanocoulombs. Remember, if it's nanocoulombs, we multiply that. So if it's nanocoulombs, we multiply by 10 to the power negative 9. So we need to take the 6, multiply that by 10 to the power negative 9, close the bracket. I think we don't have much space, so what I'm going to do, I will rewrite my equation. Okay, let's rewrite that equation now. Okay, so we are saying that Fe it's equals to, I'm trying to make sure that it fits here now. Fe it equals to 9, which is K, times 10 to the power 9 times 10 to the power 9. Close the bracket, then this will be 6 times 10 to the power negative 9. Then the second charge is this one, 3 nanocoulombs, that will be 3 times 10 to the power negative 9. Close the bracket. Then everything is divided by the distance between them, which was 0.03. Right, so this will be 0.03, and the 0.03 is squared. So what is Fe when you punch that on the calculator? I know that most will struggle to put this on the calculator. I'm also putting this on my calculator. I have 9 times 10 to the power 9, 6 times 10 to the power minus 9 times 3 times 10 to the power minus 9. Everything is divided by 0.032 squared. So I get my answer as, if I put this in scientific notation, it's 1.8 times 10 to the power negative 4 newtons. So this is my Fe. So now that we have Fe, what is the next mission? Is to find the weight. So Fg is equals to mg. So we're going to use the mass that we just converted, which is 0.05. So I don't think, even if you put this in scientific notation, you can write that as 1,5 times 10 to the power, how many zeros do you have? 4. So it will be 1.5 times 10 to the power negative 5 and negative 4. That is the mass. So when it's like this, we can substitute and say Fg is equal to the mass of 1.5 times 10 to the power minus 4 times g, which is the gravitational, which is 9.8. So what is your Fg equals to when you put that on the calculator? Oh, by the way, this is the last question. This is the last question. So Fg is equals to, when I put this on the calculator, I get this to be 1.47 times 10 to the power negative 3. So basically it's 0.00147. So this is to the power negative 3 and it's in newtons. Let's substitute now to find theta. I think this makes sense. I think everyone is happy on how we got the Fe, and I think everyone is happy on how we got that Fg. Right. So when I have it like that, I'm going to say that the tan of theta is equals to, I'm not sure since this thing is in scientific notation, should we move it down here? Let's move it down here. We said that the tan theta is equals to Fe over Fg. So let's substitute. The tan of theta will be, what was Fe? We calculated Fe to be 1.8 times 10 to the power minus 4. So this will be 1.8 times 10 to the power minus 4. Divide that by, we set Fg, it's 1.47 times 10 to the power minus 3. So this will be 1.47 times 10 to the power negative 3. Therefore, when we have this, I'm just going to leave it at this and say theta, it's equal to the tan inverse of everything. The tan inverse of that 1.8 times 10 to the power minus 4 over 1.47 times 10 to the power negative 3. Right, so when it's like this, what is angle theta equals to? So the angle theta, it's equals to, let me quickly put this on my calculator and see what I get. Inverse 1.8 times 10 to the power negative 4, everything divided by 1.7 times 10 to the power minus 3, and this gives me theta of 6.98 degrees. And that's it for this question. This will be the last question for this question 7.